And we are live with our first ever virtual conference for Absolute AppSec, a MidSummer's Night Con. I'm your host and one of the co-organizers, Ken Johnson, at CK Tricky on Twitter, joined by my co-organizers. Let's bring them all up. So we've got from left to right, I guess I should say, Stefan Edwards at Logical. And we've got at Seth Law on Twitter, Seth Law. Seth, say hi.
Hey, everybody. Welcome back to our first episode. Well, our first episode of a MidSummer Nights Con, I guess. Isn't this the point where I take over, Ken? I don't remember, right? We're excited that everyone's here, right? Yeah, this is going to be fun.
It's an experiment, and we're excited to do it.
Yes.
And last but certainly not least, and a huge help in this process, at infosec Anon, Heather Lawrence. Heather, say hi.
What's up, guys? Gentlemen.
So you've been instrumental. Stefan's been instrumental. Everybody's really come together. This is going to be a fun afternoon, evening, I guess we could say. We are going to start. So for our schedule, you can catch it online, and just a couple things ahead of jumping into Stefan's talk, the first talk. You can chat on the YouTube live chat with us. You can communicate on Absolute AppSec Slack. That's the invitation link is on absoluteappsec.com. So those are the two primary ways, and we'll moderate and make sure that we get those questions that we can answered. But we do obviously have time limitations, and then I think beyond that, I don't think there's anything. Seth, did I miss anything before we kick it off?
Nope. Let's do it.
I don't know if we can say I was instrumental if I just caused everyone a whole bunch of pain in organizing these sorts of things.
Okay. Stefan. That's about how this always goes, right?
And there's a story about why we're doing this, but I'm gonna back away from that. But Stefan will get to it here in a moment. So there's a story why this all kind of came about. So it should be fun. So are we ready to kick off?
Sure.
Yeah.
All right.
Let's see. Did I do this correctly? Wait, no, it's this one, right? No, this is the best one. Okay, perfect. So thank you very much, everyone, for coming. This is going to be a rant talk. Like Ken mentioned, there's a whole reason for this talk existing. But basically, I wanted to go through some very interesting points on software composition and how those things tie into security. So basically, I'm going to rant about some of the things that I think that we have had access to in software composition, in software engineering, in computer science, some of those things that we have absolutely known to be true for years and just haven't done for a variety of reasons, and maybe surface some of these things for new audiences, maybe talk through some things that folks are not familiar with, and then intro some of my favorite areas within software composition, within programming language theory, those sorts of things. And finally, hopefully, if this all goes well, considering that I put this talk together today, ties back in with the point of we can secure things via these mechanisms. Helps if I also switch to the correct window. So I will be talking through a number of different things. I basically want to walk you through why I think these things, what are the four areas there. I want to talk you through some takeaways. Like if you learn nothing else from this talk, what can I take away from these sorts of this rant, and how can I apply them to my area of especially application security? But really, if you work anywhere now in cloud, in SDNs, in software-defined networking, any of those areas, you probably can at least take some of these things away and really attempt to understand your area and understand the things that you're working in just ever so slightly better. I'll define what I actually mean by software composition. I don't think I have a strange definition of it, but it may be a little bit more nuanced than you're used to. I'll talk through some other notables that I think of when I think of these sorts of problems in programming language theory. in software composition, those sorts of things, and also areas that you can look for these sorts of people and look for papers that I thought were interesting. And then I want to walk through 4 really high-level areas. I want to walk through what Grace Hopper was attempting to do when she first started studying these like software composition, compilers, how do we break down languages, how do we break down problems, etc. I want to talk through Peter J. Landon, especially the iSwim paper. If you see what I mean, is a fundamental paper, and we'll talk through why. I want to talk through what Barbara Liskov did with the Liskov substitution principle, and I want to talk through multics. I think most people have heard of multics. Most people have maybe seen some things about multics. Maybe they've been curious about the historical antecedents to operating systems like Unix, but they haven't really necessarily looked into why. And I'm going to talk about what I think were the important things that we as software security folks and then the security community at large can take away from what multics actually did. And then, because there's nothing that says logical like some hubris, I want to talk about what I think are the next 700 security tools to come. And some of these already exist. Some of these are just coming out of the research community. Some of these things are being talked about in papers. But I wanted to walk through what I think these sorts of things will do, especially vis-a-vis the 4 areas that we talked about today during my rant. And if you don't know me, and I've obviously been on Absolute AppSec a number of times, but my name is Stefan Edwards. I'm a practice lead at Trail of Bits. I go by a Twitter handle of Logical. You can find me on GitHub, on Lobsters, etc., all sorts of places. But basically, I work in software security. A lot of what I do at Trail of Bits has to do with programming language theory, with threat modeling, with understanding risk, with applying many of the more academic or more nuanced things to everyday software, everyday security. I usually have this sort of slide. I am very hard of hearing. I'm also from New York, but I think it'll be a little bit easier with a virtual conference and people can type things in. So, as Ken and I both alluded to, there's an actual reason why we wanted to talk about this sort of thing. Ken and I were riffing in chat, as we often do. And he said this: I want a history in software composition and the securing thereof. And it basically cascaded from there. I looked at that and I said, oh, that's really cool. There's all sorts of things we can do with that. There's a whole bunch of stuff that we can take out of this, etc. We went back and forth. And then we thought about things that maybe Ken can talk about. And then I got Heather involved and it just exploded from there. So if we have a why for this talk, but maybe this entire conference as well, there's a lot of historical research into languages. There's a lot of historical things. And if you've seen any of my other talks, or if you've heard me rant on Twitter or other places, you've seen me talk about things that we've lost. So for example, one of the things that I always like to bring up is that I've talked with folks who maybe work at large storage companies, and they'll be working on maybe copy on write file systems. They'll be working on new ways of doing things. And I'll say, oh, you mean like what OpenVMS used to do? So there's all sorts of historical things that I, as Logical, as someone who's super interested in more of the historical side of languages and the historical side of computing, actually find interesting. So I wanted to go through and take some of my favorite things in languages, in the history of computing, in software composition, and just kind of shine a light on them. But also, I really just wanted to rant. I think it's always fun when I can get up here and rant, talk about things that are interesting to me, surface a bunch of things. And if this talk explodes horribly on me, it's because I did go up here just to rant. And then obviously we can have some more fun with the comments because we can trash talk all the things that I missed. But I think if you're going to take 3 things away from this talk, and those can be any 3 things, I would really like you to take these 3. We've been thinking about how to compose software since at least 1951. We'll talk about Grace Hopper's techniques, but there were a number of folks working in what we consider modern compilers now. This can go back all the way into the 1940s if you consider Conrad Zuse and his plan Calcul, excuse me, pronunciation is hard. But there's a number of things that we've been working on since at least the 50s that I think still apply today. And some of these things are just ways of thinking, they're modalities of processing software, but we have these historical antecedents, and I hope to surface some of these for you. And again, many of these same things that we see from Barbara Liskov, that we see from Grace Hopper, that we see from how the Multicians approach things, etc., they're directly applicable today. I'll get into it during the Multics section of the talk, but I do think that many areas that we saw in Multics, that we saw in the way that Multics was attempted to be secured, are many of the same things that you might see from Trail of Bits' audit of Kubernetes, or from a modern evaluation of a new operating system. And I wanted to also surface 4 things that are maybe lesser known areas, or maybe areas in software engineering and computer science that I find fascinating that the wider security community may not actually know. And when you hear me talking about software composition, I have a slightly spicy take. I've talked about this on Twitter before. Artem and other folks have seen me talk about this. I really don't think that things have changed all that much over the years. Niklas Wirth had a talk, or an actual book. It's been used since at least 1976. And he talks about a very simple approach to designing programs, which is you choose a set of algorithms, you choose a set of data structures, and that combination, that bespoke mix of things is actually what gives us programs. Now, there's obviously a whole bunch of things in there that we also have to think about. How we choose algorithms might be played up by how we model our risk, or how we actually approach other things within our application set, accessibility, user experience, etc. So there's a large number of things that we may see, but I think there are probably 3 main topics that we would want to talk about. Those are function or code composition. Basically, how do we plug in code that we've written? How do we take all of the stuff that we've put together and compose them into a simple, straightforward, and easily processed way? This also ties back into the sorts of data that we actually present to a program, present to users, to secondary systems, etc. So the way that we design our data, the way that we consume our data, etc., also plays into how we actually compose our software. Very frequently, when we think about software and when we think about security, we are thinking in terms of software, but we're actually discussing solutions in terms of data and in terms of consumption. So I think they actually go hand in hand. And then obviously visibility. And when I say visibility, I mean it at the programming language theoretic level. I mean it at the at the actual data hiding level, at access control, authentication, those sorts of things. Visibility is a number of things that we basically have to approach when we're thinking about how we compose software and how we actually secure it itself. So I thought there would be a very simple example of this. Most people will look at this and they will probably wonder why the hell I'm displaying this on my screen, right? We'll be looking through and seeing something that looks kind of complex. Maybe if you've seen Scheme before, you maybe can figure out what this does. But basically, Oleg Kiselyov, he's a very famous functional programmer, works in a lot of interesting areas. There was a mailing list question of how would you do an object system in Scheme? And he came back with this very simple definition. So you have a 2-dimensional point. You want to define some accessors, such as a get X and a get Y. You have some setters there, so you might want to set a new X and a new Y. And then you basically have a dispatcher. Now, if you think about this, that's all you really need to do in order to have an object system. You need some mechanism for holding your X and Y. You need accessors for it, right? We can get the X and Y out of an object. And then we basically hide it all. We hide visibility to this entire thing through a Lambda, through a closure itself. So we enclose on an environment. We hide X and Y. We allow users to introspect those things via accessors. And then we basically give them a mechanism for signaling when, hey, maybe you've actually done this sort of thing. Now, this is fairly complex. I think most users, if they were presented with software that looked like this, they would probably run away screaming. And that's usually the case when we have these sorts of like abstraction breaks or issues with the way that we define things. Now, I chose something else. This is another semi-esoteric language. Not everyone works in this language. And this language is OCaml. But I think most folks who have some background on programming languages and have some understanding of the way that classes and data structures and data hiding works can read this and understand what we're doing. We have a two-dimensional point object. It takes two parameters, x and y, and then we define methods for those and types. So we know that x and y are floating point numbers. They're basically decimals. And we know that we need accessor mechanisms for this x and y. Now, in terms of software composition, they actually achieve exactly the same thing, right? When we want to define something in Scheme, and if you were actually writing in Scheme, please don't use the example that I used here. There's all sorts of better ways of doing this, like SRFI 57. But you can use these things, right? We have a data structure with 2 points. We know how to access those sorts of things. And those things are not actually accessible outside of the scope or the visibility that we've defined. If you think about it, if you wanted to modify how the Scheme system worked, you could easily change the visibility. You could easily change the scope. And you could make sure that certain things actually work in different ways there. So there's a number of things that we have that we absolutely can control. However, the mechanisms of doing these are very different. Scheme uses a closure. There's some dispatch. It uses symbols. We use environment capturing. Basically, we use binds to capture the x and y values. We use those closures, capture them in the environment. And whilst the OCaml is probably not familiar to everyone at the conference, or it's not the most the most common mechanism for defining these sorts of things, if you have a background in Java or Scala or Ruby or any of those sorts of languages, you can look at that and mostly understand what it's doing. And indeed, we actually have very different mechanisms for using these sorts of things in some ways, right? In terms of the Scheme system, we get an accessor and we provide it with a symbol to say get x, right? We have some foo, we define a make point, and we pass this in. And then in OCaml, we actually have a very simple accessor itself. We just say pound x, that gives me the x value, or pound y, give me the y value, right? So we end up with exactly the same semantics of what we want via very different mechanisms. Now, there's an interesting difference between the two of those, right? The way that we have these, the way that we define things in our languages actually shapes the way that we use them. I know this is sort of getting towards Sapir-Whorf. This is sort of getting through some things that are, a little bit more tenuous. But basically, the things that we provide to users via our languages or via the tool sets that we provide actually shapes the way that users use systems. You absolutely can have an object system in Scheme. You use a series of closures, you provide things back, and now you have an object system. Similar to JavaScript, how many of us have seen prototypical inheritance in JavaScript, seen things that try to break prototypes and make them into a class system, because that's the sort of tools that you have. And the things that we provide in our languages influence the way that we specify software, the way that we test software, and even the tooling. If you think about it, if I accidentally change this to get m, the Scheme compiler itself would have no mechanism. There obviously are ways of doing this, but the Scheme system would have minimal mechanisms to actually understand that I mistyped get m and now am going to have a runtime error within the system because I have processed this. However, if I change this to m, the Scheme system, the OCaml system absolutely at compile time knows that this should not be an M, and that this will actually fail and can warn me about it. So the languages that we provide actually influence the sorts of toolings, the sorts of tests, everything that we can do about it. And my spicy take to this is that most security actually falls within these boundaries. Now, I am obviously going to expand on that, and I think there are more things out there than actual program analysis or those sorts of things. But I think most things fall into, we have issues with specifications, we have issues with testing, and we don't have tools to actually process and handle those sorts of things. And we are not, as security people, as programming language theorists, actually providing those sorts of things back to developers to actually use. Now, I thought this was funny. I tweeted about this on Twitter, but as I was researching this talk yesterday, as I was writing this talk today, I ran across this blurb in the UNIVAC programming manual. So this is from 1953, and I absolutely love this. And it says, the programmer must be adamant in requiring a complete description of the problem, of the input data, of the form and volume of the desired output data, as well as of the computational or processing steps to be performed. Now, if you're a programmer, if you're a security person, if you're anyone who deals with computers at all, when was the last time you had any of those things? Yeah, and yes, at Trail of Bits, we obviously work with clients who do have those sorts of things. So it's not necessarily so different from my experience. But when I worked at previous companies, when I've worked on certain projects, even here at Trail of Bits, it's very clear that we do not have complete problem descriptions. And that's not a developer failing. That's not a business failing. That's a holistic failing that we're not providing these tools, and we're not providing things to actually do what the UNIVAC manual here calls problem analysis. And obviously, this talk is very LangSec focused. I am absolutely 100% guilty of being in LangSec, of thinking about things in a language security theoretic way. I understand these things. And I'm not trying to advocate that every single problem is a nail, because all I do is look at things as a language security hammer. However, what I am saying is that I do think many of these problems stem from the same root, and we do have processes for handling these. And I do think LangSec, or things that focus in that approach, do have some of the answers that we might want and need. Now, there's a number of things that I can't rant about during this talk. I think there's a number of things that are extremely interesting. John McCarthy is fascinating to me. If you're interested in the history of programming, or if you've dealt with protocols, you've worked with John Bacchus's work a number of times. I think there are some notables in this list, however, that folks are not nearly as familiar with. Frances Allen, she wrote one of the seminal papers on compiler optimization, on program optimization. And to this day, I would say you could probably get 70 to 80% of a modern optimizing compiler from the work that Frances Allen laid out in the 70s. So there's a large body of work that allows you to get fairly decent optimization results from a paper that most people have not read. Margaret Hamilton, she was the Apollo lead. There's a number of interesting things that she did in her work during the Apollo program to actually compose software, and the way that NASA works is incredibly fascinating. Going down to the line and the reason why a bug was entered, that all started with Apollo, and then later was actually brought in as part of this language down here called HAL-S. And another interesting luminary on this list is Luca Cardelli. If you're interested in programming language theory, it behooves you to read a large number of things that Luca has written. He is one of the kindest people that I have actually interacted with on the internet. He helped me when I was a small child just getting interested into programming language theory. I asked him all sorts of stupid questions. But he also wrote a number of seminal papers on compiling ML and compiling languages like Oblique and Modula 3. And they're extremely fascinating if you're interested in the history of compilers, if you're interested in the way that things work. It behooves you to read everything that Luca Cardelli has worked. And then obviously there's a number of other luminaries here. If you're familiar with the history of Unix, etc., you know most of these folks that are here. My other favorite here is if you have a chance to read what Tony Hoare considers his billion-dollar mistake. So let's talk about Grace Hopper. I think most people are very familiar with Grace Hopper. She is a luminary in the programming world. She did a number of interesting things, but she's obviously famous for bringing COBOL to the front, right? And COBOL is a business language. It's often derided, but at the time that Admiral Hopper was actually working on COBOL, there was a real reason why we were doing these sorts of things. I'm not going to actually focus on that so much. I want to focus on what is called the A0 system. A0 is actually a set of languages that Grace Hopper worked on, and obviously teams within the Navy, within IBM, within a few different places at RAND, etc., worked on. But basically, these were the first steps towards modern compilers and actually understanding user experience and developer experience when working with low-level systems. Now, A0 was basically written in 1951, and it allowed a very simple thing. It allowed someone to no longer have to remember how the UNIVAC worked. If you haven't researched UNIVAC, it's actually fascinating. UNIVAC did not use binary directly. It actually used a thing called binary XS3. So if you wanted to encode the number 1, you would take 1, add 3 to it, end up at 4, and now you have what UNIVAC actually used for binary. So if you're programming at that level for the UNIVAC for systems of the similar vintage, you were literally writing octal, you were literally thinking in binary and coming up with ways of encoding these sorts of things. And Hopper realized that this was an incredibly painful way to work. And so she started on a series of simple abstractions with A0 to actually fix those sorts of things. Now, this is a comment from Jean Semet, also another great computer scientist. But what Jean is pointing out here is what Grace Hopper did in Flowmatic, which was B0, and other languages, was basically to realize that there was a common vocabulary that developers were using and then not able to codify into the languages that they had at the time. So if you take anything away from Grace Hopper's work, her history, etc., it would be this, that there is a large number of things, and that level of abstraction is what we need to find and what we need to pinpoint. Now, she worked in a very restrictive environment, right? UNIVAC had XS3. You needed to use 9's complement to codify things. We had to map decimal to binary for any single operation, codify things to use octal, etc. Or, and this is crazy, we could write something that says, hey, compare product number of A with product number of B, and if A is greater than B, go to 10. So no longer are we trying to think of, the comparison operation is actually this one, and we have this location, and remember that we actually need to encode 10 with 9 complement and XS3 notation, etc. Now we can just say, compare these two product numbers, and if one is greater than the other, go to number 10. So if we take anything away from what Grace Hopper did, what we were thinking about here, it's this. We need precise abstractions. And I know that sounds strange, right? How can you abstract something precisely? But there are mechanisms for actually understanding what your users, what your developers, etc., actually are doing with your languages and actually are doing with your systems. And then we can actually encode those in an abstraction that allows us to actually precisely understand what's going on here. And this simpler mechanism, this simpler case, actually allows us to surface bugs faster. We have a mechanism by which we can actually see things in a simple environment, and we can obviously read the code much faster because it's written in English here. But if you know and you're a subject matter expert, you can actually work through these things in a simpler fashion. And it led obviously to many advancements within the space itself. Now, I also want to talk about Peter Landin. He also programmed the UNIVAC, and of the two people, he's Grace Hopper and Peter Landin both worked on UNIVAC. So that's an interesting thing to note, I think. But Peter Landin also created a large number of things that we in programming language theory, in spaces that touch programming language implementation, probably have some level of familiarity with. So if you've ever heard a programmer define something as syntactic sugar, that was actually defined by Peter Landin in a paper called the Shape of the Next 700 Languages to Come, or the Next 700 Programming Languages to Come. And this is very often called the ISWIM paper. And that's what I want to focus on here. So my spicy take is that ISWIM should effectively be required reading. And this is a paper from 1966. And within 10 pages, he defines an abstract machine. And abstract machines are basically simpler computers that allow us to review them, to work through the actual semantics of what a program is, etc. He defined this very simple machine called the SECD machine. He also defined what in modern parlance we would consider an intermediate representation, basically a mechanism for transiting from what the program semantically means and what the syntax of the program is. There's a few other steps in between. He also defined a new mathematical-like syntax. And if you've seen languages like Haskell or Standard ML or OCaml, those sorts of things, they actually trace their lineage back to what Landin was doing in the ISWIM paper. And he also defines the correspondence between what we write, what we physically write, the textual review of ISWIM, all the way through to the end resulting program semantics in about 10 pages. And there's also some interesting commentary back and forth between Landin and several other famous computer scientists at the time. But basically, within a 10-page paper, he's defined many of the things that we today take for granted when we're working in programming language theory. So why is this actually interesting to us? SECD defines a very simple machine that's easy to target and easy to analyze. So if I am working as a developer and I wanted to work on a new programming language, or I wanted to analyze a new language, I could compose to SECD, and now I actually have all of the tools that work with SECD, all of the understanding, my mapping of semantics, etc., to this simple machine. I now have that abstract level, and I can go from there. And I say this as someone who has actually done this. If you've ever seen any of my work in digamma, it actually later targets an SECD machine because I was trying to analyze it in a similar fashion. He also worked on a mathematical syntax, which was easier for subject matter experts to write, right? If you're familiar with the way that mathematicians use like the where clause or those sorts of things, Peter Landin noted that mathematicians and folks who work in maths actually would want to write, and then made sure that there was a syntax that actually transited that way. And then he also worked on a clear transition between all of these states, and honestly made one of the first real functional languages and its application. If you read the paper, you'll note that he says that there's a few industrial things. But what I thought was interesting was actually the conclusion. Obviously, there's a whole set of things here, but Peter Landin actually goes through that through the process of understanding how we communicate with computers and how that ties in to the way that we analyze our programs, the way that we physically write and store our programs, and then actually go through the processes of transitioning from this high-level representation to machine level. And obviously, I don't want to spend time reading through this, but I do think that this is the meat of what is interesting about ISWIM. There's so many interesting things in a small, very easily understood 10-page paper that you can go through and actually start to understand what was being done here by one of the most famous computer scientists in programming language theory. So if you take anything away from Landin, or if you're interested in the sorts of things that I'm thinking for Landin, I think what we actually need is a clear method of composing and decomposing software. That's it. Landin laid out and defined a large mechanism and a large body of things that we can actually start to understand and decompose our software with, and then actually take those better definitions and better tools and start to understand our flow of correctness, our flow of program semantics, etc., just from these very simple rules that he defines in the Icewind paper. Now, Barbara Liskov did not program the UNIVAC. She's just slightly after that age group, but she actually was fascinating for a number of areas. Obviously, she is also one of the first women to earn her PhD in computer science in the United States in 1968. She worked on very early OO languages. So if you're familiar with the history of programming languages, she worked on CLU. She worked very closely with John McCarthy. But the thing I'm interested in is actually what's called the Liskov substitution principle. And we'll talk about this. But the Liskov substitution principle is effectively a subtype relation. And I don't want to get into what that actually means, but basically Liskov understood that there was a mechanism by which we can actually take a very simple set of rules and tie these rules together in a subtyping arrangement such that we now have a relationship to Hoare logic, which is a mechanism for actually understanding software and processing the actual requirements of what a function may use, etc., or similar construction to what Bertrand Meyer had worked in with his design by contract. So we have this very simple substitution or subtype relationship that most folks can understand. And now by tying those two together at a tight theoretic level, we actually can see a number of things here that are extremely fascinating. So what do we actually get from this, right? We are now able to understand and approach from the OO level, from the object orientation level, or from a Hoare type theory level, or those sorts of things. We can actually understand the actions that a supertype allows and the actions that a subtype allows, and then start to analyze and decompose our software in that way in order to better understand what we're actually looking at here. And I found this as an interesting example here. We have a superclass of bird. We have a set of actions that maybe flying birds can take, but then we also want to have things that maybe cannot actually do what flying birds can actually do. So this is a fascinating decomposition, but still based on the way that object orientation works, that extensions work, abstract types, etc. work, we now know based on Liskov's substitution principle or subtyping relations, we actually know that we can use ostrich anywhere that we can accept birds. We can use ducks anywhere that we can accept birds. But then we also cannot use ostriches in anywhere that we would want a flying bird, because an ostrich is not a flying bird based on the rules that we've set up. So we have a general concept that is extremely simple. And yet we can take that and codify many different things there. We can codify correctness of access. We can codify correctness of actual use, modulo some notions of decidability. And there's no real theoretical underpinnings to this that are complex to the normal user. You could show this class or this series of classes to almost any Java programmer, and they would effectively understand why you were doing these sorts of things and what the breakdown is here. So Liskov and the substitution principle actually brought us to this. Now, the last area in the history of software composition that I wanted to surface was Multics. Multics is the predecessor to Unix in some ways. I'm sure Unix Ninja and some other folks would take umbrage with this, but the folks who were working on Unix originally were working on Multics and then wanted a simpler system. And Multics is basically a mechanism for providing utility-like computing systems. Some might even say cloud computing systems. I will definitely take that spicy take. But basically a mechanism for having these sorts of things within a single operating system from effectively 1969. Now, there's earlier antecedents to Multics. It started out in 65 with definitions, but basically by 1969 and later by 1974, we had many of these things available in a simple system. Now, think through what Linux is. Think through what modern operating systems are. These were pioneered and started mainly in Multics. And there was even, and if you're interested in the way that we relay security findings and we relay security processes, it behooves you to actually read this Multic security evaluation vulnerability analysis from the Air Force Tiger team, which we now would probably call a red team. But there was a series of evaluations against Multics and its security, and this was fed back in a security engineering loop. So if I wanted to have a spicy take on this, and I obviously am known for this, it's that I'm putting forth this like 10th rule of cloud computing, which is a spoof of Greenspun's 10th rule. But I really do think that every cloud computing system is effectively an ad hoc, informally specified, etc. system of half of what Multics provides. And if you really think about it, Multics was aimed at providing utility computing servers with secure definitions written in high-level languages, with security evaluations by cool people. And it's effectively Kubernetes, or what we see in GCP, or any of these sorts of things. And it codified a rich environment for sharing, for actually processing data with strong security and a built-in database, right? The entire system was underpinned by a secure relational database called MRDS. And these are all things that we struggle with today, right? Think about how often you want to talk about something and you're thinking about mandatory access control versus maybe role-based access control. You need instrumentation, you need auditing, you need ease of access. Multics actually handled all of these things in the late 60s and early 70s. And yet we don't talk about the way that Multics did it. And if you are going to look into these things, I do think it behooves you to review what Multics did so you don't repeat some of their mistakes. Now, why did I talk about all these things? And obviously, I'm butting up right up against time here. But if you start to look at these sorts of things, and my hot take will be that we're going to have holistic, misspelled environments that actually allow us to process these sorts of things and really no longer separate out specification, language, data, etc. These things will start to coalesce into single tools so that we're no longer attempting to look at what does this look like under this specific environment. We're starting to look at these sorts of things holistically from the almost a program analysis fashion. We're not separating out the sorts of things that we're doing out into different things. And I think systems like cyber reasoning, like symbolic executors, especially as we add things such as fuzzing and whatnot to symbolic executors, we'll start to see more systems that are spread out and applied more widely, such as those sorts of tools here. And I go through and I actually decompose these. I know I'm right up against time, but I do think that we need to, with each one of these, with Hopper for understanding our precise abstractions, for going into actual designs, to land in with very simple tools and a very simple mechanism for mapping our current environments through to those tools, to what Liskov does with more type theory and more tools for these sorts of things and more specifications, and all the way to the multicians, that we have these great environments, we have these holistic environments, and we need these rigorous definitions and security guarantees and things like Zelkova or other mechanisms by which we can start to analyze and really struggle with our environments from a holistic and centralized fashion. So obviously, I'm right up against time. That was the end of my rant. I can take questions via Twitter or via Slack. But thank you very much, everyone. It was an absolute pleasure here. And I will switch back.
Thank you.
Perfect.
Thank you so much for that awesome talk, Stefan. That was exactly what I was looking for.
Yeah.
That was definitely a blast from the past.
Yes.
As Seth alluded to, we now all have reading material. All right, so Seth, should we let me make sure there's no chat questions before so is there a slight delay then? Is that what you're saying? Okay. All right, perfect.
Yeah. Yeah, there is, I think.
Okay. Cool. Well, no questions so far. I'm sure there I've got questions, but we don't have time. So no, but yeah, it was really awesome. That was really what I think that's definitely what I was looking for. Really awesome. So Heather, you're up next. Before you
No pressure.
Yeah, no pressure. No pressure.
pressure.
Just
Yeah.
following that presentation. Seth, is there anything to mention before we move forward?
I don't think so. Right, we'll just keep rolling right along. As always, jump into Slack or hit us up on Twitter or via the YouTube live stream if you have questions for us or the speakers. Slide on in. That's why we're doing this. That was an interesting one. I have all sorts of tabs now open and stuff that I have to research. Apparently, we're taking homework away from this. That's why we started with Stefan. So we're hoping that Heather can add to that for us, right? That's what you're going for, Heather, today? Yeah. Oh, yeah.
Right.
Again, no pressure. No pressure.
Awesome.
All right. Well, yeah.
All
Let's move right into it.
Let's see if I can do this as easily as Stefan did. Hey,
there you go.
all right, sweet. We kind of all went with with Shakespeare's themes, kind of going for talk descriptions. So I went with Puck's Wild Pansy. If you're not familiar with A Midsummer Night's Dream, Puck's Wild Pansy makes people fall in love. So the idea is that data visualization will possibly help you fall in love with your network data again. If you've never heard a talk from me, I'm a data scientist with NARI. It seems like a forever PhD student at this point with UCCS here in Colorado. I have quite a few prior lives. I did a stint in the service where I was a nuke for the Navy. I worked with Hack UCF and now do a lot of volunteer efforts with B-Sides Orlando, DEF CON, and KernelCon. If you've seen the B-Sides Orlando graphic there in the corner, that's something I did last year. So if you don't get anything from this talk, these are my major takeaways. There are different types of data visualization options for different use cases. And honestly, it's the same idea for most machine learning. No free lunch. It means that if you want more control and you want cooler stuff, you have to do more work. But this is getting easier, and I'll kind of go into that. So I'll go through the motivation for this talk, some visualization libraries in Python, feature selection and processing, something that I have to go through kind of frequently. And then I'm going to go through a couple of Jupyter notebooks to kind of bring this point home. As I said, I'm one of those poor PhD students. I need to sort network data. It's for my dissertation. So my budget is 0. And my network traffic captures tend to be over 500 megabytes. If we're talking like the raw PCAP, I have baselines that are 6 to 7 gigs a piece. I could probably, if I really wanted to, chunk them into pieces and then bring it in sequentially over days if I really wanted to. But no, I'm not. That's not me. I didn't really need real-time dashboards. This is point in time, so it's not continuous, right? So I don't need to know how this is going on over time. It's just a solid PCAP. I need to visualize that data. I need to visualize data about that data, particularly through feature selection and machine learning. And then finally, I have to communicate this to other people, right? I have 2 research advisors that, well, to be frank, if I didn't have it in a blog, they would probably forget that it happened. So yes, communicating to stakeholders is what's really important to me. And right now, there are several ways that this is done, right? I've asked several people what their workflows look like for looking at PCAPs. Some people say, I just throw it into Splunk. There's PCAP Analyzer for Splunk. And then there's the Splunk ML Toolkit, right? These are apps that come into Splunk Enterprise. And as you see here, they produce like dashboards, pie charts, alerts, what have you. You could have an Elasticsearch stack where you have Logstash, an ML node, and Kibana, and they all play with Elasticsearch. And again, you get like these really pretty dashboards. A lot of these are already set up for you. So if this is like your use case, this obviously sounds amazing because it's like, oh, I just get my PCAP data in there and pretty graph spit out. Maltego, another way. Here we see another kind of network diagram where each one is kind of specific to the device and to like a specific GeoIP location. And of course, this works at varying degrees of complexity. You could take a PCAP and bring it into Grassmarlin, which I was informed it's all in caps for that project name, that's fine. And you can get out some reporting. You can get out CSVs and an SVG that kind of looks like here at the bottom, where you get a network diagram. It doesn't look pretty. And there are some very cool icons here. If you like look in, you can see infrastructure or workstations that Grassmarlin kind of populates for you in this graph. And again, varying degrees of complexity. You could always write your own. You could write a Lua script with T-Shark and use GraphViz to kind of populate your own graphs. And I pulled this out of Wireshark for security professionals. So I'm not going to go over any of those. I'm going to go over Python. And here I kind of have it set up in a stack. It's not really a stack. It's kind of 4 areas of libraries that intermingle with each other or rely upon each other to plot. And that particularly is in like the Seaborn Matplotlib association. But here you have your base language, Python, IPython. IPython is providing the environment which you can view code on Jupyter. And then you can manipulate data either through NumPy, and then there's SciPy, but I'm not using it for this particular example, pandas, and scikit-learn. And then you want to visualize like all of that manipulation that you do through Seaborn, which has all these pretty colors and palettes, and Matplotlib, which is really kind of doing all of the strong arm work behind the scenes. So right, as I said, Seaborn, it's built on Matplotlib. It's closely integrated with Pandas data structures, and it's got these really cool palettes. I'll show those here in a second. And then Matplotlib mostly works, or most of it that you see is through PyPlot, and it's Python's main plotting library. I will also kind of show NetworkX, which does graphing more for the network science crowd, so like nodes, edges, but you can use it for IP graphing. There's a little bit of the notebook that has that in there. And then Bokeh, which I didn't really have time to show, but if you wanted to make interactive visualizations, kind of like the D3JS-esque, you could do that through Bokeh. If you were trying to follow along and like how on earth do you get these visualizations through PCAT? Well, generally you convert it to CSV. If you do it through Wireshark, what you see right there is exactly what you're going to get out of T-Shark. Not a whole lot of information. What PCAP number it is, looks like a timestamp, a source and destination IP, the protocol name, what port it was over, and then kind of the sequence, ACK and window. Personally, I use something called Kickflowmeter. It is an open source program out of the University of Canada. I'm going to say, I'd have to look it up. But on their site, they have the Kickflowmeter. If you wanted, you could use Joy, which produces more net flows than really CSV. Or you could write your own. And most people that I know don't have the patience to write their own PCAP parser, but it's open there if you'd like to. You need these particularly for feature selection and processing. I saw this on Twitter. It was totally relevant to what I'm trying to speak to here. You realize that you're better off with Sysmon and Elk than with $2 million Steam license quota filled with Firelog data. And what I'm trying to bring home here is that feature selection and processing is extremely important if you don't want to waste your budget on storing data that isn't actually useful. Right, so choosing which features to keep can save disk space and processing. Last time I checked, that's also known as money. Network data tends towards a higher number of features, right? Higher feature space. Kickflowmeter itself produces 80 features from a PCAP. And when I said data about data, a lot of it is metadata. So min, max, standard deviation, features about features. And realize that if you are training a machine learning algorithm, right, using these features, if you have irrelevant features in there, it might affect the training performance. So not only to save time, money, processing, your accuracy may be brought down if you are keeping in features that are irrelevant. If you're not familiar with feature selection, I'm not talking here specifically about dimensionality reduction, which is to kind of remove pieces that, or remove features, rows, et cetera, that do not really hand the classifier the best way to classify, I'm using classify in this case, the data. Particularly, I'm speaking about supervised and unsupervised feature selection. And there's intrinsic wrapper and filters that kind of fall under supervised. Trees like random forest would be under intrinsic. So this would be like a machine learning algorithm that you run it, and then by its own nature, it tells you which features it prioritizes. So like random forest would be here. A wrapper, which is essentially a program around a core algorithm like a random forest. That uses that classifier to determine feature importance. And then there are filters, which has like statistics or like a feature ranking, feature importance ranking in order to determine which features you want to keep. For the purposes of this talk, I'm just going to cover visualization using RFE. RFE, right, of course, recursive feature elimination. Most people are like, what the hell are you talking about? Hold on. As I mentioned, it's a wrapper method. It's a different ML algorithm is used at the core of the method, right? And as I said, it's wrapped by RFE. I mentioned before random forest. You could also have decision tree and gradient boosting. And the idea is that it works by searching for subsets of features, starting with all of the features. And then it removes features until the desired number of features that you choose remains, right? So the core algorithm, I believe this time I'm using random forest, it'll rank features by importance and then discard the ones at the tail and then refit the model based on what features were kept. The data set that I'm using in these Jupyter notebooks is something called CTU13. It is a botnet data set generated by Garcia et al. If you go to the link here, you can find more information about this data set. But essentially, they populated a botnet and watched over the network as different types of bots, ferried their traffic or attacked different nodes. If you are looking for it, you can find all of these here on my blog, and that's where I'm going to now go. Hopefully I didn't lose anybody here. Let's see. Let's see. I see that I am not quite there yet. Let change the screen. Yes, this one. Wonderful. All right. So here is a visualization. If you're not familiar with this is a Jupyter notebook. I basically pull in the botnet that I have already processed over into a CSV using Kickflowmeter. If you bring in the data frame, it kind of looks like this. You'll notice there's like a flow ID and a source and destination IP, and basically all the other things you would find in a data set, right? At least for PCAPs. So for these visualizations, I'm basically trying to go through and find things that you would normally put in like a Splunk dashboard, but instead of, launching Splunk and pulling in my PCAP, essentially I'm pulling my PCAP into Jupyter and running these same data visualizations. This is more convenient if I have a large number of disparate data sets, which for me, it was easier to analyze using Jupyter than instead of bringing them one by one into Splunk and then trying to analyze them. So here, and this is Seaborn, but notice that it is using PLT, PyPlot, which is part of Matplotlib, in order to do the heavy lifting. The palette here is BluesD, so I didn't have to choose any of those colors. They were generated for me. Essentially, I bring in the data frame. This particular data set has something over 100 IP addresses from the source. So here I'm just taking the top 10 and graphing them here as part of a bar plot. Similarly, I can do that as part of destination IPs, so like who's sending the most data. Here you'll notice the palette is something called colorblind. So if you have people on your staff that have trouble differentiating the different types of bars, you want to be more accessible, this already has a palette for you. Similarly, you can visualize the protocols. This goes by the IANA assignment. So here TCP is 6 and UDP is 7. Similarly, we could rel plot or kind of scatter plot any of the ports that are used. Obviously, this is quite the spread across ports, but notice that there are quite a bit concentrated around 1024. If I remember correctly, it's around port 80 because there's a lot of HTTP traffic. And now here I'm going to show Network X. Here I've kind of have it in line. If you generate it from Python, it's actually more of an interactive plot where you can move the nodes around. But here in line, it's just this. But notice that if this were overloaded with IP addresses, it becomes more and more challenging to get them to not fall on top of each other and actually see them. So this is better for smaller networks. I wouldn't say probably over 200 nodes. All right. Let's see if I can get this to switch over. Here we go. Yes. All right. Just for funsies, we were kind of looking at, if you're familiar with Jack Daniel from B-Sides, he did a survey on degrees in education and cybersecurity. Here I am just taking in his CSV. I kind of renamed his titles for his features because they were very sloppy and very hard to kind of do data analysis on. But here it's the same idea, only now these are more of categorical responses instead of a numerical feature. So here the question was, do you have a security role? You see over 300 responses are yes, several are no, several are tech, but not security. Same idea using the colorblind palette. You'll see that most of the respondents had a bachelor, a good deal had masters, some had doctorate, and some, actually quite a bit, had some college, but no degree. If you want to play with or look through these visualizations more, you can come up here to this address, and I have them posted on my blog. Additionally, if you want to just play with the Jupyter notebooks, I have them kind of shoved into my GitHub. All right, so let's see, what were the interesting ones, if I remember correctly? Oh yes, some of these, like what was the question itself? Degree fields. It turns out everybody in infosec comes from very different places. And I'm not sure if I'm going to be able to view image, perhaps. Here we go. Of course, this is a very large image, so you can't really see it there in line. Notice that people in infosec come from a very diverse crowd, but from the most part, this would say most of them are computer science. Of course, some of these need to be deduplicated, but notice that these are quite a disparity of different degrees. And you can visualize all of this in Seaborn. let's see. Lastly, I wanted to cover RFE. And notice that if you are maybe doing analysis, again, of data about data, you will kind of need to have the hooks to visualize that. Originally, I was going to show Baruda. Baruda is a statistical feature selection algorithm. It was brought into R originally and ported over to Python and adopted by scikit-learn. The problem with Baruda is that it doesn't necessarily have the hooks to visualize, so I can't show you cool things like this box plot down here at the bottom. Here, it shows you the different evaluations for the features, where they scored on model performance. So, right, these are kind of cool things to do that you might not really get out of Splunk. I haven't used their ML app. So if somebody wants to prove me wrong, I'm totally all ears and love to learn about that. But as far as I know, no. All right. So references for this talk. I pulled a lot of information, particularly RFE, from Data Preparation for Machine Learning from Jason Brown-Lee. If you have been to, I believe it's Data Science Mastery, he has a whole site on basically how to do what I'm talking about right now. And it's been really awesome to kind of look at the things that he just gives out for free. So when I was saying earlier, one of the takeaways from this, right? One of the takeaways is that this is getting easier. So I did show all of these huge blocks of code. When I was first starting out, they would have been very daunting to try to go in, learn how it all works, and then try to edit it to see, to like experiment, and then try to bring in my own code, which usually explodes. So going through and looking at how other people have done these visualizations is getting far easier to understand, to use the API, and to like use it on new sets of data that haven't been coerced and massaged to give you like the pretty graphics. I mentioned CTU13. They have a paper, empirical comparison of botnet detection methods. If you like more stuff about what I'm talking about as far as Jupyter notebooks, you should check out infosec JupyterThon. They just had it. It was really awesome. I'm referencing Jack Daniels' Uncommon Sense Security blog because that's where I pulled the survey data from. And of course, I was talking about Baruda. If you need the slides and code for what I talked about here, you can get them at this link right here. And I'm open for questions.
So far, we haven't had any questions. We've only had some input from one of our viewers that the colorblind component of that was awesome. Another nice comment from a viewer. Did anybody have any questions for Heather? I believe you're muted there, Stefan.
What even is technology? How do I fix that with Jupyter notebooks, Heather? Like, that's what I want to know. No. I think one of the things that are very difficult when you're trying to get into data science or when you're trying to get into these sorts of things is like getting started on the data sets, right? You obviously have quite a bit of background in this sort of thing. So like, what is your methodology for just getting started, for just diving into data and starting to tease things out? Because I think that's where most people start to fail.
Looking at it first. And this kind of, yeah, that sounds easy. Just look at the data. No, I mean, like, literally look at the data, pull it open, look at it. I actually like Excel. Don't kill me. But you usually have to cut up your data, right? So Excel only works up to really honestly 100,000 rows, and after that, you're taking a one-way ticket to Crash Town, right? So if you can like cut off or just like head the top part of your CSV and then pull that into Excel and look at it, that's usually where I start. And you kind of want to look at what your data actually includes. Are they categorical? Are they numerical? For us in security, it's always the question, what do I do with IPs, right? IPs aren't a numerical. They're categorical. They map to places. And more importantly, IP addresses can be spoofed. Are they spoofed in your data set? So like you need to ask yourself these questions when you're looking at like each data feature. And then after you've looked at it and you're like, all right, well, this is what I have. The next question is, what do I want? What do I want out of this data? What is it trying to tell me? What am I going to use it for? And I think that's a huge place to start, especially when you start exploring some of these data structures and data types.
So my question, like I've dug in some on the machine learning side, but for different purposes. My question is more around unstructured data and how to determine what it is, like what questions you should be asking, right? Like even coming up with a feature set when you're looking at unstructured data is so difficult, right? Well, how do you go about that? I mean, you talk about IPs from an infosec perspective, but you have a blob of data. What is it that you start to look at there? I know that's very random.
No. I hate to say that regex is your friend, but sometimes that's what you're stuck with, right?
Okay.
It kind of depends on,
all right.
it depends on how unstructured your data is, right?
Yeah.
If so, once upon a time, I used to mine dark web data. So I would log into a darknet marketplace and basically scrape their site from Selenium. So when you'd get that data back, it's an HTML blob.
Yeah.
Right. You'd have to like pull out features to even use them. And that's what I mean. Like, it kind of depends on how unstructured your data is, because you might be resulting to regex.
Okay. All right. Well, then I'm on the right track, because that's what it came down to. I was like, well, yeah, it's just a random regex of different things, and then we can start to analyze from there. So okay.
If it's like an HTML blob, like I mentioned, you might be able to use something like Beautiful Soup on it to like pull things out of it, and that would help, because there are some libraries that will pull out specific unstructured types, right? But if it's just like, here is a hex dump. Yeah, you're going to need regex. Like I don't even know how you would begin. Frankly.
Yeah, I mean, some of that has almost been like size versus like the amount of data that's in each of the different instances, the amount of different characters, right? Some of that gets interesting, but again, like it depends on the questions that you want to ask, right? Like what you're trying to get out of it.
Absolutely.
So.
I have all sorts of feelings about parsing HTML with regexes, but
yes,
hey, I'm not looking at the data, right? That's usually the last tool in the tool belt is resulting to regex, but there's a reason why people result to regex.
Yeah, for sure.
Regexes have all sorts of failure modes and whatnot. One other thing though that I was curious about, especially once you mentioned regex, do you have like a tool belt of regexes that you keep around for things, or even just like a internal knowledge base for yourself that you like? Oh, I saw this. Therefore, last time I used this regex, and now I'm going to reapply the same thing. Like, do you keep that sort of thing around, or is it really like each investigation, each visualization is different each time?
Generally, each data set's different. I was having an issue, the Kick Flow Meter, they give you like data about data. There's something called flow packets and flow bytes. And coming out of the tool, you will get nans and infinities. What do you think visualizations do not like?
Yeah.
So it's like, how do I detect that that's there in my data? How do I pull that out? One of the things that, notice I said the last tool in the toolbox is regex. I personally like to pull it into Python and then use Python slicing. So especially if it's strings, then I can, all right, read row out of CSV and then parse that row into the pieces that I need and then rinse repeat. Let's see, what is the largest data set that someone just starting can feasibly do on a laptop before they need some sort of cloud computing? Well, it kind of depends on what you're running, right? My go-to working laptop has 16 gigs, which is why I say that 100K rows is the ticket to Crash Town. But realize if you're running 4 gigs, that might be much smaller. What is the largest data set? It's kind of dependent on what you're running hardware-wise. Generally, my idea is you pull in 1,000 rows, see how well you go. If you crash, well, you can't do 1,000 rows. If it's really quick, right, you watch the way that your hardware responds. You might be able to up it to 10,000 rows, 25,000 rows. I'm not particularly one to just sell, hey, just put it on the cloud, mostly because cloud computing is expensive unless you happen to be a student and you have money to throw on hours for cloud computing time, which some do, but not everybody.
It's like that old saw that if you can fit things into memory, it's not actually big data, it's just data. And I think this is something that we always run into, right? Like what one person considers big data, or requiring a cluster or requiring Hadoop or any of those sorts of things, like another person would just be like, what? I have a 256 gig machine sitting in my data center. I just do all my processing there. What's the problem? I don't need a cluster.
I mean, if you're working with that kind of hardware, then more power to you. Most of us don't.
Yeah, exactly. But it is a great question. Like, at what point do we really want to move on? And it really is like what fits in memory, and what sorts of what sorts of requirements do we have there? And actually, in that vein too, what sorts of limits have you seen with Python? Because I've seen Python fail in weird places too, especially with memory limits. And I know you work with Python quite a bit, so that's what I was curious about.
First of all, I'm going to make a comment about data, the big data, because you got me thinking here. Coming off the wire, raw PCAP, I mentioned some of my baselines were like 7 to 8 gigabytes piece. And remember, I was talking about, you don't want to save and process all that data if you don't have to, over and over again, because, that's time and money. As you do feature selection, you move it over to CSV and you cut things down. Here at, CTU 13, it's probably about 100 megabytes now, because it's gone from this huge portion with payloads and all of these extraneous features, converted to CSV. So we cut off all the payloads, we cut off all that stuff, and then you do it more. So you have more feature selection where you cut out the flags that are mostly zeros, or take it from a sparse, right, to compact. And you're saving a lot of space, right? What you're actually processing isn't 8 gigs. It's more like 500 megs, maybe, right? And that's a huge difference on time and processing power. So feature selection, do it. It's great. Don't process things you don't need to. And then to answer your second question, Python. I was actually using Bruta last night. I've got to do things for my research advisor. And I had pulled in things with low memory being false. So when I pulled it in from CSV, it pulled in everything as a float 64, which if you can kind of consider the space of float 64 versus int 64, that's a lot larger. And frankly, some classifiers won't even use it. You'll have to concatenate down anyway, just to even use the classifier on that data. And so what I was noticing is that I'd have my Jupyter, my kernel failing. It would just kind of silently just stop working without actually failing and giving me an error. The kernel would just be gone, and I'd have to reconnect it and completely rerun my notebook. one of the important things to notice is that when you are using these classifiers, how big your data types are and how many features you have, because that will greatly change how long you're sitting there waiting for that classifier or regression algorithm to process.
We actually had another question come in. How do you handle data drift as your data formats change over time?
Data drift as data formats change over time. I assume that's from a question, or that's asking about changing from raw PCAP to like CSV or JSON.
Yeah, and they clarified with data format drift. So I think you're in the right vein there, but also obviously as you process things,
they do as you feature engineer, things change. Yes.
Right, exactly.
To be honest, planning on how to format your data is probably going to save you a lot of time in the long run. So you can have any change, right? So let's say you have your main PCAP, right? Your raw data, and you decide you were going to keep the last, I don't know, 50 features, and you're going to dump 30 of them. Well, those features are gone. So if you need those features back, you have to reanalyze your PCAP, right, to get the features back and continue analysis. That takes time and energy. So when you ask about like data drift, keep the old files because you might have to rerun them, frankly. And sometimes it's just easier to have a sanity check. Maybe you made a transform and you didn't document it very well. If you have the old formats and can do it again, you can prove to yourself, give yourself like the sanity check that yes, this is correct. This is the way it's supposed to be.
It's almost like someone just had an entire 45-minute rant about planning and all those sorts of things there. But no, I think it's a great question, and I think it's a great point, right? Like when we work in data science, when we work on these sorts of things, like keeping around our old formats and documenting our expectations and documenting what we're expecting and whatnot is a huge thing. And I think data scientists very often are not trained in those sorts of things too, or we think of things in like a REPL or Jupyter Notebook or those sorts of things, and not the longer term planning of data and how we consume it and whatnot over time.
I think it's also like not just a planning, but a process of applied machine learning. It's one thing if you have your straight and narrow data set you pull in and it's all perfectly, structured for you, and there are no nans or infinities, and every row has all of its data nicely filled out for you. That doesn't actually happen.
You mean the data doesn't just like rain down from the gods in a way that you can easily consume it every single time?
That is the new oil, but baby, you got to drill for it.
Yeah. And actually, that's an interesting point too. Like, and you and I have talked about this before as well. Like, what sorts of things do you do when your data format is actually the problem?
Ooh,
yeah.
I'm sure a lot of programmers come across this too. Hey, it's in JSON. We need it in CSV.
Yeah.
Now go. Luckily, Python has a bunch of libraries in core that help out that a lot. So you aren't just trying to write your own parser from scratch most of the time. To CSV, I believe that's part of Python. It's helped me out a lot. And honestly, it wouldn't be nearly as attractive if I couldn't pull in data as nicely as you can with that. But to answer your question, like going from different formats, a lot of that tends to be manual if there's a library not even written for it. And sometimes you want it to be manual because there will be no library written for a specific parser to do the thing you want to do.
it's also interesting too, and it harkens back to what you mentioned there, keeping around old data sets, versioning things, making sure that those processes stick around is incredibly important. Are there like techniques or are there mechanisms that you use to help manage your data sets, like GitHub LFS or Git LFS or any of those sorts of things? You know you're not, because this is a hard question.
Oh no. So it depends generally, right? If it's just a CSV and it's not very, weighty, I could probably just put it on GitHub and then version it that way. Not a big deal. If it's large, trying to find somebody to store large data files is not an easy process. I've been turned down from multiple academic places that store your data set for scientific use. No, they don't. It's a lie. The cake is a lie. Sometimes what you end up doing, at least what's working for me, is when you process the data set, you put the date. Generally, if you almost like you were working on a Scratch template for that day, the date that you are currently on, because you're not going to generally process it more than once a day. And if you do, you can add some more qualifiers on the bottom or at the end. But generally, that's sufficient to keep versioning for me locally.
So it's the old one, two, final, no, really final, this sort of thing is what we end up doing. But for scientific
I used to do that, yes.
No one does that. No one does
No,
that.
I'm okay. I'm okay admitting I used to do that.
I used to do that. I still do, but I used to too.
No, then you start going, all right, so when was the last modified date? You start going forensic style on it. All right, so how many kilobytes is in this notebook?
So I had one last question. I know we're butting up against time here, but as far as classifiers go and the algorithms used there, how is it that what do you end up using, I guess, for the analysis that you do, and why do you pick the different classifiers?
That is the scope of a whole talk.
I realize that. I just was hoping you had an easy answer for me, but if you don't, that's fine.
No. I can actually answer this one pretty quickly. So I use classifiers, a binary classifier.
Okay.
And because I use that because my labels are 0 and 1. Either it's attack traffic or not attack traffic. In the event that maybe we had different qualifiers, maybe 0 is benign and 1 is insider threat and 2 is malicious attacker and 3 is abnormal, right? Then we would use a different classifier. Then we'd start looking at multivariate analysis instead of just binary.
Okay, cool. Well, good. I know we're getting ready for the next portion. So Heather, thank you so much. I don't think we have any other questions. Did you guys see any others come in?
I think that's it.
Okay.
Thanks for having me.
Yeah, no, thanks for all you do. I think next up we're waiting on EFF, correct?
Yeah. Fred and Naomi will be joining us for a legal question and answer. Oh, there's Naomi.
Mm-hmm.
Perfect. We can add Naomi to stream, and then we'll add Fred in once he joins. Perfect. Hey, Naomi.
Hey, how's it going?
Good. Thank you so much for joining.
Thanks for having me.
Okay, we're just, I'll ping Fred as well. Well, we're just a minute in. We're a minute ahead. What? I'm so used to from meetings being like, oh, I'll just go ahead and ping them. And wait a minute, this is actually a conference. We can do whatever we want to.
It's too professional there, Stefan.
Yeah, no. Slow it down.
Well, project management skills die hard. No, but it is really great to have you, Naomi. It's absolute pleasure. And obviously we'll get into your background and everything as well in a few minutes. So.
Totally. No, it's awesome you guys are doing this. How's it going so far?
Pretty well, I think.
Cool.
I think we've done pretty well thus far.
Nice.
We've managed to figure out technology for the most part. When I accidentally was speaking on mute twice, it's fine.
Mm-hmm. That happens. That's 2020.
Honestly, 2020 has been so interesting. You could probably just have like random thing happen, be like, oh yeah, that's 2020.
Just anything bad.
Anything bad.
Yeah.
Doom scrolling for the win.
Right.
There we go.
Stefan, did you want to talk a little bit about what's going to happen here or explain?
Yeah, absolutely. And there's Fred. Fred, thank you so much for joining.
Thanks for having me.
So basically, we had Heather and I came up with a series of questions that we thought would be incredibly impactful to have some lawyers discuss, things that really impact security professionals, companies, across a number of different areas. And obviously we have two very smart, very talented lawyers, and we'll go through their backgrounds there in a moment. But we basically have the ability to ask some questions of folks, and then obviously answer any questions that come in from the audience. Obviously, also too, I wrote this really great disclaimer, so I'm going to read it. But basically, I did want to preface this discussion that obviously neither of the lawyers here present are your lawyer. None of the things that we'll be discussing is actual legal advice. You should always talk to your own legal counsel before you make any decisions. And despite the fact that we have two very talented, very smart lawyers, and we'll get into their backgrounds in a moment, but despite the fact that we have two very smart lawyers here, they're not your lawyers. I certainly am not a lawyer. You do not want me doing anything legal for you. I failed the Bird Law bar. I'm especially atrocious at these sorts of things. So don't take anything that we'll be discussing here. And obviously, if you do have questions about anything that is discussed here, and you should talk with your own legal counsel there. So, sound fair to anyone? Naomi or Fred, do you want to add anything to that? Nope.
Sounds good.
Perfect. So to just kick this off, Naomi, do you want to go back into your background, talk about what you do and that sort of thing, and then Fred, you can do the same?
Sure. Yeah, my name is Naomi Gillens. I'm a lawyer at the Electronic Frontier Foundation. And first off, just thank you so much again for having me. Always glad to talk about the CFAA and really glad to be here with you guys today. So a bit about me, I litigate cases at the intersection of technology and civil liberties, right? So when there are new technologies that have ramifications for privacy, maybe it involves government surveillance, implications for free speech and dissent and protest, that is where I am working. And it might not be immediately obvious how the CFAA is relevant to that, but I think that will come out during this conversation. Before I joined EFF, I was at the ACLU working on very similar issues. And before that, I was working for a few federal judges and a student at Harvard Law School, where I was also an affiliate at the Berkman Klein Center.
So you have an incredibly impressive and impactful career, and continue to do impressive and impactful things. That's an amazing background. So
love flattery. Thank you.
No, that's wow. Okay. When Heather suggested you join, I knew you would bring this sort of background. I did not realize the level to which you work in these sorts of spaces, and that's amazing. Thank you again for all you do and what you bring here today.
Thank you for having me.
No, of course. And then Fred, you obviously also have quite the background too. You and I have known each other for a few years, and you also work with some of our hosts here as well. But do you want to talk about your background and what the sort of things that you do?
Sure. So I am Associate Corporate Counsel at GitHub, and among many other hats I wear there, that includes I'm the primary attorney working on sort of legal support for our security incidents, for our bug bounty program, for a handful of other things in sort of the technical security space. I've also worked with our policy team on advocacy in this area and others. And I've been with GitHub for about a little over not quite 2 years at this point. Prior to that, I was at Tor Eklund Law for about 4.5 years, primarily doing cybercrime defense. Have second chaired CFA criminal trial, have handled many civil and criminal CFA cases, from search warrant through to Supreme Court appeal. And it is a delight to be here talking about it. I should also mention, sort of in the AppSec world, I also have authored GitHub's current bug bounty, which was shortly thereafter adopted by Microsoft. So I've got some things to say in that area too.
No, that's perfect. So that leads us right into the first question. Is I think you both work for incredibly impactful organizations. Obviously EFF is at the forefront of defending all sorts of rights and all sorts of like the ability to actually continue to do the things that we as security researchers do. And then GitHub is no less impactful, but from a technical side, really in helping people actually share research and whatnot. But could we talk about what CFAA is and talk about what the actual impact that researchers and other security folk would see based on both of your experience and background with the law and those sorts of things? Naomi, do you want to lead off there?
Sure, happy to. What is the CFAA? This is the federal anti-hacking law. It was passed in the 80s to target malicious computer break-ins, right? So it was actually passed in response to the movie War Games. I don't know how many of you have seen this movie, but the lore goes that President Reagan saw this movie. It's about a kid who thinks he's, playing a video game and is in fact starting World War III. And this was seen as a very realistic depiction of the kinds of threats that, the new up-and-coming computing systems might face from attackers, and got the president very concerned and got Congress very concerned. And there were other laws at that time that could target malicious computer break-ins, right, like there are today, like wire fraud. But Congress wanted to do something more, and so they enacted this statute, the Computer Fraud and Abuse Act. And what it does is it's very lengthy, but it prohibits accessing a computer without authorization or in a way that exceeds authorized access. There are a lot of different provisions, but they all include this language about authorization. And so the question is, what does that actually mean? And the statute doesn't tell us. And it was enacted in 1986, right? So we did not have the modern internet or modern computing. And these questions about what this language actually means, like these are still being batted around in the courts now, like right now, like there's a Supreme Court case about this question, this term, because it's just totally unclear. Fred, do you want to talk a little bit about the impact that confusion has on researchers?
Yeah, sure. No, that's an excellent intro. I think probably the biggest and most harmful aspect, whether we're talking about the access provisions or the damage provisions, and there's a whole other, can of worms about whether your authority to access is also your authority to damage or not. But I'll leave that aside for now. I think one of the most pernicious things is that in several circuits, and this is what the Supreme Court case is hopefully going to be touching on, they still adhere to what you could sort of think of as a contract theory of authorization. So if the terms of service for the website or the URL that you click through says don't do this, that is not just a contract term, but is a condition of your authority to access the site or the software. Obviously, if you are a security researcher, if you are taking programs or systems or hardware apart in a way that probably violates that term, that is essentially putting you at risk of felony culpability for doing necessary security work. The other sort of lingering horror of this having been passed in the mid-'80s is the bar for charges becoming a felony are extremely low. It's $5,000 or more in damage or loss, and those are both defined further in the statute. And back in the mid 80s, that was probably a lot of money for a early computing industry. Nowadays, pick your smallest security consulting shop, and they'll do that in an hour or two of instant response.
Mm-hmm. Yeah, I've definitely exceeded that in potential risk damages, or in potential, obviously simulated, granted by a client, that sort of thing. But any number of things that we do could easily exceed that sort of thing. I mean, even in programmer hour, we could easily exceed that number there. So that's super interesting. So CFAA obviously hilariously comes from war games, which I obviously and I love the movie and whatnot, but I think it also has some other further reaching implications there. So there obviously folks who want to like modify healthcare devices or work with insulin pumps, that sort of thing. You're very clearly voiding your manufacturer's warranty. You also can famously do this with like John Deere tractors, right? So the tractor has a no right to repair, and now anything that you do is technically violating these sorts of things there. So can you talk about the implications from your own background, as well as from what you see in GitHub or at EFF, about these sorts of things? Like, how are we actually impacting right to repair and right to modify? Fred, do you want to start off?
Oh, did I lose you?
No, I don't think so.
I was going to say, I don't want to wander too far into DMCA anti-circumvention territory, and that's where you get into the John Deere tractors, the repair, the right to avoid your warranty. And that is a fascinating area, but is a talk unto itself. I do think that the tractor and farmer community getting into right to repair is the best thing to happen to it in years in terms of attention and power. But as far as the CFAA, I think what worries me is more and more devices and technologies and things that have traditionally been on-prem hardware are moving to a cloud-based or cloud reliant structure. So, even if my 1201 exemption covers my right to repair my tractor or my right to perform security investigation on my, hardware firewall, once those become cloud services, now I am logging into a system that someone else controls and probably doing it through protected computers active in interstate commerce. And I think the more of our sort of day-to-day devices whose security or modification or repair relies on those internet connections and cloud interactions, the more the CFAA becomes a looming threat for those communities as well.
Yeah, that's absolutely right. And then on top of that, the CFAA, at least some courts' interpretations of the CFAA, the broader interpretations, which Fred was talking about earlier, would also prohibit like violating terms of use. That encompasses so much. And there are so many instances where you have security researchers doing, like basic public interest security research, right? Reverse engineering devices or software and trying to figure out where are their vulnerabilities, where could there be data leaks, right? Where could malicious attackers be accessing like really important information? And in order to do that, maybe they violate a prohibition on, saying no reverse engineering, right? That's a very common term, or all sorts of things. And there are all these prohibitions in terms of use that maybe don't even make sense, right? Or are just like copied and pasted. So EFF's favorite example of this is like the website for 17 magazine that used to say no visitors allowed who are under the age of 18. Right, until EFF like publicly called them out for that. And that's obviously just a case of someone copying and pasting the terms of use and not even thinking about it. But it happens all the time. And then you get, it turns into a federal crime if you violate that. And so you have researchers who have done extraordinarily important research, finding like vulnerabilities in insulin pumps, for example, right? You have Jay Radcliffe is an example of a researcher who he did research into his own Medtronic insulin pump to try to figure out what the vulnerabilities were, and discovered that attackers could potentially get into that pump, control the insulin levels, deliver potentially lethal doses of insulin. And by exposing that, he was able to get Medtronic to actually fix that software, right? They fixed it. Then he found more vulnerabilities in the updated version, and then they fixed that. But that's incredibly useful, right? It's so important in this ecosystem to have security researchers doing that work. And, luckily for him, he did not run into legal liability for doing that, but he has no guarantee of that. And that is the problem, is that if Medtronic had wanted, instead of welcoming that research, had wanted to turn it against him and go after him for violating their terms of use, they could have done that.
And I'll add, that is not just a hypothetical. I have absolutely had clients in private practice who were in the medical tech security field and absolutely had med tech providers say, how dare you expose our security flaw? Here's a civil CFAA claim, or here's, my buddy at the local FBI office after you now. And it's nasty.
Yep.
Interesting. So can you talk about the two risks there? Like you said, there's the civil side, right? That's obviously interesting. Like, how much can they go after someone for? How much can they really, like, how bad can that be? And then if they do refer it to the FBI or even saber rattle in that direction, like, how far into that can they actually get?
So the first one's easier to sort of hypothesize on because anyone can bring a civil claim, and it's a relatively structured process. If you see it probably most often in the real world with ex-employees who had some sort of privileged access and then ran off and started like a competing company, is sort of the classic civil CFA example. Or a web scraping situation, like the LinkedIn case is a good example where some other company is scraping your public data and turning that into some sort of profitable item that you don't want them to be doing. In those situations, no one's going to jail. It's a civil claim, and it's, if I'm remembering right, I'm forgetting right now off the top of my head if this is every circuit or just some circuits. It's also subject to that $5,000 floor, which again, in this day and age, is pretty trivial to meet. So, I mean, if a case goes forward, a private party could bring claims for their damages and losses caused by that activity. A criminal case is a little more complicated and gets into what I describe sort of as the social and cultural factors around criminal prosecution. Back in 2014, I think it was, the DOJ sort of released their internal charging guidelines for CFAA cases, and at sort of a high level, they're not unreasonable. They look at things like the sort of social harm caused by what's being done, the amount of damage, the amount of like user base or public harm coming from the activity, and draw a not outrageous line for what case is actually worth bringing and what case isn't. There's sort of two problems with relying on that as a sufficient backstop. The first is, that's DC. They can set sort of guidelines and suggestions in policy. The individual U.S. attorneys' offices in various states and federal districts have a lot of independence and a lot of power, as do individual prosecutors within those agencies. So part of this is you've got career incentives where if I'm a junior prosecutor, cybercrime is sexy. I want that, on my resume. And if it means going after someone because they, visited 17 Magazine's website and they were 17, so be it. You've got that discretionary aspect. You've also got the aspect that, if I'm a security researcher, just the process of being investigated, having my devices seized, having my home searched, even if no charge is brought, that can be life destroying. And the problem is to even answer some of the questions in this DOJ charging manual, you're already beyond that point before you can answer them. So it's not really a sufficient protection. The other piece here is, the reality is larger companies tend to have law enforcement contacts, tend to have leverage either nationally or at least within their community to say, hey, you over there, why don't you go look into this? And I don't know, just the guidelines coming out of DC have not seemed to do a whole lot to minimize the abuse of this overbroad law countrywide.
Yeah. And I'll just add a few points onto that. First of all, something I would add is that there are a few cases sort of working their way through the courts right now about how exactly we interpret the CFAA. One of these cases is called Sandvig v. Barr, and in that case, it's an ACLU case that I worked on when I was at the ACLU. And it's representing computer scientists and academics and journalists who do research online looking into algorithmic discrimination, right? How do algorithms on employment websites or housing websites discriminate intentionally or unintentionally, right? Based on characteristics like sex or race. So these are extremely important questions, right? It's obviously in the public interest to get to answer them. And the argument is that these researchers aren't able to do the work because by doing so, they would have to violate terms of service, like prohibitions on making these tester accounts or using accounts with any false information, which you would have to do, right? If you're testing out to, identical accounts that are different only in, gender or race. So as part of this litigation, the court gave the government the opportunity to disclaim its intent to prosecute these people, right? And this case would have gone away if DOJ had just said, look, we tell you, court, we will never prosecute someone doing this kind of public interest research. And that's not what happened, right? Instead, what happened was they pointed to these charging guidelines that Fred is talking about, and they said, look, it's our policy that we don't, probably we wouldn't be going after these people. Look at our policy written down here. But they wouldn't actually make a representation, right, under oath to the court saying, no, we're actually not going to prosecute these people. So that's the first thing. And then, even though these prosecutions for sure are rare, right, you don't have the federal government prosecuting the 17-year-olds going to the 17 magazine website all the time. It doesn't happen that often, but it can happen. And the fact that it can happen has real repercussions for how comfortable researchers are doing their work. And that's especially the case. I mean, first of all, there's individual risk, right, that you take on. Are you willing to possibly go to court and defend yourself and hire a lawyer? Is your employer willing to take that risk, right? The university that you work for or whatever it is, like, are they going to support you in doing that and potentially bringing on that kind of court fight? Do you hire grad students, right? Or do you employ people who are maybe here on a visa? Are you willing to expose them to that risk? So even just having this law on the books, even if it's not enforced very often, has real ramifications for security.
Oh, wow. That's like super interesting that you bring that up, because when you mentioned that, the first thing I think about is it black box attacks, adversarial machine learning, Nicholas Paperno, I believe. He had basically trained algorithms using AWS and was showing that the adversarial machine learning was possible, not knowing their algorithm on AWS. So, by all rights and what we're discussing here, that he would have been, eligible for CFAA. But I mean, this is a research group. Sometimes they're not all even in the U.S. Sometimes they're in Canada. Mm-hmm. But that's interesting how that could totally derail that line of research.
Yep.
And excuse me, how far into researchers can they actually lean? So let's say I didn't actually do the testing, or you can't prove that, Stefan did the testing. However, if you look at my GitHub, there is a repository that has all the steps in Markdown. Maybe I wrote some Python scripts, some Go, whatever it was. Like, how far into a researcher can you lean and say, like, you actually, are meaningfully impacting us? Either one of you is fine to answer. I think we both have different sides and views to this sort of thing.
I think if I'm a creative prosecutor, 18 USC 371, the conspiracy statute, stretches pretty far. probably, if there was no evidence that you had any connection to this group that actually used the code, but you'd written sort of detailed instructions, arguably no, not conspiracy. There are some other sort of cybercrime adjacent laws that might be brought in. I'm thinking of Marcus Hutchinson's case specifically, where they brought in like access device fraud type charges as sort of a fallback in case the CFAA didn't catch for that reason. But the range of charges just for making that sort of stuff available is not small, and certainly if you can tie them to the group that actually used it, even if it's tied through a legitimate research institution, yeah, I don't think a prosecutor would have a hard time bringing conspiracy charges on that.
Yeah, I mean, there are arguments that prosecutors or companies can make about, look, this was an issue in the Sandvig case, was we had these researchers who literally what they wanted to do was make two tester accounts, right? One account to look for, upload a resume and look for what jobs are offered, and then a second account of a different, say, gender, right? Uploading a resume, seeing what jobs are offered. They're not applying for jobs. They're not interacting with people. They're not posting jobs. And you have companies saying, it's very important to us that all of the accounts be real people with real names, because otherwise, people won't trust us. They'll think we're awash in fake accounts and bots. And so there's this like unquantifiable damage that you are causing. And even though we can't quantify it, that is real harm, and it enables us to go after you. And that is a stretch of an argument, right? Like that seems crazy, but that's the legal argument that folks can make under this law.
Interesting. And then the point that you brought up, Fred, about bringing in cybercrime adjacent laws, is that sort of like stacking? Like you charge someone with one crime and then charge them with a crime that's almost the same, but not exactly. It has slightly different nuance, different law, etc.
Yeah. So I mean, subject to the limits of one's sort of district office's policies or the charging guidelines issued from DOJ Maine, there's really very few disincentives to bringing just a whole laundry list of charges. It increases the sort of terror factor for the defendant, so you've got more leverage to get a plea. It gives you sort of fallbacks if, say, some get dismissed on motion to dismiss or otherwise get sort of dropped before trial. I'd say my experience in federal courts sort of across the country has been, it's pretty easy for prosecutors to amend a complaint to add or drop charges once they sort of get closer to trial. So yeah, I don't, the best example I can think of with CFA is Marcus Hutchinson's case, but it's not uncommon, especially for conspiracy charges, to be included on if it's a sort of group effort situation.
And then Naomi, obviously you work at the EFF. You see quite a few cases come in that touch on CFAA, and obviously I'm not asking you to speculate, but in terms of how often these sorts of stacking crimes or cybercrime adjacent laws that you see come in, are they very often brought together? Like, is someone just hit with this laundry list? Is that a fairly common thing, or are prosecutors more using this in specific cases like Marcus Hutchinson or other cases that they want to make sure that they get a win on?
Sure. Well, I would echo exactly what Fred said. I mean, I think any prosecutor worth their salt, really, like, it makes sense if you are a prosecutor to stack all the charges that you can, right? It just increases your own leverage, your own ability to get a plea deal or whatever it is, make this all go away as easily for yourself as you can. So that's a very common practice.
I'm seeing we kind of have this kind of related question here. While CFAA gets most of the press, I have started to see more state-level hacking charges against kids doing hacking. Is this becoming more common, and is the EFF tracking these laws?
I actually don't know about that. It's a great question. I've been very focused on the CFAA and this federal law and trying to figure out what it means in every jurisdiction right across the country. But that's absolutely right that states, of course, can have their own sets of laws, and then you have 50 different sets of laws in every state to try to figure out what it means. And that's not only going to be dependent on where you are, right? If you are living in California, you have to figure out California law, but maybe you also need to figure out the law of whatever systems you're interacting with.
Yeah, I'd echo that completely. The jurisdictional question, once you get to a state law level, is a lot more complicated. Certainly where, let's say it's sort of a simple single attacker, single victim situation. Certainly jurisdiction's fine where either of them are. If the route from attacker to victim goes through, a server in Arkansas and bounces off a VPN that's located in Mississippi, jurisdiction gets a lot more complicated real quickly. I can't speak to sort of whether that's becoming more common either. I will say it's becoming more common for states to have their own sort of CFAA-like laws, and they often introduce complications that are more nuanced, both for better and for worse, than the CFAA. So California's state law, for example, gets into a lot more technical detail than the CFAA does. And because of that, it has a few different limits, but it also has a lot more reach in some ways.
A lot of what we do at EFF is counseling people who want to do a research project and need to know what kind of legal liability am I incurring, right? And there's not always clear answers that we can provide. A lot of times it's just a matter of saying look, these are the sort of known unknowns. These are the risks that you're taking, and laying them out. And that's sort of the best we can do. And then it's up to that person to decide whether or not those risks are worth it for them.
This might be a very silly question, but when does something become CFAA versus the local state equivalent thereof? Like, when am I going to go to big kid court for CFAA abuses versus maybe the junior varsity league of a state that maybe doesn't have such great, when do I want to risk this? No, I'm not asking you to speculate on that. But when do things become a federal impact versus when do things exist only at the state level? Naomi, you probably deal with this quite a bit in your counseling, and then obviously Fred, I'd love to hear what you think. But when is it federal versus state?
Well, the answer is that it can be both, and that you can be prosecuted in both jurisdictions too for the same activity. Unfortunately.
Yeah, it doesn't sound like there's good answers to any of these questions that we've come up with thus far.
Not good for any of us. Maybe good if you're the prosecution.
Right.
None of us are. So, no, please, Fred.
Oh, yeah. No, I was going to say that's exactly right. And I think the most disappointing day of my kernel procedure class in law school was realizing that double jeopardy does not mean that you can't also be simultaneously charged by the state court. Which one gets sort of precedence if you've theoretically violated both is a really hard question to answer, because it's not clear from the outside sort of when DOJ pulls rank and says, hey, no, this is for us. There are limits on the CFAA based around some sort of arcane definitions of what's a protected computer and what's used in interstate commerce. But the reality is that today the case law has kind of defined a protected computer and in interstate commerce really broadly. So if you're not using a handheld calculator that was made in state, you're probably using a protected computer in interstate commerce.
Ouch.
Oh.
Yeah. And as a practical matter, if you have a project that you're thinking of doing, you're not going to be able to make that distinction ahead of time. It's if you are violating someone's terms of use, then you need to be thinking about the state law and you need to be thinking about the CFAA.
Interesting. And then obviously the target is problematic, but also where I'm launching these things from then. So if I like using Fred's example earlier, it bounces around and whatnot. But can I then effectively be charged in each state with every interstitial device that I've touched along if someone figured this out along the way?
So last I looked into the case law, that is still a somewhat open question. It is, you've got sort of appellate level federal cases saying, no, the internet isn't everywhere just because it's the internet. It has to have some sort of locus to, a defendant, a victim, an affected organization. But I don't, Naomi, if you know better, I'd love to hear it. But I'm not aware of any court that's said clearly, because this routed through a server here, you've got jurisdiction.
Yeah, no, I agree. But I would also back up and just emphasize that, like, what's really important and concerning about these laws is the high level chilling effect and power that they give to prosecutors and to companies, right? Because if you are thinking about some kind of important work you want to do, like maybe you're not thinking about which exact states is this going to be bounced through and what are all the different jurisdictions where I can be prosecuted in. Because if you are a computer security researcher who wants to just do your computer security research and help the world be more secure and privacy protective, what matters is are prosecutors going to come knocking anywhere, right? It doesn't matter what state they're from or if they're the feds or, maybe it will matter if that actually happens. But when you're weighing whether or not to do this project, am I opening myself up to legal liability? And if the answer to that is yes, which all too often it is, right? Or maybe, then that is a real problem and it really chills research. And there are so many examples of this. So one that we talked about in our brief to the Supreme Court was the Equifax data breach, right? That we all remember from 2016, where 140 million people had their data exposed. Someone had discovered that vulnerability, right? An independent security researcher found a vulnerability on the Equifax website, knew that it could be used by attackers in order to get this information, wrote to Equifax and said, "Hi, I uncovered this vulnerability." And the researcher in interviews afterwards said it would have taken them 5 minutes to fix, they just needed to shut down this website. It would have taken 5 minutes. Then they could have fixed it and carried on. And they just totally ignored the researcher instead. And so now this researcher is in a bind, right? Because they have alerted the company, putting themselves at some legal jeopardy for doing so, because it could show, right, that maybe they violated some term of use in doing that research. And when the company doesn't respond, then they have the further question of, okay, well, now what do I do? Like, you could go to the government, you could go to the public, go to the press, right? Create a website, tell people about this, which in doing so, that's going to force the company to respond, right? If you go to the public, the company is shutting that website down for sure. But it also increases the chances that they're going to be going after you, right? And that they're going to be really pissed at you and try to bring charges against you. And so that person understandably didn't want to take on that legal liability and didn't go public with this, right? Didn't go to the government with this. And just a few months later, we have this huge data breach that was completely preventable except for this archaic and confusing legal structure that has all of these incentives that disincentivize people from making our computer systems more secure.
Well, and Naomi, you also brought up an interesting point, given how everything you've said is interesting, but one of the things that stuck out to me is since it's so incredibly arbitrary, who defines where this start is or what the problem is or those sorts of things, it almost sounds like the company might be okay with it, but someone in between may have an issue with it. So like if I launch my attack my proof of concept from AWS or Vultr or some VPS provider, they also could take umbrage, launch a CFAA charge against me in any capacity, and then kick the ball off rolling, even though the target organization was perfectly okay with this attack or this issue going on.
Yeah, that's absolutely right. And you have so many systems now that are extraordinarily complex, right? So you have talk about a mobile voting system, right? Like this company called Votes that now makes an app for your phone that you can look at, doing Trail of Bits, audited them, right?
Yep.
So if the company is paying you to do an audit, that's great. But my understanding is that Trail of Bits was not looking into all of the third parties that Votes contracts with, right? So Votes makes some of the software themselves, and they also hire other people or use other people's software. Okay, so you have an audit that looks into the security of Votes, but is not looking into the security of all of those other people's work. Okay, so then how secure is Votes actually going to be? Even if an audit says, great, perfect, everything we looked at is great, which is not what the audit said, you still don't know because there could be a vulnerability at any step. And if you look into those other companies, then you're exposed.
Yeah, this comes up in bug bounty sort of policy setting and safe harbor clause context a lot too, because like you say, exactly, like things are so interconnected and relying on sort of vendor systems now. I think any good bug bounty policy today needs to address third-party systems and sort of what their stance is as to those systems.
So that's another interesting one. If I found a vulnerability that does not impact the client, right, that the target of my bug bounty or my research or anything, but does accidentally send, I don't know, 11 million text messages throughout it, and there's some material cost to that, could the company that I impacted transitively, would they go after the original client who started this, or would they go after me as the researcher? And obviously I'm asking you to speculate here, which I know is not, but like, do they have the right to come after me as the researcher, even though I technically had the permission of the target that I was researching?
If you've got the permission of the target you're researching, and it involved, unauthorized access or exceeding the authorized access third-party system they use, no, you've got legal risk from that third-party system, absolutely.
And I would add on top of that, there are a bunch of companies now that have vulnerability disclosure programs or bug bounties, and they say, we welcome independent research. We want our security to be great. Come, do your pen testing. Let us know if you find problems, and we will patch it. And that's awesome. But it also, is a PR tool, and it also indicates that the company cares about security, and it makes people feel like the company's products are more secure, which means that many, many companies adopt these policies in good faith, right? EFF has a bug bounty program. We will not give you cash, but we will give you swag. But not all of them do. And there have been instances where people have done testing that they thought was allowed under the vulnerability disclosure guidelines with votes, for example. Like, that's one example where just last year, I think, or a few years ago, there was an undergrad student, right, a college student taking an election security class at the University of Michigan, who, as a part of a class assignment, was doing pen testing into Votes' app, found a vulnerability, disclosed it to Votes, and then the FBI comes knocking, and it turns out Votes referred him to the FBI, saying, look, he's doing pen testing, or he's trying to penetrate our system. His defense, of course, was, I was doing this per your vulnerability disclosure program guidelines. And what they said was, no, they pointed to a specific provision in the guidelines that, they said that he had violated. And then people discovered that actually that provision had only been added to their vulnerability disclosure program after the fact that they had referred him to the FBI became public.
It's so shady.
That is super shady. I have a case I can talk about because the client gave me explicit permission to a while ago, where almost the exact same thing happened with a well-known drone company, which very hastily rolled out a bug bounty program. I think kind of around that time when they were coming on the scene as like, okay, right, this is the thing we need like a written policy page and a landing page for and all that. And had they rolled out this just kludged together bug bounty program that said, yeah, research anything, do whatever you need to, tell us about it. It was perfect marketing, terrible legal copy. And so, this person went out and found a critical vulnerability with a bunch of private keys out in the public where they shouldn't have been. And the company, rather than fix the problem, started threatening all kinds of criminal, referrals and civil suits, and the exact same story of just, you didn't act in good faith based on sort of your published policy.
And I think this actually is a nice segue into Madeline's question here too. In general, do charges tend to be levied against individual employees or researchers, or the actual organization they represent? And to wit as well, how far can you carry these things too, even if it is against an individual researcher? Like, can someone go after Trail of Bits for something I was doing transitively for another client?
In silence. I don't want to speak on behalf of Fred. For myself, this gets sort of into issues of like employment law and liability that I'm not so familiar with. But certainly something that does happen a lot is that employers will be at least threatened with lawsuits or legal liability, and then you have employers putting pressure on their employees to stop doing research or to stop talking about it, right? And there have been a ton of cases over the years of like presentations at DEF CON or Black Hat or other security conferences being canceled because people's employers get pressure at the last minute not to have their employees talk about some bug that they found.
I would say, with criminal charges, the only CFA case that I'm aware of being brought against an organization is WikiLeaks. Every other criminal case I'm aware of was an individual. If we're talking civil claims, it's very common for it to be an organization, whether that's a web scraping company that they're claiming a terms violation against, or a competitor company that they're claiming, stole some secret through unauthorized access. So yeah, civil, it's not uncommon to be an organization, but criminal, almost always individual.
And then one last question before I ask you both the closing question from Null Bytes. What can a security researcher do to cover themselves and reduce, minimize, mitigate the risk? Obviously, I don't think there's any, from what you both have said, I don't think there's any actual mitigation here. But what can we do to do harm reduction and minimize the risk that I as researchers have, for these sorts of things? Naomi, do you want to lead off as the EFF person? And then
Sure.
Sure.
Yeah, I mean, for sure, you want to be, reading your terms and actually be familiar with what are the parameters, what are you allowed to do when you're interacting with this computer system. And then think carefully, maybe you are going to be violating some of those terms. Think carefully about is that actually going to be causing harm, which might not actually have such a big difference in terms of your legal liability, but might make a difference in terms of how likely you are to actually get prosecuted, right, or charged civilly. But the biggest thing I would say is, we are here to talk to folks doing security researchers who are concerned about these things. We have a project called the Coders' Rights Project, where we are here to talk with you about these questions. So email us at info@eff.org. That's what we're here for.
It's a hard question to answer because it depends a bit on what kind of security research you're doing. Generally speaking, I think of sort of CYA and risk mitigation as either proactive or reactive. Proactively, if you're a red teamer, if you're doing sort of contractual engagements, absolutely read your contract or write your contract and make sure it has really clear permissions about what access you're allowed to, what systems you're allowed to break into, what you're not allowed to break into. Just be sort of as granular as possible. Similarly, if you're doing sort of bug bounty style research, read the bug bounty terms, see how well they protect you, and factor that into where you do your riskier, more invasive testing. And that's not going to stop the government from charging you if they decide to. It is going to give you a nice formal piece of paper to hold up and say, look, I had permission, here's why. Reactively, if charges have been brought and you are in that situation, the best things you can do are don't say anything, get a lawyer, and that's kind of it. Just don't incriminate yourself.
And then obviously, thank you both very much for joining. But Fred, do you have any last thoughts? We'll start with you to keep rolling there, and then Naomi, obviously, any closing thoughts on this?
Yeah, we didn't really talk about Van Buren, and that's the Supreme Court case that's on the docket for this term. And I think any security researcher will do well to watch that closely. It is a pretty narrow question about where the boundaries of authorization lie and whether that kind of hinges on what the intended purpose was, or if authorization is authorization full stop. And that's gonna, in the security research field, certainly that's gonna change the way that research contracts look. That's gonna change the way that, authority to access terms in red team agreements look. That's gonna change a lot of things about this landscape, whichever way the court comes down. So, I would keep a close eye on that.
Yeah. And just because we failed to get into this, and it's so interesting, but Van Buren is the Supreme Court's chance to finally make it clear whether or not violating terms of service is actually a crime under the CFAA. So hopefully they will take that chance and make that clear and come to the right decision. We will be watching it very closely. But I guess my concluding thought is really just that, this is something that maybe seems like it doesn't affect you if you work for a company, where you're being hired to do security research, by the company. But it really impacts everyone in the broader security community because, the people with the most exposure are going to be independent researchers, right, or academics, journalists. But the entire security community benefits when anyone can discover new vulnerabilities, right? When anyone can publish their security research, create new tools, and all of these things are chilled by this law. So this really impacts every single one of us. And it's something that's sort of endlessly evolving. There are new court cases about this every single year. And even though this one, Van Buren, might clarify this particular corner of the law, there are still many looming questions about what authorization means that will continue to be litigated for a long time.
Well, thank you so much for joining. Fred, Naomi, first of all, not only for joining, but thank you very much for the work that you do. It's obviously impactful to us as security researchers. It enables us to continue doing these sorts of things. And we really just appreciate not just that, but also for taking the time to talk to us today. This was super informative. And like you said, we didn't even get into some of the questions that we had thought up here. But if you want as well, we can also drop your Twitter handles or any contact information. We will also tweet out the info email address that Naomi mentioned so that researchers can get in touch with the EFF if they do have those questions. But thank you so much, both of you, for joining today. It was an absolute pleasure.
Thank you so much for having us.
Yeah, thanks for having us. It was great to be here.
Great to be here. Take
Perfect.
care.
All right.
Yeah.
Catch you later.
Thank you very much.
Oh man, so
All right.
awesome.
Seth, you good? Yep.
Oh yeah, that was awesome. There was all sorts of questions going, and I was like, no, we don't have time to go into it, right? So I guess the main takeaway is contact the EFF because I don't know if I have almost more questions than answers after that, right? To be honest, as a researcher, it's like, oh, well, if you're thinking about doing anything, contact the EFF, especially looking at code, right? Like Ken and I do all the time, or we all do all the time. I'm like, okay, right. So I'm doing an assessment and I'm pulling in this third-party library, or I'm accidentally hitting Datadog or what, you know what I mean, or whatever. Crap, right? Like, oh, I got to think about that and what's actually being sent over there. But
yeah. I was thinking about, was it the coal fire guys? Who's like, yeah, you're going to have a pen test and your employer sends you. You're like, all right, I've got the get out of jail free card. I'm being told that this is okay. And you end up in jail anyway.
Yeah, that's the worst case scenario, right? Like social engineering engagement. You're showing up at a courthouse in the middle of the night and they haul you off to jail. And you flash the card and they say, and you were trespassing, you're going to jail, right? Like, yeah. Anyway, so
I basically took away from that I don't want to do security testing anymore.
Hopefully that's not true.
So your nihilism is finally, finally come full circle and you're done.
Nihilism.
Yeah. There's no point. We're not going to secure anything. We all die. And also the EFS says that we're going to go to jail.
Yeah, we're going to die in jail for what we're doing.
I was thinking about what does that world look like? CFAA, and they decide that you can't do security research. So like what kind of field does that leave us in as people who like to tinker in computers? And like the organizations, like they don't need to do testing outside anymore, right? They do it all themselves, like Oracle and the CISO with the blog posts, like, please stop reverse engineering our code. We do our job just fine. Yeah. And they don't. What does that world look like if CFAA is, held to that standard?
Yeah, I've definitely run into companies.
We have no answer, Heather, right? Like
yeah. from personal experience, I have run into a large company that has sent a client a cease and desist. So I found something, I turned it over to the client, and the other organization's response was not, oh, thank you for finding these vulnerabilities, or how can we integrate these sorts of things. Their response was actually literally a cease and desist, and that we had violated terms of service. And at the time, I thought nothing of it. I naively thought, and this is why I asked Naomi and Fred, I naively thought, I'm a pen tester, I'm supposed to be doing these things. But it sounds like if they had wanted to, they absolutely could have pressed for me to take on damages for breaking the terms of service there. So
yeah, well, and that's just it. Like I'm with you. I'm like very almost disappointed in the answer, because I felt like this problem had gone away, right? Like I remember it being an issue. Well, I don't mean gone away. I don't know how to say this, right? But this was an issue when we started getting into the field, like late 90s, right? Oh crap, there's all of these instances, or there's all these computers hooked up that are out there. We want to tinker with things. If I find something, what do I do? Right? Responsible disclosure. And then it was like, well, do you really want to responsibly disclose? Because they're going to come after you. And so we're like, oh, bug bounty programs, that should solve it, right? No, apparently not. Right? That's what I got, is apparently not. And, get a lawyer to check your contracts, and yeah, hopefully we won't go to jail. I guess is really all we can say.
Don't do anything with computer security. It's bad. You'll go to jail. You're not securing anything. You're not fixing anything. Oh gosh.
Yeah. I don't know. Well, at least we have Neil coming up, and he's going to tell us all about how to do it on the safe side, right? I guess with CSP, because that's where we have to go. I don't know. Like, now I just need a drink, which is going to make our talk even more fun, right?
Oh yeah, man! I'm about to break out the whiskey here in a few. So, yeah, totally excited to have Neil speak about CSP, because CSP is super cool, and we always kind of mention it on the podcast. But I think this will be an opportunity to have that thought expanded upon by the master himself.
Mm-hmm.
So we've got a few minutes until he starts. Is there anything you guys wanted to chat about? Any, or do we just want to get Neil set up and
Well, I do think the one lead into Neil's talk is, besides the fact that Neil handles CSP for GitHub, and obviously does work on an incredibly impactful website, right? Think about the number of people who visit GitHub every day. Neil is super humble and will not actually relay how incredibly painfully difficult CSP is. I have clients that I have made recommendations, like, it's easy from my perspective, right? I'm just the pen tester. I'm just the code reviewer who's like, you don't have CSP, you don't have cores enabled, go do those things, right? But Neil actually is in the trenches dealing with that sort of thing, and it's incredibly painful. So I always look forward to when he talks about these sorts of things, even off the cuff in Slack and things like that, because it truly is interesting to see there. So I don't know if you all have seen that too.
No, I mean, I definitely have. Ken and I were having this discussion about a different site recently, right? Like a smaller site, and they're like, well, they have no CSP in place. So even though the code looks good and it just means they're at risk for other things, right? And I mean, it's one of those protections that makes a lot of sense from an external perspective, like the Stefan you're saying. But it's very difficult to do if you're the one that's actually trying to build it out. There's no easy recipe that's out there. I mean, I think it is getting easier, but it's still very difficult to implement properly. So
I don't know if I would say it's getting easier. There's tools out there that help, and I'm sure Neil can talk about those sorts of things and whatnot. But it's absolutely not trivial at all from what I've seen. Even with modern web frameworks, even with things that you would think would make these sorts of things easier, it's so difficult.
Rails. Oh, sorry.
But no, I think the CSP is incredibly difficult, and I think a lot of clients struggle with it. So it's fascinating to see what GitHub has done, what Neil's able to do with CSP, because it's absolutely non-trivial, and I have great respect for the fact that he gets this going. So
yeah, well, let's bring him in here.
All right, let's enough talk about Neil. Have him join.
No pressure, Neil, by the way. Just showing how much you get GitHub working with this sort of stuff. It's fine.
Did someone say Rails? Did we talk about Rails now? Thanks for the introduction. I definitely put a slide in specifically for the difficulty of CSP. It is not trivial, but let's get into the presentation. I'm Neil Matatal. You can pronounce that however you feel like. I won't get upset. We're going to be talking about content security policy and how we manage it at GitHub. You can find me on GitHub at OreoShake or at NDM on Twitter. I'm a product security engineer at GitHub, and what product security means to each company varies greatly, so I'm not really sure that helps. I'm also the co-founder of LocoMocoSec, which is a conference that would have had its third event 2 months ago, but has now been rescheduled and become online. Previously, I had worked at Twitter and UC Irvine and more, and I spent half of my life kind of doing development and half in security, so I think I have a little bit more of appreciation for these two sides of it. And I have 2 dogs named Dory and Crush, and yes, that is a naming scheme. So what is it? Content security policy, or CSP, is an HTTP response header or meta tag that manages some browser capabilities, primarily what JavaScript is allowed to execute. Once you have it in place, it has nice assurances that certain potentially bad things cannot happen by rule, but it can also limit your capabilities. This may or may not be a bad thing. And if you talk to anybody who has never implemented CSP or only partially implemented CSP or implemented it and moved on, they'll probably tell you that CSP is stupid, useless, and difficult. I only take issue with part of that. CSP is stupid difficult. It's very complicated. The spec has a lot of sharp edges. The implementations across browsers are not identical. So it's really tough to do. Let's just look at an example of content security policy. This is an abbreviated version of GitHub's. It is a very, very long string. It is one of the longest headers on the internet that is not involved in setting cookies. It has gotten quite big over the years. It takes a lot of careful consideration, testing, experimenting, and planning. It is absolutely 1,000 times more difficult to retrofit than to build from day one. Most applications out of the box are 100% compatible with a very strict content security policy. It's only the stuff we add that makes it worse. The primary thing you're trying to avoid is having this value of unsafe inline or unsafe eval in your script source directive. The script source directive is the one that manages what JavaScript can run. This can include, for example, a host name, a host with a path, HTTPS to load any JavaScript from a SSL URL. But the directives of unsafe inline and unsafe eval control whether or not you can use the eval function in JavaScript, which is not inherently dangerous, but leaves open the possibility for dangerous things, or unsafe inline. This is, a script tag in the middle of your page with some JavaScript. The browser just renders whatever you tell it to. It has no idea whether you meant to have that inline JavaScript or not. But if you tell the browser, hey, don't ever run inline JavaScript, and it sees inline JavaScript, it knows not to run it. CSP often requires you to rework your application significantly. Lots of third-party, mostly visualization frameworks are notoriously not compatible with CSP, primarily because they make heavy use of the eval function, and they cling to that capability with lots of reasoning. You cannot simply remove all your inline JavaScript and get stuff to a CDN, but the steps in between are pretty good too. So simply defining a policy is hard. Being able to coordinate a policy across many people is very hard. Think about a monolithic Rails application with hundreds of developers on it. Google recently did a research that found that a lot of the CSP on the internet provides little to no benefit at all. Again, it's a daunting task unless you've thought about it from day one. But a proper CSP provides many guarantees. Proper management of CSP makes the technology less daunting in general. And it kind of gets GitHub to a state where we're not like really concerned about XSS on our main application anymore. I don't say that in a cocky way, but I mean, if you can execute JavaScript that prints out a console message saying that your JavaScript was blocked, like, good job, but we're not going to, stop what we're doing to handle that. So how you go about defining a policy? Generate a baseline policy. I suggest you do this manually. Install a browser extension that allows you to modify the header. You can start with the most restrictive policy possible and work your way backwards from that. The nice thing about CSP violations is the console will literally tell you what you need to add to your policy to make it work. You should do that with some caution because you want to be sure that the sources that you are adding are sources you intend to add, and you're not, for example, adding a Superfish malware URL to your website's policy to enable the Superfish spyware. That was a true thing. Superfish was in a lot of CSPs on the internet, including one I managed. Crawl your whole application. You know your application better than most people. Hopefully hit that one corner of the website that you don't even know that people know about. Make sure any feature flags are turned on for your users so you're not accidentally seeing old content or content that doesn't apply to you. But don't expect to get it right on the first try. Don't expect your first policy to be right. You're gonna get it wrong the first couple hundred times. The point is, start and move on. I think a lot of people, especially a lot of engineers hear this and they go, well, I'm just gonna hook up a crawler to generate my policy. And that probably, the time it takes you to write that reusable crawler is still probably gonna be longer and less fruitful than your manually crawling the website. There are tools, for example, the author of Casper, as well as a product called Screen, do have products for managing a policy. It'll ingest reports, it'll make suggestions, and what you could do to the policy, and go from there. I think that those products are promising. I hope they can really, make it as simple as something that, for example, would have been designed by Apple, such that, everybody, people who maybe don't understand the backend frameworks, can even apply a CSP. This is, definitely a pie in the sky dream, but who knows? Now, I mentioned the reporting. The reporting is very valuable because your browser is not the same as every other browser on the internet. The way you use a website is not exactly the same as everyone else. CSP reporting will tell you every time a violation occurs. So it can be useful for both, tuning your policy, but it can also potentially detect an attack. Unfortunately, the level of noise in CSP reporting from when I last checked was way too high to ever potentially detect anything but like a massively wormable XSS bug, because all of the extensions on the internet generate CSP violations for your website, and you can determine whether or not it came from a plugin. You can look at, for example, the actual JavaScript that tried to execute will be included in some reports, but the reports themselves are not super valuable because of the amount of noise. And that's why I suggest you don't apply CSP reporting to every user who visits your site, but rather only the users that you have some reasonable assurance that they don't have 60 bad extensions on their browser. They hopefully don't have malware. For GitHub, this group would be our employees. Our employees use the website every day. So if something were to happen, they would be most likely to find it, and the chance that they're generating garbage is significantly lower than the rest of the entire internet. So again, CSP reporting can be useful for tuning a policy. I don't necessarily think it's useful beyond that. But the nice thing is, once your policy is in place, you don't really need the reporting because your policy is enforcing the rules. So it's doing its job. But you can't just turn it on tomorrow and break everyone's computer because you haven't tuned your policy well enough. There's a report only mode that will simulate as if you had applied the blocking on CSP, but instead will only generate reports and only generate messages in the console, but won't affect the way your application behaves. Again, if you have a group of people that you can reasonably rely on to test this safely and have some reasonable assurances that their browsers aren't garbage, you would put report only for everyone and then test it on your employees first. And if your employees can use it, then you eventually roll it out to the rest of the population. Definitely would suggest a very, very gradual rollout. You know, if you can put this behind a feature flag and just do like 1%, 5%. People will tell you when things break, hopefully. Maybe your reporting is still in place and maybe that helps you find bugs. It absolutely has helped me find bugs that weren't security issues as well. It's kind of interesting in that way. So let's look at the capabilities of a content security policy. I'm only going to focus on the script source directive. There are many more directives, but they're less important to me. You know, CSP allows you to define, for example, where you can load an image from, where you can make an XHR request to. And these are sort of, you know, can be seen as exfiltration vectors, which they absolutely are. And I don't think CSP's job is to prevent exfiltration, is to prevent script execution that leads to exfiltration. So every time I see another article that says CSP bypass, and I see that they allow unsafe inline and unsafe eval, it's kind of, I don't like the word bypass in that context. An overly permissive policy leads to overly permissive protections. But let's look at an example here. I know we jumped straight into seeing a bunch of HTML and a header value, but I will try to explain this on the fly as we go. So the first value for script source is the word self in quotes. This means load a JavaScript file from the same origin as the current page. So that's pretty helpful. I mean, a lot of people, when you're just developing a simple application, everything goes to one server and, you know, the static assets get handled separately. Local development, you typically aren't working with a separate domain, or self is pretty good for that use case. This also happens to enable JSON-P, so it's something you should probably want to get rid of if you don't need to support JSON-P. It also supports dynamic JavaScript. If you have an endpoint that spits back dynamic JavaScript on the same origin, this allows that sort of inherently unsafe behavior. Again, you can use it safely, or you could just not have the possibility of ever having a bug. I chose not having a bug. The second item here is the HTTPS with the colon. This says any HTTPS URL can be loaded. That's great that you've prevented, you know, accidentally leaking the loading of a resource, but you've enabled the entire internet. Probably not a good thing. And we already talked about unsafe inline and unsafe eval, but we'll see examples of how they're used here. So the first line is not loaded because evil.com is not in my list of sources, and it's an HTTP URL. Unfortunately, our hacker man does not have an SSL certificate. The second line there is a relative URL, so it is the same host. The third one is an SSL URL to a CDN, but because it's SSL, we allow it. Now, this image source on error, this is an example of inline JavaScript because it is JavaScript that is essentially, you know, taken as a string, and I don't know if it's under the scene eval, but it's kind of the same experience. This would generate an unsafe inline violation, but we've allowed this unsafe behavior. Similarly, the script tag below that allows inline JavaScript. We don't know if that's malicious or not. Now we've loaded this sweet animations.js file, which makes the use of the eval function to do something very interesting here. And lastly, it appends an inline script that says hello world at the very bottom. The only thing that wasn't allowed here was the loading of the evil.com non-SSL URL. Now, if we start to tighten down our policy, we've removed the eval function, unsafe eval, from our policy. Now, essentially, I've removed that first example. That'll always not be true with our policy. But the only difference now is I can't call it eval function. That alone is a huge step in the right direction. One thing that's definitely counterintuitive is the way jQuery did or does evaluate sort of a script tag as if you were to insert it into the DOM. It does insert it into the DOM, but it actually evals the content between the two script tags. So while it kind of seems like an inline script violation, it's actually an eval violation. Absolutely not obvious, but you've just closed a huge potential problem. So now we've dropped unsafe inline from our policy. This is a huge milestone here. That script source self, I don't like it. I don't like the HTTPS, but I've definitely helped the browser know what JavaScript they should not execute, at least within the context of a loaded page. So our on error event handler will no longer run. That inline script tag will no longer run. And that document.body.append child will no longer run. So on this page, the only thing that was allowed to happen was I was able to load the JavaScript file from myself and from my CDN. Again, this is leaps and bounds better than nothing. Now, again, I didn't like the self. I don't like the JSON-P. I don't like the dynamic JavaScript. I just rather just move everything to my CDN. So by removing that self, I can no longer load that relative path. I will have had to move it to my own HTTPS CDN on an external server, but I want to specify my CDN. This is kind of your end goal for a CSP 1.0 policy. We'll talk about CSP 2 and 3 later and how they make applying CSP easier and less restrictive. But so all of this potentially dangerous behavior has now been disabled, and now the only risk is if someone goes and modifies my bundle.js file on my own CDN, which hopefully you have some control over and some access controls, and you have some sort of integrity checking, which is exactly why when you pair this with something like sub-resource integrity, you've really mitigated a lot of potential threats. You're saying only load it from this place and only load this content. This could be taken further, but this is what GitHub has today, and it's been quite nice for us. So I talked about the happy path, but nothing is ever that easy, of course. Removing inline JavaScript is not trivial. It might require you to completely re-architect the way you do things. The way things interact will be different. It's not rocket science, but it's also not something that can be automated fairly easy, I don't think. So CSP 2.0 introduces two features that allow you to leave your inline JavaScript. The first one is a nonce. This nonce will, as long as you have a header value, a nonce in the header that matches the nonce in the script tag, the browser will say, okay, this tag has been blessed. It is allowed to run. Now there's another feature with the SHAs that allow you to take the hash of the content, specify that in the header, and then you actually don't even have to modify your code at all. Your script tag as is, that value will execute. So you'll just have to take my word for it, but given the header above and given the HTML below, the first two will execute, but the third one will not because there is no hash or nonce present. Trusted types is a bit of a kind of a tangent here, but it is a part of CSP now. It's worth a whole presentation on its own. Essentially, it allows you to define how data is passed between interfaces with typed values in place of strings, because everything on the internet is parsing and generating strings. And when you're passing data around, it's nice to have some guarantees that a number, for example, is a number. And I just want to congratulate the folks at Google. This was a little, about 2 months ago, and they deployed trusted types into a non-trivial application. And I really hope I get a chance to play with this sometime soon. It seems like a pretty powerful, but definitely advanced feature of CSP. Another cool feature of CSP I want to talk about, this is a CSP 3 feature, is strict dynamic. It has been in Chrome for some time, and I also found out it's been in Firefox for some time too. I think it could definitely have an impact on the way people use CSP and apply it. This is sort of the third iteration of trying to make securing inline JavaScript better. Each iteration, for the first one that just had whether or not you had unsafe inline in your header, that's the most strict policy and more secure policy you can apply. Using nonces is not the best, but it can be very useful. Nonces still allow for inline JavaScript to be dynamic, which can lead to XSS. But even if it's not perfect, it's so much better. The hashes are kind of hard to use. A lot of people think, oh, well, I'll compute them on the fly. Well, then you shouldn't be doing that because that's essentially dynamic JavaScript as well. It's not necessarily a lessening, but it's just kind of hard. And then strict dynamic, again, makes it much easier to apply by only sacrificing a tiny, tiny bit of security. GitHub will not use nonces or strict dynamic unless we really can't find a way to work around it. But I should not say that you should not use this feature. I definitely encourage you to try it. Let's say this was your policy. This is going back to mostly what we had before. I have to allow unsafe inline, I have to allow unsafe eval and HTTPS, but I want to start applying these nonces. So essentially you supply strict dynamic with a nonce or a hash and unsafe inline and eval for backwards compatibility. New browsers know to ignore the unsafe inline. Newer browsers know to accept the strict dynamic and discard the rest of the string so that it knows which resources to load. Sorry, that was very distracting. The problem with the policy above is it allows any HTTPS URL. An attacker can load any HTTPS resource, including out of data and vulnerable libraries. By adding a nonce attribute to script tags, fetching external resources, those resources will then be able to fetch other resources or add other JavaScript to the application. This sort of transfers the trust from one script to another without having to list out all the possible sources. So here we have HTTPS, maybe we want to list our CDN, maybe there's a marketing integration that requires us to add their CDN and then they want to load JavaScript, and then the JavaScript they load wants to load JavaScript, and you end up with this very long list of 15 hosts that you don't understand, that might be changing over time, that you might not control. But the strict dynamic feature allows you to sort of pass along this chain of trust so that the required libraries can execute the JavaScript they need and they can load the JavaScript you need, and you don't have to constantly worry about updating your policy. Now, that doesn't sound inherently undangerous, it doesn't sound completely safe, but again, you've still eliminated the possibility of having inline JavaScript, which is really the big goal here. So going back to an actual example here, up in the policy, we have strict dynamic with our nonce. So the new browsers that understand strict dynamic will ignore the rest of what's behind it. So going back, our eval script cannot run. Our suite animations can run because it has a nonce tag that matches the header. Same thing with our arbitrary CDN because it has the nonce. That inline script with the alert will run. The image source on error will not. Inline script tag without nonce will not. The eval function will not. But that script we loaded that adds some more inline JavaScript will run because we've implicitly trusted it to add more JavaScript. I found this website today, and I thought it really did a good job of explaining this whole process and how it is backwards compatible as well. CSP is not versioned, which makes things a lot more complicated. Knowing about the backwards compatibility is pretty important. It's become less important over time as the disparities between the browsers are different. And also that these CSP2, for example, has been around for many, many, many years. And the chance that you support a browser that does not support CSP2 is probably pretty low, unless you have a wide variety of support. So it's less important now, but it was much more important going in the beginning and going forward that it'll have to be backwards compatible forever. And we can see all three levels in this policy. So content security policy, script source strict dynamic with a nonce, unsafe inline, HTTP, HTTPS. This feels like a very, very overly permissive policy. Feels like it's the kitchen sink, literally any URL, unsafe inline. But the presence of the nonce and the strict dynamic allows the browsers that understand them to ignore the unsafe behavior without breaking anybody's document. So the strict dynamic allows script which executes on a page to load more scripts via non-HTML parser inserted script elements. So specifically, this means you can't use a implicitly trusted script JavaScript file to use document.write or a trusted inline script thing to use document.write to insert more script elements. You have to use like append element and things like that. So the second one has the nonce here, and this will be understood by CSP 2.0 browsers and above. You might get a warning in your console that it doesn't understand strict dynamic, but it is still enforcing that nonce behavior, which will then ignore the unsafe inline. And then we still have the HTTP, HTTPS. This is just because, you know, some browsers, we just can't break them. So this example again goes on to sort of show that if you could get your hands on a CSP1 browser or a 2 browser, you could show that this script works in every case. I kind of think it would be worth anyone interested visiting this page, look at the source of the color.js file, look at the way this thing works. It's not too clever, but it is kind of interesting. And I think it does do a pretty good job illustrating the functionality. But now I've talked about CSP enough about what it is, but now I've also explained sort of a strategy for applying CSP, but how does GitHub do it themselves? You can't just apply CSP as a HTTP response header in your server config file. It needs to live with the application. It needs to be dynamic. And it also needs to be managed in a way that's easy to understand. CSP is just a string. It is not rocket science. But having to splice and dice a string to make things, you know, dynamic on the fly can, you know, kind of be overly difficult and error prone as well. So provide an easy way for people to adjust the policies. And instead of asking someone, what should the CSP be on this given page, you ask, what is different about this page from our globally defined policy that requires an exception? By providing a familiar and documented API, developers can pattern match on this and copy and paste this safely in other places. And the security teams can then set up a alert to see if they ever see this function called, to maybe give it a second set of eyes. This has definitely caught people from making changes that we may or may not be comfortable with. And having this familiar documented API enables both groups to really get the stuff done that needs to get done. Now that our policy is in enforcement mode, you literally cannot add a feature that is incompatible to the application without security knowing. It's a really powerful feature. And a real programmer, if you hear me, I'm sorry, I'm going to butcher this. I'm going to explain it in a way that is convenient for my story. Since everyone loves Rails, Rails is built using a version of the model view controller pattern. Speaking very liberally, the model is the data. In Rails, this usually represents a row in the database and its foreign key relations. The view is kind of what displays the data. This is where, for example, the HTML that is displayed to the user would be generated. And the controller is sort of what interacts with the HTTP request to then generate the model data, and then, you know, gives it to the view to do what it needs to do to display all that data. And the only important thing here is you wouldn't really apply CSP logic in a model. You probably would have a reason for it, but we've yet to see it. When you have a view that's actually displaying the generated HTML, this can be a good place to modify your CSP. We'll show an example of that later. And primarily, I think the most common place where these things happen are at the controller level. If you're able to, you know, group functionality into, you know, controller behaviors, typically your CSP modifications are going to be similar across the actions of that controller, but they could also be completely arbitrary as well. So these are a few examples of actual GitHub code that's been changed slightly. We have this helper method in our base controller called add CSP exceptions, and that calls the method that would add, you know, generic CSP exceptions to a given page, you know, thus, like, for example, adding a value onto your list of sources, as long as this controller defines this constant. If the constant doesn't define the controller, if the controller doesn't define the constant, it won't run. So in the second controller down below, we've defined the constant, says add foo.com to the list of URLs that I'm allowed to frame on a given page. That before action says, hey, call that method, but only do it on the show action. The show action is kind of like a Railsism for, like, you know, if the index is a list of things, the show action is the page for that individual thing. But maybe this exception only applies to the show action, so we have no reason to, for example, either add it to our base policy or add it to other actions like the index. And then we also have this other controller down here has a much more loosely defined things. You know, it's nice that we can apply exceptions to controllers and actions, but sometimes we need the flexibility to say, you know, I only want to add this third-party source on Thursdays in the year 2021 where the username starts with the letter L. It's a completely contrived example, but you do need that sort of flexibility. And that's not something Nginx is ever going to understand. It's also something I fear these third-party integrations will never understand either. And yes, you could probably build in things to, for example, you know, maybe signal what features were enabled for user, what their, you know, username was. But the flexibility of your own application can really just run whatever you want. And then I mentioned sometimes you just need to do things in the view. This underscore prefix file name above is a Railsism for what's called a partial. It's a reused piece of code that generates HTML. It can be rendered on any given page. So instead of the controller or the action having to know whether or not we're going to render this element, how about just, if you see this on the page, you know, add it to the policy right away. And if, you know, if you render the same thing 5 times, it's not going to add the same host 5 times. Has a little bit of smarts around that. And then just another example of why you can't trust Nginx configuration is if you're ever going to use the nonce feature of JavaScript, the nonce feature of the CSP tags, you know, it's not impossible to add a random number to the header. It's not impossible to plop that value right into a script tag that you wrote, or you could just write a helper called nonce JavaScript tag that does both for you, and you never have to even see the nonce. Little things like this make applying CSP just so much easier. And then there's also another use case. You know, we have a baseline policy, but not all pages are the same. You know, yes, you're used to seeing the GitHub banner and the GitHub footer, and you generally have, you know, the same thing on most pages, but our error page uses a completely different CSP. And so we have this sort of separately defined policy that we can just, you know, use every time we need to. So at the bottom here, we have a helper method that says render 404. This can be called from, you know, just about anywhere in the code. Make sure we set the right CSP, and then we render the error page. We wouldn't want to, you know, an error page is maybe not the best example of something you'd want to, you know, ensure you really had the most concise and strict policy ever. But there are other cases where you're just going to need a whole different CSP, and you still want to build with that idea of start with the baseline, add the exceptions as you need them. This allows you to start with a different baseline. So that's all I have for today. I haven't modified a policy myself in years. I review a couple changes per week, and they're usually pretty simple. People at GitHub are well versed at modifying their own policy, and, you know, by allowing them to discover the problems that our policy creates by adding new features and working with them during the review every time something like this triggers. I do think that there is a general knowledge amongst everyone at CSP, everyone at GitHub, with at least some familiarity with CSP and how to diagnose the problems you run into and how to fix them, or where to go when you can't figure it out. There absolutely have been times where people will come to me with a question about CSP, and some things are just not compatible, and it's not hard to know unless you've really like investigated deeply. And that's pretty much the only thing I do with CSP nowadays. Completely wholly managed by other people. So yeah, go out and apply content security policy, y'all.
Sweet. Apply security policy. Make it everywhere, right? That's
that was a great talk. So I guess one of the things, like Seth and I come across this quite a bit in courses, and you know, it's like the question usually is, or not. It's not so much of a question. It's almost like we can't do CSP. You know, like our apps are too complicated, or we've got a structure that's not, you know, set up for it. And you know, like, is that something that you hear a lot from folks? Do they come to you and ask that, or, you know, make that statement to you often? I mean, because this isn't the first time you've given some tidbits publicly on CSP. So I'm curious.
Yeah, I mean, there's literally things that are completely not compatible with CSP no matter what you do. I think like I've seen people trying to like work around some of these less common things, and the hoops they have to jump through are just impressive and are honestly beyond my understanding of how things work sometimes. But even on like a very basic and simple page, it's just not trivial. And people will ask me, I get all kinds of questions all the time about how do I make this compatible? What do I need to add to my policy? And every situation is different.
Mm-hmm. So like you talk a little bit about the things that are just not compatible with CSP. Do you have any examples of that just off the top of your head, or is it a little bit too nuanced to get into?
It's funny because this just came up the other week. Someone definitely nerd sniped me into figuring out what sort of combination of hashing and would work to allow this bit of JavaScript to work. And the things it did, I mean, Ken, I know I sent this, you saw it. I don't know if you actually looked at it, but it did everything possible to not be compatible with CSP. And I got like 3 levels deep in different CSP fixes to get to like the 4th level and just be like, you know what, this is just not compatible. There's nothing that can be done. And it was only, the thing it was trying to do was trying to be, universal and load on every browser that's ever been written by using eval, by using all sorts of other like nasty inserting inline scripts. And it's just not necessary for modern browsers to do some of this stuff.
Yeah.
And another example is, marketing site wants to source third-party dynamic JavaScript, and they won't even let you review the unminified code. And you're like, well, so you want to just be able to insert whatever JavaScript you want, perhaps on a page that contains a user password, and you won't even let us like see the unminified code or like maybe support a static version of this page or JavaScript for some period of time before we're like forced to upgrade. And some say yes, some play ball, and some say like, no, we're not, like, and we say like, okay, well then we're not a customer.
Yeah.
And then some have just straight up like bent over backwards to like work with us and added, JavaScript APIs that we could use post message so we could frame their content on a site we own, source their JavaScript, but still be able to talk to our application in like a safe way. There's no way we would put their JavaScript on our pages.
What was one of my favorite things was, or is one of my favorite things is when folks have tried to include third-party source and our static analysis tool catches up on them trying to modify the like secure header policy, and through like, for those that aren't familiar, it's static analysis is basically like linting for this constant variable to be like modified. Anyways, that's my favorite thing is like how that tool sort of tattled on people because we had CSP and you would have to make an exclusion for like a marketing widget, for instance. It sort of like tattled and said like, hey, probably not the right thing to do here. That's like probably my favorite thing to come out of our static analysis tool.
I think you give it too much credit. Isn't a regular expression there?
Yeah. Well, okay. Isn't that
how all good static analysis tools start?
Exactly.
It's a regular expression engine.
Yeah. Yeah. No, but it's super cool. Like if you if people wanted to do that in their own their own code base, they could have some global variable defined that has like a list of CSP policy statements and values, and then like if that's ever modified, then you get a notification on it. So, and actually that brings up another question, which is from David Corsi. Is there anything I can use with a very large number of apps to scan each one and give some kind of recommendations on CSP improvements?
I don't know about scaling it to a bunch of different apps, but there are services that will evaluate your CSP and provide suggestions. Obviously, they do it from the outsider's point of view of, yeah, just remove unsafe inline, no problem. But that's obviously the hard part. I am blanking on I think security headers IO was one of them. I think the Mozilla Observatory will also do it, but this is on like a one at a time basis. I'm imagine you could script it if they don't hate you for doing that. But I don't know of like a way to mass scan an entire enterprise.
All right. Let's see if we have any other questions.
So, yeah, I mean, my question, like, again, being a consultant on the outside, looking in at most of the sites that I review nowadays, I don't see a lot of good CSP. I'm going to be honest, right? Like most, especially small to mid-sized companies, if they have any sort of CSP, it's a shock, right? I'll be honest. So like, where do you go from there? I know you always say, hey, it's easier to build from the ground up, but that's not always possible. Like, so what do you recommend? Just like broad swath, how do you get them to dip their toe in that, coming from the outside?
Well, I mean, obviously you got to start somewhere. Some CSP is better than no CSP. It's an iterative process for sure. There's some talk about like, well, do you focus on removing inline JavaScript or do you focus on getting a policy you can enforce?
Yeah.
And I would probably say it's more important to get a policy you can enforce as long as you're able to test it on reasonable people. You know, the policy when I came to GitHub was actually, the hard part was done. They didn't have any inline JavaScript. They hadn't been allowing it for some time. And it was just a matter of cleaning up the rest of the policy and adding more directives. And, you know, just because we had something on one page doesn't mean it needs to be part of the global policy. So once we had a static policy that was good and we started adding this sort of dynamic policy, but then using that as a way to tighten our policy while not making things worse going forward, you know. So generate a baseline, enforce it, add the dynamic capabilities to tighten it, but also going forward.
Okay. Makes sense.
This, I mean, it came from a straight up use case. Like one of the first applications I applied CSP to had a WYSIWYG on one admin page, and it was allowing unsafe inline for the entire application. And it was like, that's okay, but we're like one step away from like making this application like 99% more resilient to XSS. And sometimes it's that easy.
Yep. Okay. Yeah, that makes sense. I'm just thinking of it from a, you know, hey, I'm presenting a report or I'm like talking to the developers about CSP and where to start, right? Like, and so I think the advice of identify as much as you can where it's easy and then iterate from there is good advice in and of itself.
I would almost also say, don't even bother with the other directives first. Just do script source. You know, like I said, like I don't think CSP's job is to prevent exfiltration. Specifying where you make XHR calls to is great, and it's helpful, and it's self-documenting, but like that's not the threat I'm really worried about. And even if you do specify where you load images and XHR and whatever, you know, if a redirect occurs, there's nothing preventing that from exfiltrating data. There is a proposed directive, but it doesn't exist, and therefore there's no protection.
Yep. Okay, cool.
Oh, but also do object source none because that allows Flash. So script source and object source. I'm sorry.
Object source, script source, object source none. Cool. All right. Well, we'll tweet that out. Neil, this was awesome. You know, I know we're pushing up, I guess, against the time that we wanted somebody else. Not, I'm saying that all wrong today. Sorry. It's been super interesting. And, you know, I know, you know, we were not necessarily on the camera the whole time, but I've been following all the stuff and just getting it outlined as far as what each of those different pieces do, and a test that shows that out with the code is very useful from my perspective, and I'm sure it will be across the board. So thanks again for coming on. Ken, anything else on the CSP front?
No, just appreciate you coming on and agreeing to do it. And we had to move the dates a bunch. Just, you know, with the pandemic, things happened and logistics, you know, I appreciate your flexibility on that and all of our speakers for that matter. So thanks, Neil. Appreciate that.
Yeah. Appreciate it.
Thanks for putting together, and thanks for having me.
Yep.
And I can't wait for Locomoco Sec when we can get back to it.
That is, so yeah.
More on that later, Steph.
Yeah, I'm sure.
All right.
Thanks, Neil.
Later. Awesome. Well, we've got Paul, and I want to make sure. Well, let me hear. Stefan's joining. Let's see. Stefan, we cannot see you or hear you.
I was specifically and purposefully being quiet there. No, I think it's going to be very interesting. Paul and I worked together for a while. He's a close friend of mine, super smart guy, works in some interesting places in cryptography. He's also the author of Pi Crypto. We can chat about those sorts of things. And Paul is filling in, actually, for another speaker who was out sick. And so I really do appreciate Paul coming on now to fill in. So Paul has like 15 or 20 minutes worth of time to fill. And then we obviously can chat crypto. We can chat, any of the things that come up in questions from the talk. I think there's plenty of things that we can do to pick Paul's brain about crypto and about elliptic curves and all sorts of fun things that he deals with. So I'm super excited to have Paul on. So I'm going to add Paul to the stream. Hey, Paul.
Hi, everybody. How are you doing?
So, Paul, you're going to, do you have slides or anything, or are you just going to do an interpretive dance? I know you have done those before, so.
I do have slides. Hold on one second. Let me figure out how. I'm pretty sure I can make this actually work. We're going to find out. So if I do this.
It's been a challenge for all of us.
Hit share screen, and then I do that second screen. What do we see? I think it actually works. Look at that.
There you go.
So, all right then. Yeah, so one thing I have to correct, Stefan, is I do not write Pi Crypto. Right, PyCA cryptography. Pi Crypto is a different.
I'm sorry.
A different problematic library.
he writes the good side of those sorts of things from Canada as well. So
that's right. It's still allowed there at least. So all right, I guess I can go ahead and get started. And like I said, it's probably gonna be around 10 to 15 minutes, depending on how quickly I speak, and then we can obviously. You and I we can all have a conversation about whatever you'd like until such time as I have to go to my next work meeting.
Well, thank you for your time.
No problem. All right, so let's go ahead and get going then. So I'm here to talk about ECDSA, which is beautiful, elegant, and incredibly fragile. We're going to talk a little bit about how ECDSA works in practice. And probably, well, more than a little bit about how I learned to stop worrying and wrote this talk in about 2 hours today after Stefan frantically asked me to. So first, some administrative trivia. I am an emergency replacement speaker. I have not used PowerPoint since classic Mac OS. Yes, this is a built-in theme, and it's got like a greater than sign, so it seemed like fate. I should have made presenter's notes, but time makes fools of us all. And speaking of time, this is going to be about 10 minutes long. So like all crypto talks that don't run through 100% of the math, this talk relies on an argument from authority. So why am I authority you should trust? Well, my name's Paul Kerrer. Hi. And I've been doing security and cryptography for the past 15 years. I co-wrote Frinkiac, a website that lets you create memes and GIFs from almost any Simpsons episode on a frame-by-frame basis. This has nothing to do with cryptography. I just think it's really neat. I'm also one of the founders of Fish in a Barrel, a fake business that talks about how to stop using memory in safe languages. Also not cryptographically related, but more on that later. I ran the cryptography team at Trail of Bits with Stefan, and now do Oracle's cloud crypto, and that any of their cloud cryptographic maturity problems are my fault. And finally, I am the author and maintainer of the Python Cryptographic Authority, various projects that we have, including cryptography, PyOpenSSL, Pinnacle, Bcrypt, and several others. So, but Paul, crypto talks have a lot of math. So here we are, 90 seconds in, and you're already complaining. To set your mind at ease, let me assure you that this is pretty easy math. So it won't be boring equations that only a PhD can solve. We're not going to go deep on theory, so you won't have to hear the words group operation, except just now when I said it. And again, this is a 10-minute talk. I promise you cool posters at the end. So actual talk time. What is ECDSA? Well, I mean, it's in one sense, it's a signature standard based on DSA, which stands for Digital Signature Algorithm, which enjoys a wonderful reputation and has no major issues whatsoever. It uses elliptic curves instead of big integers modulo some other big integer. And of course, it makes you sound smart when you say elliptic curve in a sentence, and therefore it is good for your career. But what is an elliptic curve anyway? This is a picture you've seen 1,000 times. It's also not a useful model of an elliptic curve for many, many reasons. Forget I showed it to you. Here's all we need to know. Elliptic curves are some mathematical equation that we can choose a point on and then perform addition with that point to get other points. No, really, in a lot of ways, that's really all you need to know. And of course, multiplication is really just a lot of addition. As an aside, these mathematical operations are called addition and multiplication, and they act consistent with the mathematical definition of those terms in the group we've created. But be aware that since these are not basic integers, the actual operation is not as simple as something like 2 times 3 equals 6. They're not actually particularly complex, and there's a concept of whether or not you have a mathematically complete group and things like that. None of that matters, and we're not going to dive into it today. So what makes these things useful, though, right? Like we've talked about what they are, but what makes them useful is that there's a security assumption underlying them called the discrete log problem or the elliptic curve discrete log problem. But really, all that matters is thinking about it this way. Given a large secret scalar, which is a very large, big number, and a base point, which is defined as part of the shared information about a given curve that every system knows a priori. So basically, like when I say like, oh, we're using the prime 256 curve, then like there's a known equation and a known base point that everyone knows, and that's known a priori. We can multiply the secret scalar that we've defined or we've come up with of ourselves and this base point to create a public point. And with just that information, like if you just have the public point at the end, it is difficult with a capital D to determine what that secret scalar is. That's it. That's all you have to know. And that's really the underlying basis of why this is a secure model of operation. So now that we know roughly what an elliptic curve is, what's an actual ECDSA equation look like? So it's really just this. This is the entirety of the equation. I'm not even simplifying it really at all, other than we're kind of eliding the complexities of what point addition and point multiplication actually are. But first we pick a random integer k in the interval 1 to n minus 1. N in this interval is the order of big G. So rather than explain what this means in great detail, we're going to hand wave a little bit, as you can see with my constant hand waving, and say that n is the number of points in the subgroup created by the generator G, which is also called the base point. So you heard me say base point earlier. Base point and generator, same thing. You may also hear me say K and nonce. Those are interchangeable terms again. I apologize. I frequently mix the terms because I'm used to people knowing what I'm talking about. So once we've done that, we've got to pick our K. Now we need to compute a curve point. So we say that K value times the base point, G, which is the generator, gives us a new point, which is just XY. And that's a very, very simple point there. The numbers themselves are very large, but X and Y are just X and Y. You can think of them in a Cartesian plane if it makes it easier for the way you're thinking. So once we have that, we need to compute the value R, which is just X coming from that XY modulo N, which is again the order of that of the generator. So that's a big number still. And now we also need to generate S, which is K inverse. So that's the modular multiplicative inverse of our nonce. Again, we're not going to talk too much about what that really means. It's not that hard to derive one. It's like a regular inverse, but it operates inverse inside of the group modulo N. So then we take that, we'll multiply it times the hash of the message, which is generally represented as an integer in this particular case, plus the R we derived times a private scalar. That private scalar is a derived, like that's commonly called the private key, and it's just a number you've effectively gotten from a random number generator. So all that is taken then modulo N, and we have our S. So that's it. That's the entirety of the equation. You can see that it's mostly kind of high school algebra style stuff. And you get an RS tuple at the end of it, and that represents your signature. So when you see a signature, sometimes it's represented as a big endian byte string. Sometimes they're ASN1 DER encoded sequences. Sometimes it's just those two giant integers in a row. It doesn't really matter what it is. It's all the same thing. You can just transform between it as needed. So when you need to, now that you've signed something, you need to be able to verify it, of course. So to verify it, you need the public point Q, which is literally just the, let's not go too deep. There's a public point. It's associated with the private scalar. It's fine. In reality, it's just multiplying the private scalar by the base generator point, and then modulo, of course, the group order, and that tells you what your public point is. So we need to compute U1, which is just a hash of the message times the modular multiplicative inverse of the S that we derived from the signature, modulo N, and U2, which is R, again, from the original signature we had, times S, the modular multiplicative inverse of S, modulo N. Then we just do U1 times the generator plus U2 times the public point, and that gives us an X and Y. And if X modulo N is equal to R, then it's valid. There's a little hand waving there, but that's effectively how it works. The hand waving is around error cases, but this is, for all intents and purposes, how ECDSA signatures and verification actually does work. But of course, I was telling you that things are not great in ECDSA land. So what can actually go wrong? Well, when signing, R must not be equal to 0 for a given K, plus the secret key plus the message. So you have a K secret key message tuple effectively. If it turns into, if the calculated value, as you saw from the previous slides, is for R is 0, you need to pick another K. Same thing handles to S as well, or same thing is true for S as well. If you receive an S of a value of 0, then you need to try again. And then finally, and this is most importantly, everything about K. K cannot have any detectable bias, and it must never be revealed. So it can be deterministically generated, but God help you if you use a faulty random number generator. K selection is the single biggest failure mode of ECDSA. With just a few bits of bias and LLL, which is a lattice recovery attack model, you can recover the entire private scalar. If you reuse K on 2 different messages, you can immediately recover the private scalar. This means that K can never be revealed, K must always be different, and K cannot leak any information about what that K is, ever. When verifying, the math that you saw before actually allows certain forms of signature malleability, which is to say that RS is not the only signature tuple that's acceptable. You can actually do negative RS as well, and a few other forms of it if you're not careful. And so implementations need to check that R and S are in 1 to the n-1 range again. You need to check for the identity point, which is also called the point of affinity, and it's a special point in elliptic curves that turns out to cause all sorts of problems if you hit it at the wrong points. So you need to check for that point at a variety of times. And you also need to ensure that provided inputs, when you're validating this, are actually on the curve that was actually selected. And like any arbitrary XY value is not a valid point on a given curve. So you have to verify that it's on the curve. That's even more important on something like elliptic curve Diffie-Hellman, which we won't be talking about here, but you can actually perform small subgroup attacks there, where if you don't validate that the point's on the curve, you can force the exchange key to be a much, much smaller range, and you can guess it effectively. And finally, in general, we care a lot about side channels, right? Your implementation needs to be side channel free, much more so than many other cryptographic algorithms. Writing timing invariant curve implementations is tricky business if you're living in this land with like Prime 256 or SecP 384R1 and things of that nature. K is so critical, and even tiny side channels can leak a few bits of the chosen K, which is more than enough. So, wrong in practice. I said it was very important to never reuse or even reveal K. Why is that? Well, given the starting equation you see at the top of this, which is how we computed S when generating a signature, you can see that some simple algebra shows how K is the only unknown if we're solving for the private scalar, right? So we start with that S derivation, and we're just moving stuff around exactly the way you would in high school algebra. And at the end of that, we have a private scalar is equal to the modular multiplicative inverse of R times multiplied by k times s minus the hash of the hash message. But it gets worse. If you reuse k for 2 different messages, it's also trivially game over. Again, simple algebra shows how we can recover k, and then we can recover the private scalar from the previous k reveal operation. I'm not going to run through all this again, but as you can see, you can basically subtract the 2 from each other. That solves for k. Once you solve for k, you can go back and plug it into the previous one, which is this one, and you can obtain the private scalar. And then the scariest one, bias k's. So we won't go through the math here, but tiny amounts of bias in the selection of k are all that's necessary to recover the private scalar. These attacks use a concept called the hidden number problem, and for today it will remain hidden. You can leak information about the chosen k very easily through side channel attacks, as I previously said. Since the standard set of curves people have available were not designed for ease of timing invariant implementation, this makes the entire construction of ECDSA very fragile. SecP 256R1, aka Prime 256, commonly has constant time / timing invariant implementations, but like larger curves like P384R1, which is something that the US government requires for CNSA guidelines and in general for top secret handling, typically does not, which ironically almost certainly makes it a less secure curve despite its larger size. So some examples of attacks that leverage nonce bias include Minerva. It's an entire class of attacks. There were many vulnerable implementations. At the end of this, I've got some resources that has a link to it that you can take a look at it. Ladder leak is also another one that came out very recently. You can see the paper on IACR ePrint. The YubiKey FIPS series of devices had a bug late last year that turns out that they had a problem in their RNGs, and up to 80 bits could be fixed of a nonce. 80 bits is a lot, and it turns out you can recover the private key from biased RNGs like that in only 2 to 3 signatures. And of course, the famous PlayStation 3 issue, which was that they used the same K forever, for every signature they ever did, right up until the point where the fail overflow team noticed and extracted the key based on this very simple math, and many, many more. So what's better then? First of all, definitely not RSA. RSA is an incredibly complex algorithm that has many more failure modes of operations because it's flexible in so many different ways. If you're willing to constrain a lot of the different parts of RSA, you can limit your failure modes, but even then, like many of the things that make it fast, make it vulnerable to fault attacks if you're not careful, and it just turns out to be a big, big mess. You can limit your risk to a certain extent by generating your K deterministically. So RFC 6979 by Thomas Pornin has a bunch of advice around how you can do that, and there are a variety of other ways to do it. One of the big keys of that is that you must mix in a secret, which means you're going to be hashing in to derive your K, you're going to end up hashing in your own secret scalar. Because otherwise, if it was purely deterministic from a message that the attacker could see, then they could derive what that K was, which, as we already said, would be revealing your K and leaking your entire secret key. Another thing you can try is using blinding to try and make it so that measuring the timing attacks against it, against these various implementations is harder. In my experience, blinding really only kind of shifts the goalposts. It doesn't stop anybody. It just makes people work a little bit harder. Gets a new fun paper for a postdoctoral student. But in general, I would say that's futile. And then finally, you can be very, very good at writing sufficiently performant and timing invariant implementations. There aren't a whole lot of people in this world who can do that very well. In fact, there are so few that even the most common open source implementations have very limited numbers of timing invariant implementations. So that's probably not the right answer either. As you might guess, I believe the right answer here is probably EdDSA in the long term. That's Twisted Edwards DSA stuff. It attempts to simplify a variety of the implementation challenges and complexities of ECDSA such that you don't have to do things like choose K, and that all the math that you're doing is pretty hard to make not be constant time by default, although it turns out that anything is possible when you give it to programmers. So even then, we sometimes see timing problems there. But in general, it's made to be hard to misuse because it's hard to misimplement. So I believe that tools like that, as they become federally standardized so that people in government and banks can use them, will be good. And those of us who aren't bound by that should try and use them even more quickly. So I have a few resources that I'll sit on here for a minute. And then I have one last bit of information, which is something completely different. So I told you I have a side gig with Fish in a Barrel, a not real business. But are you tired of 60 to 70% of your security vulnerabilities being memory related? And have you fixed thousands of memory safety related bugs, written countless fuzzers, and lamented the cruel God who would create such a pile of garbage for us to build a society on? Well, Fish in the Barrel has an answer for you. Stop writing memory unsafe code. We call ourselves Fish in a Barrel because memory unsafe systems make finding major security vulnerabilities as easy as shooting fish in a barrel. And we hate that we exist. We want you to evangelize incremental migration of memory safe tools in your own organization. Heck, we'll even pay you to eliminate memory unsafety with a bounty program that we launched just today. But if you don't want to do that, you can also buy these incredible posters, and you can show your hate for memory unsafety and shame your C and C++ loving coworkers. So you can go there, check those things out, and think about ECDSA and the ways in which it can be both beautiful and fragile. Thank you.
That was hilarious.
Yeah, seriously.
That was a great presentation. Presentation.
Oh. Well, thank you. It was a labor of love.
No, and you know, Paul, you and I have talked about a lot of these things and been on assessments together and whatnot. So we've certainly seen a lot of these sorts of things. But for folks who don't see cryptography very frequently, like how common are these failure modes that you're talking about? Like, how often do you see these in assessments or in your work elsewhere?
So in assessments, we saw them reasonably often. It's not super common to find the most egregious failure mode, like the PlayStation 3 style one. Like in general, once there becomes enough press around a specifically like embarrassing way to screw something up, people are relatively good about it. I'm not saying they don't make that mistake, but it's not super common. But like in terms of K reveals, or especially these non-SPIAS attacks, they're kind of constant, right? Like in many ways, unless someone's done an incredibly rigorous job of building a timing invariant system and then somehow building like the instrumentation to prove that that's true, it's almost impossible to prove that it can't be done. And instead, the default assumption needs to be, this is probably going to leak. What happens when someone with sufficient education and inclination attacks it? And that becomes a very challenging thing to resolve, right?
Yeah, and I also think there's a lot of confusion. I mean, obviously, I'm not a cryptographer. I'm not a crypto engineer. I'm not doing any of those sorts of things. But very often you see clients who want to, or see developers who want to do the right thing. They want to sign data. They want to do something, and it's really not trivial to come up with a simple way of doing these sorts of things. If you're a dev, is there something like libsodium, or is there something that you should be using there to make things very simple that are like basically you can't shoot yourself in the foot with any of these sorts of failure modes?
No, absolutely. So I think that unfortunately we don't have a one-size-fits-all approach, obviously, yet. That's something that it's very near and dear to my heart, as you know, and will be a thing I will probably be working on until the day I retire. I hope I get it done before then, but we'll see. But certainly right now, like depending upon your use case, libsodium has constructions that can limit the damage and limit the problems you can have. And Tink, which is a Google project as well. Well, not as well, sorry. Libsodium has nothing to do with Google. Tink is a Google project, and Tink is a pretty good set of cryptographic recipes, as I like to call them, right? Higher level constructs that solve specific use cases, and in doing so, limit the number of like dangerous like knobs that you can turn.
Yeah, and that's an interesting point too. Like you mentioned RFC 6979 and whatnot. There are things out there, for how to do these sorts of constructions properly. But I don't think there's as much guidance, like simple guidance out there for developers, like that sort of thing. Like, hey, if you're going to do X,
you must do Y. Obviously, there's the Latticore cryptographic, right answers sort of blog. But what do you recommend for folks who are trying to avoid some of the failure modes and some of the things that you talked about today to do? What should they look for?
I mean, the thing that I care about most is an opinionated. So I come from the more modern class of cryptographic engineer, where I believe that opinionated constructions that have one well-oiled joint make the most sense. So if I was a non-expert developer looking to minimize my risk, my suggestion would be to look for implementations that demonstrate a knowledge of the danger of their own primitives. Like, you're looking for something where they tell you that they have a story for, like, hey, you should use this for storing data of this size, or you should use this when you need to have seekable authenticated encryption, and then have like documentation around the ways that it can fail you if you use it in the wrong fashion, or if they have APIs, depending upon how fancy your language is, right? You can have like type safety stuff that literally prohibits you from doing maybe the bad things. A good example of that, and something I personally failed with in my APIs, although I'm going to try and blame Python for this, even though I really can't, is that you should never really use a ECDSA key as an ECDH key. That is an unwise thing to do. And if you have a type system, it can say, no, those things are different. You can't like pass them between unless you do an explicit conversion. And that way you'll never have a case where that's happening and an auditor can't find it, or someone who's reviewing the code can't go, well, why did you do that?
What is the failure mode for that? For folks who don't know ECDSA and ECDSA and ECDH, like, what are they running into there?
So in some senses, it's a cryptographic hygiene problem. It's not so much that there's like an explicit cryptographic problem with doing so. It's that using them for using the same key for two different purposes significantly increases your risk profile. But the other side of that is that ECDH's failure modes can be much more severe. And if you're not very, very, like, I say they can be much more severe. ECDSA's failure mode is obviously extremely severe, but ECDH's failure mode can be such that you perform an exchange, you think you've derived a shared key that's safe for you, and in reality, you've derived a shared key that's like got a possibility space that's just like 2 to the 8th, and an attacker can trivially enumerate that in like 100 nanoseconds and know which symmetric key you've actually derived. And when they've done that, there's a bunch of ways. There are additional things they can do that potentially compromise your ECDSA key, at which point all your signatures that you thought were safe are broken because you were using this for a key exchange. So like it's just unwise to mix keys for similar purposes. Kind of the same reason why it's actually unwise to use an AES key as an HMAC key, even when you're just HMACing the AES payload. You should really have those be two separate keys.
And you actually brought up something that I wanted to ask you about, or you bring me to something that I wanted to ask you about, because you and I have been on several assessments where maybe folks didn't understand when you would use HMAC versus when you would use a signature, or maybe they conflated the two or didn't know one or the other. Like, when do folks use these sorts of constructions, and when would you use an HMAC versus when you would use a signature, that sort of thing? Like, why do we have these differences?
Sure, absolutely. So like an HMAC is appropriate in a scenario where you are okay with pre-distributing the key to both sides. Because to compute an HMAC and to verify an HMAC, you need to have the same key available to you. So for example, that makes it a very bad candidate for, say, like authenticating a vote from a voting system up to a server. That would be foolish. In a model like that, in the abstract, you would much more want to be using an asymmetric algorithm where you have a public-private key, because the public key can be distributed to anyone. It can be used for verification. It can be used, if it's RSA stuff, you can use it for encryption as well. And also you can do that with ECIES using ECDH, but like that starts to get a little, we start to get into acronym soup very quickly there. But yeah, like an asymmetric model is, if you need a distributed system, then you obviously want to have an asymmetric model pretty much immediately, because you want to be able to have like things happen asynchronously, and you want to not have to have a central root of trust that cares about anything. You want to distribute that such that you can verify trust without ever having to talk back to the central authority. But and the other component for an asymmetric system is obviously when you have an asymmetry in your trust relationship.
Yeah, and I think that happens much more frequently based on our experience and based on the sorts of things that we see, you know, just with the systems that you and I have worked on and clients we've worked with. I think that happens much more frequently than people suspect, because these sorts of constructions are very difficult to know and use and understand. The other thing too is you talked about EdDSA and like Edwards curves and those sorts of things. I have nothing to do with them, but when you're thinking about like Ed 25519 and those sorts of things, why do these alternative curves exist, and how do they come up with these sorts of things, and why do I have like, you know, an Ed 25519 key and then other types of keys for SSH or that sort of thing there?
Sure. So like there's a bunch of different ways you can construct elliptic curves, and they can be in a bunch of different forms, including things like Weierstrass form and twisted Edwards form and a bunch of others. It turns out that different values plugged into these curves can have mathematically advantageous properties in terms of being able to compute things more quickly. So part of the thing that's come up, I should also say there's a secondary component, which is that there are a variety of secondary properties that curves have, most of which are not pleasant and you don't want. And so you need to pick your parameters such that you both have a mix of good performance, good security margin, and minimizing / eliminating the bad things that might happen on your curve. So like some of that is like your curves can be of prime order, your curves can actually be binary fields, your curves can have different values of cofactors. There's things called J invariance on curves. There's all sorts of things that you have to care about. Twisted Edwards curves have a very, very nice property that they, well, I guess I shouldn't say, this is not exclusive to Twisted Edwards curves, but it turns out to be easy in this form, which is that there's a concept called a Montgomery ladder, which allows you to do these group operations inside of the elliptic curve group in constant time, basically for free, which works really easily, and it's very hard to misimplement. And it turns out that Ladder Leak taught us that people can still misimplement it. It's just less common than the problems that you see with Weierstrass addition and multiplication. So I guess to close that one off, because you asked me a really broad question there, Stefan. It turns out that like we continue to look for newer curves that have more of the properties we want and less of the ones we don't want. And what we've discovered in the last 10 years is that one of the properties we don't want is difficulty of secure implementation. And so EdDSA helps a lot with that.
And one last one, I think we're going to take an intermission before the next talk lands, but one last question. If folks wanted to read up on how to not make some of the mistakes here, or if you had any like generic reading that folks could do, what would you recommend that they look into?
Sure. So the easiest thing to start with is Lawrence Van Houten, LVH, who's with Adecor, wrote a book a long time ago called Crypto 101. So you can go to crypto101.io, and it's a free PDF that you can read. And it gives you a lot of grounding in a variety of cryptographic concepts. Once you go from there, there's Dan Bonnet and some others wrote a thing called a graduate course in cryptography. That's a much more advanced piece of kit, but it is still relatively approachable, and again is a free thing. And then lastly, I'll toot the horn of my previous employer here, and I would say that the Trail of Bits cryptographic posts are very good, and my former team does great work, and Stefan doesn't get in their way too much, so it works out fine.
I, in no way, shape, or form, want to get in the way of cryptographers. That ends in math discussions that I am not I'm not there for. There's all sorts of things. They get ornery. It's not a good thing. I usually just make sure they're well fed and watered and everything. And the cryptographers mostly go for themselves. So it's perfect there.
Absolutely.
Well, Paul, absolute pleasure. Again, thank you so much for joining last minute and taking all these questions and putting up with me as per usual. It was an absolute pleasure.
No problem, anytime. And I have to leave this by turning on the green screen since I had my green shirt on.
So I think we're going to take a 10-minute
intermission before we go to the next round. Seth or Ken, do you want to say anything before we go there, or do you want to display a screen?
No, yeah. So I'm gonna just share out a screen saying that we're gonna be coming back shortly. We have 2 talks left, Seth and ours, or Seth and I's, and then Corey Dr. Us.
My talk.
Yeah, thanks,
Cool.
Paul.
So-
Thanks for hopping in. That was really interesting. A lot to read up on my front. So, but appreciate it.
Absolutely, no problem. Talk to you guys. Well, I'll see you guys online in just a little bit.
Perfect.
All right,
Thank
thank you.
Hey,
How's it going?
so, and we're live with our 100 and something episode of Absolute AppSec, also known as MidSummer Nights Con this year, or this week at least, right?
This week, yeah.
I guess we can allow Stefan to introduce us, because that's
Should I?
yeah.
Heather should introduce you.
Yeah, there you go.
She's the most professional of all of us.
Yeah, but I don't have that like general rapport that you guys have.
It only took us about 102 episodes to get there, so just it takes
And
a
years
while.
of working together as well. Yeah.
That's why I drink.
Yes.
Is that the only reason why?
Cheers.
Are you sure that's not a product of being in this industry?
Oh, that's a whole other topic.
That's a whole other. Yeah, that is a whole other topic. We have discussed that in the past, but
We have. Well, Seth, do you want to get started on this presentation?
sure. Let's
All
go
right.
for it.
Our very experimental presentation. We'll see how this goes.
Live on ice.
Live
on
on
ice.
ice. Yes.
All right. Let me see if I can figure out which one.
Well, while you're doing that, oh, perfect. So Seth and Ken are going to wander through the infosec burnout, some other areas that we've generally touched upon on the show. Lots. I think it's going to be a lot of fun. There's some great art that's inspired by truly an amazing person, and he's so humble and kind
And good looking, lots of friends, smells terrific, one of the smartest people he knows.
exactly.
Yeah.
Never at a loss for words.
Wow. Thanks, Stefan. That feels so good to my heart.
But no, I think this will be a lot of fun. Very interesting stuff. They're also going to go over some of the code review things and other stuff that they work with. So I'm really looking forward to this. Not the least because I love the art. But Seth, Ken, do you guys want to take it away from here?
Sure,
Yeah.
yeah. We'll get started. Should be an interesting one. All right, I'm
Yes.
going to set this as our primary window, and we shall get started. So, Chronicles of True Risk by Absolute AppSec. From the creative minds that brought you Seth and Ken's excellent adventure and the Absolute AppSec podcast, and co-ideaed, not sure if that's a word, this conference with Stefan and Heather. We are back for another adventure. Embedded and external in the rise of risk. So embedded is going to mean essentially your staff. That's what that represents. That's what this person's character represents. We try to narrate this comic book live, improvisational style.
Live on ice, yes.
Live on ice.
Whereas external, represented by this character, means consultants and those outside of your employ, I guess I should say.
These are researchers and
Researchers? Yes, consultants.
rapscallions such as Seth.
Rapscallions.
External.
External.
And here we have Risk.
Risk.
Beware! He's everywhere. Oh
He's
no.
everywhere. And he's increasing at an enormous rate. Look how big.
He's ginormous. And for those of
Ginormous.
you that aren't aware, this may or may not be loosely based on Stefan.
How good looking. Yes.
How good looking he is in that mask. And Risk is spreading everywhere through apathy, through fear, through FUD. It's just everywhere.
Through barbecue, through Vegemite. You've got to beware of Risk.
Brian Adams, probably he's responsible, I'm sure, for some of this risk.
Not Alaska. A lot of risk comes from there.
Not a lot. Sound
Not
the
a lot.
nerd alert. An unamused external responds.
Oh, risk can be found. It's made up of a few parts we can target. So we have to take down the risk by taking down those targets. Or this quote, whichever one you choose.
Embedded phones in from Locomoco Security Conference in Hawaii. And Seth, external, if you're not aware, Locomoco Security Conference occurs yearly in Hawaii. Obviously not this year, but most years.
I don't believe it. It's a figment.
But which parts do we target? Embedded asks external.
You must target all of these things. I hear that CSurf is big nowadays. Or maybe Tavis, watch out for him. XSS, and anything that you can find on our NetSec. That is important. Anything.
Friggin' Tanner's the root problem here.
Yes, in the IT department or the admin, whatever, right? Whatever.
Embedded says, disagree! But without an exclamation point, so it's more like disagree.
Disagree? There should be a question mark after that.
Disagree?
Disagree?
Well, maybe some of those things. I think some of those things might be relevant. Meanwhile, risk intensifies.
Watch out for risk.
It's coming for you.
It's coming for you. It's definitely all of the things. Everything feeds into it, which means you have to worry about all the things. Which is not an answer that anyone wants, but that is the case.
It can't be all of those things.
All right. Let's talk about risk.
Yes. Let us chat, external. Let us ponder these
embedded.
These individual issues. Let's chat about them. Let's talk through it live. Oh man. All right. So maximum logi has been reached. Let's switch over here. All right. So I'm going to remove these two and it's just going to be a discussion. So let's get into it. Let's figure out, let's talk about the state of AppSec, our opinions, our experience, what exactly has been of the items that you listed, which of those we should talk through. I figured we could start with the OWASP top 10. That was on the list.
Yeah, I mean, and I feel like we almost need some background here too on why we came up with Chronicles of Risk, and the discussion that we're trying to make at this point. Okay, so in our secure code review course, right, we always talk about prioritization and we always talk about risk. We always talk about the top 10. And if you have ever been involved in any sort of an external assessment, what are the findings that always show up? Ken, what always shows up in those reports?
Outdated software.
Okay. Yep.
Crap from last year.
A lot of stuff. Yes. A lot of stuff. The OWASP top 10, right? Like you start talking about authorization issues like least privilege. You start talking about cross-site scripting. You talk about cross-site. I guess cross-site request forgery isn't necessarily a singular point in the OWASP top 10, but it's in there underneath authorization, the authentication, broken authorization, right? It's these items that show up over and over again in those reports. And from an external perspective, those are obviously the most important things because that's the stuff that we see in every single application. If you've written a report, if you've done any sort of an assessment, you've been involved in a bug bounty, you find these issues, and that's what you're promoting to the company as, hey, guess what? This is what you need to go work on, right? And I mean, I know from internally and being involved in internal teams. Now, Ken and I could probably flip back and forth as far as who's embedded and who's external, right? But it realistically, we've been in both of these different cases, right? We've both been embedded in organizations. We've both been consultants. We've both been bug bounty researchers. And we're trying to figure out how to evaluate the risk and present that in a form that really makes sense for the business and the developers that you're dealing with. Am I out of line there, Ken? Is there something that I'm missing?
No, I don't think you're out of line at all. I think that, what we're concerned about when an assessment, occurs is we're looking for the things that like truly have impact. And I think that's one of the topics we want to talk about is what truly has impact.
Yeah.
I mean, for me, what truly has impact is anything that goes against, our mission statement, right? What is our mission statement? And each company has its own mission statement. For us, keep private data private, keep sensitive information sensitive and private.
Yes, but the fact that you have a mission statement and can refer to it just tells me that you're still in like that Silicon Valley bubble, right? Because what are most Fortune 100 or like big companies that you go to? What is their mission statement?
That I've gone to in the back, that I've gone to as a consultant, because that's pretty much my only. I guess I've worked internally at a few large companies, but I couldn't tell you what their mission statement is, and I couldn't tell you exactly what maybe even their AppSec team's mission is.
Yes,
no clue.
Exactly, and logical. Or Stefan just brought it up. He said the mission statement is mainly make lots of money, right? Like most companies exist to make money, so. You can't argue with that, and anything that detracts from that mission statement, and definitely is a problem. And that this is where risk comes about. Like when you start talking to those big companies, I do a lot of work with financials, with other places. But every time that we get in and we're talking about risk, especially from like a threat modeling perspective or a security architecture review perspective, however you want to handle it. They're not necessarily approaching risk from a security risk perspective, right? And I think that's where we fail as information security is we talk risk and we're like, it's all about the exploit. And a bank has a really good idea of what risk is, but financial risk. And so me spending lots of money or them having to pay me lots of money as a consultant to help them take care of a security risk is probably more of a financial risk, and that's what they care about as opposed to the security risks in and of themselves.
They may understand risk, but do they understand their risk? Are they objective? Do they know where all their assets lie? Do they know do they have a risk assessment for each asset? Do they really understand what we're talking about here? When it comes down to it, that's what I'm talking about as an internal or embedded person. That's where it comes down to is I want to know what should I actually be worried about at night? Not what's my what's my compliance risk or my this risk. I want to know exactly what I should be thinking about. And that's one of the areas I'd say with assessments from external. That's the when I get a report from a bug bounty or I get a report from an assessment, that's where the risk seems a little bit different. It seems centered differently. It's maybe more like probability and likelihood, maybe some impact sprinkled in there. There's a quite a few things that go into it, I guess. But in reality, all I'm concerned about is, does it go against my charter? Does it go against what I'm trying to protect?
Yeah.
And what am I trying to protect? That's in terms of, again, asset management and identifying risk on those assets.
Yeah. And to your point, right? Most of the time that I as an external person, I come into an assessment, my scope is defined by you as an embedded person, right? And I can't tell you the number of times that my scope is embedded to something that in the long term does not matter, right? If I objectively look at it, I'm analyzing a mortgage calculator that's written in JavaScript that doesn't actually run on your servers, right? Why am I looking at this? It's because somebody inside the bank decided that there was a risk associated with it, or somebody inside the organization did that, and they scoped me to that risk. And so it's almost like they don't understand what the assets actually are, what the internal risk actually is. To be fair, it sounds like you have a better foothold, or you have a better understanding of that than most people that I talk to. And I know it's a huge issue on the podcast. We always talk about asset management. We always talk about like asset inventory and knowing what the landscape looks like. But as an external person, I'm so scoped. And even as a bug bounty person or a researcher, you are so scoped down to what the organization has decided is important.
Well, so that leads me to a question going back to the various categories and the parts that make up risk.
Yes.
I'm trying to understand, like, what was the thinking there for the company to have a mortgage calculator? Like, what was the real risk there? Was it on let's think through that for a bit. Was it on like their primary domain where sessions could be stolen if there was like cross-site scripting?
No, it was not. The primary risk was okay. Logical keeps typing in NIST 830. Yes. Okay.
So I said NIST 860 because what I was trying to say is you need some sort of fundamental way of actually mapping what an asset holds, how important it is to you as an organization, that sort of thing. Whereas NIST 830 is about risk rating and talking about like likelihood of previous occurrence, likelihood of exploitation, that sort of thing, and balance.
You're being way too optimistic about what the people at these banks actually care about and what they're measuring. The risk was the first thing that you said, which is must have a pen test each year. It was a compliance risk.
Oh, I know.
That was the only thing. And so I spent 40 hours looking at a mortgage calculator on a site that doesn't have access to anything. I mean, like there's a slim possibility that there was a cookie scoped to a parent domain that may end up over there in some like convoluted path of cross-site scripting. But it was just, again, like as an external person, the risk that the company gives me is what I have to go with. Right. So, of course, in my report, I'm going to report that, hey, guess what? I found cross-site scripting in this mortgage calculator. That is a critical risk. You have to take care of it because you gave me this and you made me spend time on this dumbass site. Right.
But on my side, I would say, well, I'd probably say before we got there, why the hell are we assessing this thing? But like, how can we get this thing not like, can we iframe it from another thing and then not make it in scope, or so can we do something along those lines? But so first of all, I guess I would say I would try to reduce scope as an embedded person. Embedded person. But,
sorry, Stefan, what were you saying?
No, I was going to say I had an application many years ago that was just a static HTML file. There was nothing else. And there was literally no input. There wasn't even JavaScript that you could run. It was literally just HTML from a bank. And I dinged them on a bunch of flags. I dinged them on like one of the comments that came back from some like interstitial server was an internal IP address, that sort of thing. And I marked them all as lows and notes. I didn't say anything was impactful. I was just like, hey, when you get a chance, look at these sort of things. Well, this team had been going through pen tests every year for 10 years against this damn HTML thing. And They were so stoked that someone reported something. So they acted like this was critical. But they had to like, do we shut down the application? Do we need to go through and like, who is our incident response team? They like rolled out that like broke the vial to like get new keys and stuff. And it was great. I was like so happy that they had all these things, but I'm like, you are very well prepared because you have never had to do this sort of thing. So you've been like chomping at the bit for it, but like the people who actually probably need to have these sorts of things have none of these things going. They have no idea how to do any of these things. They're screwed, Yeah. Single page app was cool. So
single page app. Yep. So it sounds very similar. And Dave Corsi brought up a point, right? The risk of reputational damage through XSS to a Fortune 100 company, right? Not being the person that shows up in the news. And so as an external person, I understand that, and I'm going to scope and I'm going to do my work on whatever you give me, and because you're paying for me to do it, right? And you're paying good money for me to go after these assets. But maybe you need to think about it a little bit before you issue this like all-out order to go attack a mortgage calculator. That's all I'm saying. That's all I'm saying.
But even reputational damage is very specific. Like, unless you're a security product that like refuses to fix its security, I would say that like honestly, most of these companies have bounced back. Like, I'm just playing devil's advocate.
Oh, no,
they bounced right back, even better and harder than before.
Exactly. Like, yeah, look at, I mean, the Target breach. I know I'm going back a few years, but the Target breach, did it materially affect them? No.
Home Depot, are they out of business?
Yeah.
I bet you Lord Melson would disagree with you as to whether or not they had actually been impacted by that. But I know what you mean. Like, reputationally in the community at large, most people still shop at Target and want the things from there. I have seen one a hedge fund deal with this. So if there was nothing sent back to the server and there was nothing that was actually like PII, SPII, etc., what they would actually do is it was perfectly okay to be like statically analyzed or like very simply scanned, and they wanted to spend no more than 8 hours on that. So no 40-hour pen test, nothing like that. They would do like 2 hours of scanning, and then we're done, because nothing. But that goes back to having an asset catalog, knowing what the heck you're testing.
Again, you started with, what did you start with? There was two main points there. It was a static site, right? Like, there's no information flowing back and forth. There's obviously some asset and risk profiling that's gone on. There's some risk that's been chronicled there, to go back to something I've heard earlier about that application. And that's just it. Like, so many of these large corporations, and to be fair, I don't see quite as much of this as I did, 10 years ago, but there's still those applications that you get pulled in on that you're like, really? It's been 10 years. No one's found anything on this HTML site, and you want me to look at it again because somebody included it in like SOX as being SOX relevant or PCI relevant when it's really not, right?
Yeah, it's on the same server as something that is, SOC or PCI or something else. So therefore, even though it's static and it accepts no input and blah, 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 it needs to go through a pen test every single year.
Yeah. Yeah, but you can always see like who is like what tools people use by what they report, right? Like, anybody see DOM XSS pop up because of Burp Suite like the last year? No, not at all.
No, bro, I got CSP. Neil just talked about
it. Neil Mattel is mine. No, I that's always a hard one too. DOM-based XSS is really difficult. I think
it is.
It's non-trivial to actually find that. Burp is not your friend in any way, shape, or form, but certainly not for DOM-based XSS. And it's pretty awful in general to find. So, I'm not a huge fan of DOM-based XSS. I remember when like Domato and all those tools were the thing that you were supposed to use in Dominator and all that, and it was never fun. It was terrible.
No.
So let's talk about CSurf next, since we're on individual OWASP top 10 things. Let's talk about CSurf. I've heard from
in the OWASP top 10
that it's the new ODE. What's that?
CSurf is not in the OWASP top 10.
Come on, you're not that embedded yet.
Your twin Kevin Johnson actually talks about this all the time. OWASP does not include CSRF anymore. So
no, not as its own standalone, but I believe it's under access control with OWASP top 10. I could be wrong, but it's not its own category anymore. That's for sure.
Yeah, and it definitely shouldn't be.
It's a confusion problem, right?
It is. Yeah.
What's that? Sorry, I missed that.
It's a confused deputy problem.
Yeah. It's a confused deputy problem. You got that?
Yeah, it's definitely not a related issue for sure.
And it's,
Yeah.
I mean,
But how
it's
important is
it's
it? That's my main question is impact. What's the impact?
depends on the asset.
It's contextual, correct? We agree that it's contextual.
It's contextual. Yes. But again, this all goes back to the scope that you give me, right? Like within the context of this single application that I'm looking at, this is all that I have access to. By nature of that relationship that I have as an external person, I'm naturally going to rate things higher, and I'm going to attempt to inflate the risk rating or the risk severity that I give things to give credence to my report, right? And we see this all the time with bug bounty researchers, is they'll come in and they'll be like, oh my word, I found that you have like there's a WordPress site that's out here that I found, and it has the XML, RPC, whatever, PHP exposed. That's a critical risk. And you're like, what do you say is embedded to that?
I would
No.
say no. I would say a
Yeah.
hard. And actually, I get this all the time, and I don't want to because we have some awesome researchers, but there are definitely researchers who send me a finding that's like I can copy and paste my session from one browser into another browser, and so that's pretty critical because I could become somebody else on another window, or take over that person's account. Yeah, so I definitely get those findings, and they come in as critical or high. And I think that's, this goes back to what actually matters. Like if it is a property that is meaningful, if it is going against our mission statement, or if it's just something that has true impact, which I think can be assessed not by probability, but rather by, what does it actually mean? Does it mean you can take over an account? Does it mean you can do something destructive? That's really what it comes down to for me when we talk about context and meaningful bits there. Now, the other one I wanted to talk about was SQL injection. Or injection in general. We could talk about content injection and CSP, but I think we've talked a little bit about that, or we could talk a little bit about SQL injection.
Yeah, SQL injection nowadays is interesting, right? I mean, it is contextual. Like, obviously, it is contextual, and I don't want to give the impression that bug bounty professionals or bug bounty researchers don't actually dig in for all of this and try to understand the scope. I mean, the good researchers that you have, I'm sure, understand what they're looking at from a GitHub perspective. And I do also see that from the consultant side, right? That's one of the first things. There's a reason why in our code review course, we talk about risk profiling. We talk about roles. We talk about the back end. So we talk about SQL injection and what you can actually access from the SQL database. Because at some point it could be, hey, you could take over this .NET server or whatever, right? Like within the scope of this application, or you could exfiltrate data and passwords out of that because they're storing passwords in an MD5 format or something like that. So the risk can increase. But anytime I find SQL injection, it's usually a pretty severe problem, right? It's not just, hey, I can only get back a slight bit of information. It's usually, hey, I can dump your entire database, including whatever is secret about this application, right? Do you see instances where SQL injection would not be at the very least a high or not critical, if not critical risk?
For sure. Sometimes the only thing you can do is sort destructively, right? Like be able to manage descending and ascending, right? Like you can limit, and depending on the connector for the database you're dealing with, potentially that's an issue, or most often it's not, right? It's pretty limited on what can be done. So and then there are cases where, more often than not, it is pretty destructive and it is pretty damaging. But again, I think it all ultimately does come back to context, but I agree pretty much with you on everything you said on that point. And then I wanted to add the things that actually do matter to us would be any access control issue, because you made a statement there where you said bug bounty researchers might take the time to actually like understand the application. And I think that that's really what it comes down to with these AppSec findings is that the consultant or the bug bounty researcher has to know the application, and that's where the most meaningful things come from. There's certainly the issue of just like exposed S3 buckets or some default, something dumb that can be like a high payout, right? Something that was just not configured correctly. But more often than not, as somebody who took the time to know the application. And so those like bits that are like authorization and access control related, they're harder to actually to uncover unless you absolutely do understand the application and then logic flaws that come out of just subverting the way that we intended for you to use the application. So those are like I think the things that are most meaningful, and I think we pretty much agree on those bits there.
Yeah, and like I do want to zero in on one of the things that you said as far as so understanding the application, and I know I'm repeating a little bit of it, but like you keyed in on logic flaws and business logic flaws, and as an external person, and the longer that I've spent as a consultant, the more time I realize and I spend on understanding why the company built the application that I'm looking at and what it is that it's actually meant to do. So yes, it's great to find SQL injection. It's awesome to find cross-site scripting, and we can list those as highs all day long, but we have a lot of tools out there that help us do that nowadays. The hard problems exist when it comes to the business logic flaws, when it comes to authentication and authorization, because that's where, number one, that's a hard problem to solve programmatically as a programmer. And number two, that's where the assets lie. That's why the application was built. And so if I can find a way to get any of that back out or subvert that logic, it means that there are serious issues with the application that need to be fixed. And that being said, there are a lot of applications that we run into as external people where it's just not possible. And I don't find authorization issues in that same magnitude or logic bypasses. They do exist, but like it's almost become the new SQL injection, to go back to that, right? Like back at 10 plus years ago, it was like a SQL injection was every other app. You'd find a way to dump the entire database. But nowadays, it's those authorization flaws that we look for. And I think we're getting better at securing applications, but we're getting better at also understanding and decomposing an application to what the core functionality is.
So I think if we're wrapping up this section before we get onto a few of these other points, if we're wrapping it up, a lot of these things are basically managed by modern web standards, or can be managed through modern web standards and framework libraries when properly used and written, of course. But I think we could pretty much distill it down to that. And I'll say something. Somebody, I won't say who, just in case they don't really want to die on that hill, said XSS is bullcrap. I'm paraphrasing. I'll die on that hill. And what I say to that is, you have a CSP, have a CSP. Secondly, have a CSP. No, but like honestly, XSS is like, honestly, you have to think through the context, and you really do. Just like with all the things we talked about, some beating a dead horse, you really do have to think about, when does it matter? Because it doesn't always matter. It really doesn't. And I know that's going to be like the AppSec guys saying XSS doesn't always matter. Absolutely. Which brings me to the second point I wanted to talk about, which was backlog. Backlog is an issue. Findings from last year's pen test, essentially. Or
they always exist. No,
they do exist. They exist from assessments. They exist from bug bounty submissions for embedded folks. I know you have to look at, well, you have to think about anyways, the people that came behind you, and so these findings, you may report. You may have clients, and I'm sure you do, where you have maybe every 6 months or once a year you do an assessment. Right? How often do you come back and they have a backlog, and it might be even frustrating for you? And I'm here to say that there are definitely things that are pretty meh that you can take time on. Those things are like defense in depth. I'm looking at my notes. Sorry, I had to think of this because I knew we'd be drinking, and I want to make sure I stay on point. So defense in depth issues. Those are issues
Yes.
where it's not an immediate security concern. Well, we label them internally as that. It's not an immediate security concern. It actually, we would need something else usually to fail. Like sometimes, and we've talked about this in our secure code review course, where sometimes we just write up things that look like, okay, look, if this other function changes, or if somebody uses this function that wasn't intended to be used by like a potentially sensitive operation, then we're going to have a problem. And those are defense in depth, where, hey, let's do these things to harden that function. Another one, and I'll just only one more so that you can respond in turn. Another one would be, well, actually, we already talked about it, and my example was XSS that doesn't bypass CSP, because sometimes XSS does bypass your CSP. I was going to say CSP policy, your CSP, which Neil talked about.
Yeah,
your CSPP, and so yeah, there's XSS that doesn't bypass that, and they're just again very contextual, but they're like just this is backlog of things that don't matter so much.
Yeah, and okay, so as an external person, I get that, right? But I'm going to go back to this whole scoping issue, right? Like, and apparently I'm going to die on a scoping hill today. But like, when you have me come in to look at an app that's already been looked at, for the last 5 years, and you haven't fixed something that was in the report 3 years ago, does that really matter? Is that a useful, way to spend the money, right? Like to spend money on consulting. And I know that there's firms out there that'll actually help you fix some of that stuff. But if it's not important enough to fix in the last 3 years, then like, what are we doing, right? Like at times it almost feels like you're trying to catch an external person out to see if, hey, are you as good as these guys that came in last year, right? Or the year before that? Because if you don't find that same XSS issue on this one page and this one, like, this one edge case, then, maybe we don't hire you back next year, right? And it directly affects my like ability to provide for my family, right? And so it goes back to scoping at that point, and what is it that you're trying to do with the assessment that is being conducted? Are you trying to eliminate risk, or are you just trying to get a compliance check? So I guess that's really where it falls down for me, is that whole compliance check versus actual risk discussion.
No, I think you're actually, and you bring up a legitimate point, by the way, which is, you kind of touched on it, is sometimes, yeah, it feels a little bit deliberate, because sometimes it is deliberate. When have you and I have definitely had customers in the past who planted bad code purposefully just to see if you would uncover it.
Yeah.
Which is a nutcase thing to do, but I get it, because there is no governing standard, really, right? There's no governing standard that we all sort of meet. InfoSec is it's still in its infancy. Let's be honest. It's not that old of an industry. So anyways, that's sort of my point there, is that if I have any point at all, is that, like people have definitely, you're right. They've left bad code around. But I think what I was trying to say in the end is that sometimes it's just a thing of like, I need to manage a certain amount of resources. My product managers, my project managers, they have their requirements, and they have their deadlines, and they have the conferences they're shipping features for, right? And that's always going to be that way. And our job is to prioritize what matters for them to actually get fixed without impacting schedules. And then ultimately those things, maybe they get, tended to a couple cycles down the road, but they may not be in the story for that feature release. So that's like, that's sort of a middle ground. I think it's a little problematic and frustrating, and especially for consultants. But it's certainly something that,
and the other thing that I want to bring up there is, if you're having a consultant or bug bounty researchers in there and you already know about a bug, just tell them, like, good hell, right? Like, tell them that it exists and to move on, right? Some of the bug bounty platforms are really good about this. Hey, there's already been XSS reported in this, whatever, right? And I know we're dying on the XSS hill, or someone is, but if there's an issue somewhere, let them know so they concentrate on stuff that's important and team up with them, rather than treating them like a complete black box. Because most of those attacks, right? Like, I haven't seen research recently, but most of the attacks, most of the actual exploits that are successful come from internal resources or people that have privileged access. exactly like the Twitter account, right? Like, social engineering, they were able to get in and then they were posting content, right? So it's a completely different thing than someone going in blind and trying to find vulnerabilities.
Well, we've got 6 minutes left, so I want to touch on one more point and then wrap up with your all-encompassing thoughts on what you think organizations should concentrate on from a risk perspective. And I'll give my piece, but it's the last piece here. Bug bounties are really a tool for us as corporations, as organizations, I should say. It's a tool for us to determine what our real risk and impact is. We talk about it in the secure code review course, and you've talked about it tonight with scoping. You have a limited amount of time. You're scoped to a specific piece, and it's no different for the embedded people that are doing assessments. There's still scope. There's still a limited amount of time. So bug bounties can be a good way, and again, we talk about it in the secure code review course, to find things that are much more difficult, nuanced, and take multi-step sort of a multi-step flow to actually get to the point where you're exploiting an application in a meaningful way.
Yeah.
So that's how we look at it. But is it not a little bit of a liability for external consultants, in the sense that, let's say you're doing an assessment and a bug bounty comes in during your assessment, or you turn in your assessment and right after a bug bounty researcher finds something you didn't find? Is that not a little bit of a liability? Is that factor into how you perceive bug bounties?
Yes. It definitely does. Because there is definitely a competition factor that feeds into it, right? Because partially it's a professional pride thing as well. But on the other hand, most of what I do as a consultant when I'm in doing an assessment, again, is scoped to a specific application, and it's scoped to a specific time. And so like if I'm beat out by somebody that just spent 120 hours figuring out one little logic, flaw within the application to exploit, the database, and I was only given 40 hours to look at a site and do a full-blown assessment against it, guess what? Kudos to that bug bounty researcher, because realistically, they spent the time to find that bug and they should be paid for it, right? Like, I don't dispute that at all.
But should the customer be frustrated with you?
I guess if they want to be, right? But they have to realize that there's two different avenues to secure your application. It shouldn't be one or the other. It should be, hey, how can these complement what I want to do and what I want to secure?
I think that's totally fair. Again, I think researchers have a lot of time on their hands. They have whatever the scope, and honestly, sometimes what's not in the scope, not listed in the scope. So they have like a leg up for sure, in one way, and in another, not so much, right? Because they need to find something to get paid, especially if they're doing this professionally, right? So they might have that sitting in the back of their head at times, but ultimately there's that time advantage. So what I would ask you before we hop off here and finish out the slides and the rest of the presentation, give like a quick soundbite of advice to an organization. Yes, on like for risk. External standpoint, what is the best way to minimize risk?
Turn off all your computers.
20 to 30 seconds.
Go find that one cord that's plugged into the computer and just unplug it, right? That'll eliminate all your risk. That's the only way to be truly safe. And you need to understand that is that risks exists independent of what we do as external researchers, right? We're trying to uncover it. We're not trying to make you look bad. At times that relationship gets a little bit antagonistic, especially with developers, when it doesn't need to be. I don't know.
Well, I would agree with you. I would add, make sure you understand the context, make sure you understand your true risk, and what I mean by that is we don't, you shouldn't be worried about fluff findings in, as an embedded person. You should worry about what actually matters. Look at the context and then prioritize accordingly. So I think we have a plan. Do we not, Seth?
Yes, we have a plan.
We have a plan. All right.
Max
hold on.
Logi is reached. Woohoo!
Max Logi was reached, but then our heroes had a plan, and now they can manage and contain risk. Frick!
Uh-oh. Frick! No! Risk is frustrated.
Risk is not happy. And now our heroes rest on the beach. And those are, by the way, our sons. Seth actually has two, but Colin's his son on the right. Max is my son on the left. And
hey, no doxing. Come on, slow down.
They were nice enough to do our April Fool's podcast for us. I figured we would just like give them a little nod there. So thank you for watching. There's our contact information. I think, though, that you have everything you need to reach out to us if you're watching this podcast. So we will go back and stop the screen sharing and get ready for our next guest. And I'm going to pull everybody back in. Oops. All right, we've got everybody back. I was going to hand it off to you, Heather and Stefan.
Yeah. Do you want to do?
No pressure.
You want to intro Corey really quick? I'm excited to have him for the. For the conference.
You want to talk about how this was like? Man, I wish we could get Cory Doctorow.
It's amazing. I'm so excited.
So many people have reached out asking how.
I originally started with the EFF.
Oh, well. Yeah, I met Cory a few years ago. It's always amazing to listen to him speak. I could go through all the books that I have of his. There's no end of things that I can talk about. So I'm super happy. Heather coordinated this whole thing, so thank you very much to Heather for that. She did awesome. Wow.
No, I don't know. Both Cory and Naomi were extremely patient with trying to reschedule things and. You. And it managed to happen. So I'm so excited to hear you talk. As soon as we saw the talk title, I was like, oh yeah, Logi's gonna love this talk title.
Yeah, no, this is amazing. Cory, just over to you. Thank you again so much for joining, but absolutely looking forward to it.
Well, thank you all. It's a real pleasure and an honor to come and speak with you folks. Thank you for your involvement as an EFA affiliate, Electronic Frontiers Alliance affiliate. That's how you came to us, right? You came in through the affiliate thing. EFA is a really important network of independent organizations that work on issues with each other and with EFF. We're an organization of co-equals, or a network of co-equals. And the work that you folks do is really important. And it's EFF is just one organization. We need lots of people. Yeah, good. You got your colors. Excellent. Yeah. We've got a new 30th anniversary hoodie coming that is so dope. Oh my god, I haven't got one yet, but if I had, I'd be wearing it. So I'm going to do a talk. I actually gave a version of this talk yesterday at Hope. I hadn't quite figured out that these are going to be so close together. I hope that it's not redundant. But yeah, if you missed me at Hope, you got me today at MidSummer Nights. And it's a significant talk because normally the way that this goes is, I have a spiel I give that's related to the issues that are going on in the world. And, you give it and you get better at it, you practice it, you revise it, and things happen in the world. And maybe you do a big refactor every now and again. But, it's your thing. And that's not this talk. About a month ago, I was doing another talk. And I was looking up the history of the free software movement, and specifically like when the GPL came about. And I just got a kind of bolt between the eyes where I realized that what I thought about when I thought about software freedom was through this extremely time-bound lens of like 2020, and that there is a bunch of important historic context that puts it in a completely different light. And that led me on this kind of journey where I found myself calling up scholars that I knew, Pam Samuelson, Benjamin Mako Hill, Rebecca Giblin in Australia, all kinds of people, Seth Schoen at EFF, and saying like, this is where my thoughts have taken me now. Is this crazy? Like, because it's not quite the way we talk about this stuff. And they were like, no, that's a really good way of putting it. I haven't really thought of it that way. And so finally, I've been calling it jokingly my grand unified theory. And I wrote it up for Locus magazine last week. I do a column there. It's the science fiction trade magazine. I do a column for them, and they let me write about whatever I want. I do 6 a year. It has to be, about 1,000 words or more. And I was like, how much more? And they were like, whatever you feel like. So I wrote them a 5,000 word column that is the outline. It's if you've ever met a Marxist, this is the Grundrisse of my Capital, my outline for this idea that will someday be a bigger thing. And I've talked about it in public exactly once, and that was yesterday. And today I'm going to do it again. I'm going to read you this column, or use this column as the basis for a talk. You can read the text of it in Locus magazine in about 6 weeks. And with no further ado, here we go. The column is called IP. So this crowd definitely has heard of open source software, and you're into the politics of this stuff, so you've also heard of free software. You probably know a little bit about the underpinning ethical debate that we all think about when we think about the difference between open source and free software. And I've been involved with this stuff since the last millennium. And even I never really understood what was going on in the background until recently. It happened when I was looking up the history of the first free software license. And I had this revelation that transformed the way I think about this stuff, which is significant because to a first approximation, this stuff is all that I think about. So some background. Free software, you probably know, it has its origins with an AI researcher who became an activist, a guy named Richard Stallman, who started a project called the GNU Project in 1983, and out of that came the General Public License, the GPL. The GPL is a computer license, copyright license rather, for computer code for programmers who want to share their work. When you release code under the GPL, that means that anyone else is free to run your program, study your code, improve your code, and publish their improvements. The GPL, this copyright license for software, arrived at the same time as copyright for software was arriving. Prior to 1983, software was not really considered copyright. It was considered a functional work. And as a functional work, it wasn't entitled to a copyright. Copyright only adheres to a creative work. Here, I'm just going to adjust my mic a little. Copyright only adheres to creative works, and copyright was considered functional and therefore not eligible for a copyright. In 1980, there had been some changes to the Copyright Act that paved the way, but what the really big bang thing was a lawsuit called Apple v. Franklin in 1983, and that created the first limited copyrights for software. When you chose to apply the GPL to your code, you could lock it open and ensure that not only could others build on it, but that no one could take the work that you were all building together and lock it up again and take it for their own. Now, today, the act of licensing your code as free software is a mark of forbearance. It's a way for a software author or a company to signal to others that they will not seek legal sanctions against anyone who creates new programs that can read and write their formats, or that can interoperate with their program, or that fork off their whole program and make a new one that competes with it directly. To make your software free is to promise that the people who interact with it will have freedom, freedom in the sense of free as in beer, or free as in speech rather, even if it's not always free as in beer. Now in 1998, free software underwent a revolution. That's when a more business-oriented groups of technologists and entrepreneurs got together, and they decided that the term free software scared business people because it implied, on the one hand, that you couldn't charge money for the software, and on the other hand, that there'd be some kind of messy freedom that wasn't necessarily a thing that, if you're in business, you really are concerned with. So these people, they coined the term open source as an alternative to free software. And in doing so, they stress the instrumental benefits of allowing other people to scrutinize your code. When other people get to scrutinize your code, they can find the defects in it, the things that might allow third parties to do malicious things with it, the things that might make it run slowly. With enough eyeballs, all bugs are shallow. So let's go back to 1983 and that birth of free software. When free software was born, it wasn't clear, the free software copyright was brand new. It wasn't clear what kind of software could be copyrighted, and it wasn't clear what you could or couldn't do with software that was copyrighted. Software patents were basically unheard of and very, very hard to secure. The terms of service that came with shrink wrap licenses, these are licenses that you quote unquote agree to just by opening a box or running some programs, doing anything sort of normal and unsuspecting that doesn't look like the kind of agreement that you make when, you know, you get married or sign a contract or do any of those other things that we mean when we say agreement. Those terms of service, they weren't considered enforceable either. There was no law against going around DRM or copy controls. And the para-copyrights, these kind of exotic legal theories like the one that Oracle is advancing as they sue Google to make API syntax copyrightable, those didn't exist either. They hadn't come into existence yet either. So in other words, when free software was born, if you wanted to clone or interoperate with or improve or modify any software that you encountered in the world, all you needed to do was reverse engineer it and go to town. The GPL wasn't permission to make an interoperable product. The GPL was people already knew how to make software. People who knew how to make software already behaved as though they didn't need permission to make that interoperable product. The assumption that everyone had was that if you wanted to fix some code, you could fix the code. The GPL instead was a request for companies and for individual software authors to make the process easier and less tedious by handing out source code so that would-be interoperators could get right to the good stuff without going through the wasteful, tedious, time-consuming business of reverse engineering. Remember, in 1983, even more so than today, there weren't a lot of people who knew how to write code, right? And so the idea that like half of us would be writing code and the other half would be reversing that code when we had a lot of code to get written, it was kind of wasteful. So the free software license was basically saying, don't waste your friend's time. Just give them the source because you know they're allowed to do it and you know they'll reverse it eventually. The GPL, in other words, was icing on the cake. Applying your GPL to your code didn't signal that you would forswear legal vengeance upon those who wanted to make something compatible with your thing. You had no right to that vengeance. Applying the GPL to your code signaled that you were willing to collaborate with interoperators rather than impotently shaking your fist at them from the sidelines as they went right ahead and interoperated with your code against your wishes and screw you. Some 40 years later, we are living in a very different world. Between software copyrights, anti-circumvention laws, software patents, enforceable terms of service, trade secrecy, non-compete agreements, and the pending Oracle-Google dispute over API copyrights, any attempt to interoperate with an existing product or service without permission from the corporate overlords of that product or service is a legal suicide mission, an invitation to almost unlimited civil and even criminal litigation. You can go to jail for this stuff. That is to say, if you dare to modify, improve, or replace an existing dominant software-based product or service, you risk bankruptcy and or a long prison sentence. 40 years ago, we had cake. Yes, software is also cake. 40 years ago, we had cake and we demanded icing. Today, all we have left is the icing, and we've basically forgotten that that cake was ever there. If code isn't licensed as free, you best leave it alone. All right, so that's the first section. The second section is about interoperability. So what is interoperability? The term is a nerdy, technical, obscure term. It's closely related to a more familiar, less technical term, compatibility, but it has a different gloss. The two aren't exactly equivalent. In a technical sense, interoperability describes two products or services that can work together in some way. Whether that's opening a Word document in GDocs or using third-party ink in your printer or replacing your watch band, changing the stereo that came with your car. Interoperability is a broad, universal, essential characteristic present in all of our technology. Interoperability is the default state of the world. Anyone's charcoal will burn in your barbecue. Anyone's gasoline will burn in your car. Any manufacturer can make a light bulb that will fit in your light socket. Now, some of this is down to standardization. Manufacturers, academics, interested parties, they gather in these standards development organizations to make the process simpler. Like they'll describe the canonical thread characteristics of the light bulb screw, or the best way to compose an HTTP request, or how the fittings underneath your toilet should work so that you can just plunk a new toilet on the pipes that come up out of your floor. This certainly makes interoperability a lot easier. Think about the standards for paper. We have weight standards, grams per square meter, GSM. We have size standards. In the US, that's like legal letter foolscap. In the EU and the rest of the world, where they're a little more sensible, it's like A1, A2, A3, A4. And that means that any paper that you get will work with your printer, and you don't have to like cut it to size. But if you decide to make it run in your printer, you can trim it. A failure to standardize can make life hard for everyone. Early Australian rail barons were engaged in fierce competition with one another, and they decided to lay railroad tracks at different gauges so that across Australia, you couldn't get a rail car from one country to another because where one network met the other, the rails were different widths apart. They call this the multi-gauge muddle. And those barriers to interoperability, they're not insurmountable. If the paper doesn't fit the envelope, you fold it. If it doesn't fit your printer, you can cut it. In Australia, there have been hundreds of proposals for multi-gauge rail cars that can like suck up one set of wheels and drop down another set that run at a different gauge. And though no one's ever built them, it's not hard to imagine how you could. Instead, they've done something that's ultimately probably going to be more reliable and cheaper. They're just tearing up railroad tracks and putting down new ones at a standard gauge. Interoperability lowers your switching costs. That's the cost of leaving behind whatever you're using now in favor of something that you think will suit you better. So my grandparents emigrated to Canada in the 40s from the Soviet Union. And when they did, they incurred a very high switching cost. For more than a decade, my grandmother couldn't talk to her family back in Leningrad. The only way that she could contact them was by word of mouth with the odd person who got a visa to visit the USSR. Now, contrast this with what happened to me 5 years ago. 5 years ago, I moved from London to here in Los Angeles. Now, we are in routine contact with my in-laws in London and my in-laws in Wales and my family in Toronto. In fact, I'm missing my family Zoom call just to be with you guys. We do that every week. My laptop and my books, they all came with me. You can see them around me. And while we left most of our appliances back in London because they ran on a different voltage, we did take a few of them with things that we really liked, and then we just put new plugs on them or got transformers or adapters. Our switching costs were a lot lower than my family's were a generation ago when they were Soviet refugees. Companies really like high switching costs for the same reason that the Soviet Union really liked high switching costs. If you're a would-be monopolist, the best product is one that is seductively easy to start using and really hard to stop using. As there's been litigation against Purdue Pharma for their blockbuster product OxyContin, there's been lots of internal memos leaked and revealed through litigation in which you see these pharma executives like rubbing their hands together and talking about just how easy it is for people to get started using oxys and how hard it is for them to stop. Addiction is not the only way to raise switching costs. Think about Facebook. Facebook makes it incredibly easy to get started. Historically, they even went so far as to deceptively invite you to upload your whole address book to them so they could immediately enmesh you in a network of all of your friends who already started using Facebook. Once you're on Facebook, it's really easy to go out onto the public web and grab links to articles and put them inside of Facebook. And you can even use Facebook to follow friends on services like Twitter that expose themselves to the public web. So Facebook lets you follow friends who aren't even on Facebook. Over time, as you use Facebook, it nudges you into making Facebook the primary means by which you find out about what's going on in the world and keep track of your friends, even those who aren't members of the service. But when it's time for you to leave Facebook, there is no easy way to do so. You can't go to a rival of Facebook's and follow what your friends on Facebook are doing. You certainly can't reply to what your friends on Facebook are saying from another service. You've got to log into Facebook to be part of their conversation. Interoperability, that's the principle that allows Facebook to slurp in all that stuff from the open web. That's the key to self-determination. Leaving Facebook in the 21st century is like my grandmother leaving the USSR in the 40s. You can go, but your friends and loved ones are all hostages behind Zuckerberg's Iron Curtain. So leaving Facebook means leaving behind your communities and your relationships. Now, obviously, that's not as hard as kicking Oxy, but it's not easy either. And your presence on Facebook, that's the reason someone else isn't going. So your hostage on Facebook is part of the reason that someone else is hostage on Facebook. Now, here's the thing. Everybody in the world wants to minimize risk, whether that's employers or workers, big tech, or its users. You want Google you want to use Google in ways that make your life better, and you don't want Google to be able to arbitrarily change or remove services in ways that make your life worse. Ask me how bitter I am about the removal of Google Reader all these years later. Now, Google wants to make sure that you won't leave the company or its products or services. It could make this happen by producing the very best products or services that are so delightful and engaging that you have no reason to want to leave them behind. But a surer and cheaper way is to interweave its products and services with your life. So making sure that your kid can't go to a public school without getting a Google account with Google Classroom that you can only monitor from your own Google account. Embedding Google Search in your mobile OS, releasing web and app development widgets that gather data on the users of the services built with those widgets and pass them up to Google. So even if you leave Google, you haven't left Google. The more freedom that you have to leave Google, the bigger a risk you present to Google. The more Google can lock you in, the lower your risk of departure from the service and the higher the risk that Google will cease to keep you inside its walled garden by being amazing and delightful, and the higher the risk that they will rely on retaining you because you can't leave, or that leaving will come at too high a price. Interoperability improves self-determination by safeguarding your ability to change your current situation in incremental steps. If you like your phone and the apps that you have, but you want an app that's banned in the default app store that came with your phone, interoperability can come to the rescue. You just add another app store, and then you get to use that app. You get to keep your phone. You get to keep all the apps you had before. You get to keep all your data on your phone, and you get to use the app that the phone's manufacturer didn't like. But without interoperability, your only choice is take it or leave it. If the App Store blocks you from allowing another app store to be associated with your phone, then your only choice, if you want that app that's banned, is to throw away your phone, throw away all of your apps, lose some or all of the data that you've either input or gathered with that phone. That's going to be a pretty good app before you're willing to do it. And so those switching costs really lock you in. Writ large, interoperability encompasses things like democracy. When someone says they like their city, but they're opposed to one of its laws, we don't say, well, if you don't like the laws, get out of the city. We have a whole process for reforming the laws in your city. And if you fail and you decide you do want to leave the city, you don't have to leave your stuff behind. You can keep your city and change the laws, or you can change the city and keep your stuff. And either way, you get to stay friends with all of the friends that are in your city. So that's the second section on interoperability. Now here's the third section. For me, this whole line of thought began with a reflection of the history of free software movement and the largely forgotten time in which the default condition of software was freedom. In the absence of copyright and patent, and anti-circumvention and terms of service and non-competes and confidentiality and other commonplaces of today's software marketplace, anyone who could figure out how to reverse engineer a program could improve it, replace some or all of it, read and write its files, compete with it, or sideline it. Today, this is no longer the case. In fact, today's software marketplace is so unlike the cake and icing world, where we had the default for software freedom, which was cake, and the free software movement began its audacious demand for freely reusable code to go on top of it, which was icing, that it's virtually impossible for us to even imagine living in such an environment. The thicket of interoperability rules that have sprung up to change the world so much and take away our cake and threaten our icing, it has a name. We call it intellectual property, or IP. And free software advocates, they hate the term IP, or intellectual property. The argument against IP has two thrusts. One is that it's imprecise, and the other is that it's rhetorically dishonest. Prior to the use of the term intellectual property, we didn't often group together all the different things that sit under that banner. Trademark was trademark, copyright was copyright, and patent was patent. When you're talking about whichever one you were talking about, that's what you named. Bunching them all together didn't make a lot of sense because they're all really different legal regimes under the hood. On those rare instances in which we did want to group all that stuff together, we called them authors' monopolies or creators' monopolies. The anti-IP argument leans into the difference between the underlying rationale for each of the rules underneath the creator's monopoly or intellectual property. So in the US, for example, copyright exists to promote the useful arts and sciences. That's what it says in the Constitution. It provides just enough incentive for people to make new things and just enough protection to create those incentives, and no more. Copyrights do not extend to ideas. They only extend to expressions of ideas. And you have patents. Patents are completely different. Patents aren't about creativity. They're about incentivizing inventors to make disclosures. To get a patent, you have to draw a diagram and write an explanation that explains how your machine works. And that means that other inventors can examine your invention, even during the period of the exclusive patent, and they can figure out how to replicate its functionality or design something that plugs into it, even if you don't like it. Trademarks are completely different again. They're consumer protection. Trademarks empower manufacturers to sue deceptive competitors who trick their customers. It's not about giving Coca-Cola the exclusive right to use the word Coke. Coca-Cola does not have that right. It's about deputizing Coca-Cola to punish crooks who trick people into drinking things that aren't Coke, that are labeled Coke. Coke's trademark rights do not cover non-deceptive, non-confusing uses of its marks, even if those uses harm Coca-Cola, because they do not harm Coca-Cola's drinkers. That's who the trademark protects, the drinkers, not the company. Seen in this light, intellectual property becomes incoherent. When you assert that your work has intellectual property coverage, do you mean that you can sue rivals to prevent your customers from being deceived? Or do you mean that the government will block rivals because you disclosed how your product or your service worked? Or that you've been given just enough but no more protection to incentivize you to produce your work, but that others can take your ideas even if they can't take their expressions? When you look at how IP is used in the real world, though, you see that there is a coherence. There's a colloquial meaning that actually explains why we use the term IP to explain all of these things. And here's that meaning. IP is any law that I can invoke that allows me to control the conduct of my competitors, my customers, and my critics. That is, in a world of uncertainty, where other people's unpredictability can erode your profits or mire you in scandal or even tank your business, IP is a means of forcing other people to arrange their affairs to benefit you, even if it costs them. There are some ways in which this is absolutely undeniable. Think about DRM. DRM is used by, say, printer manufacturers to force you to buy printer ink at sky-high prices, even though the printer ink itself is not special and you can buy it from someone else. And DRM allows the manufacturer to stop other people from reverse engineering the chips that verify what kind of chip they have. DRM also allows companies to decide who can fix your product and to monopolize the repair of your product and to decide when it's time to throw it away. So companies like Apple and John Deere and even Medtronic, who make the most common ventilator in the world, they all use DRM to stop people from fixing their own stuff, which allows them to say, oh no, that's not fixable. You have to throw it away and buy another one. Or copyright laws ban tampering with, copyright laws ban tampering with DRM, making it a serious jailable felony to provide others with the tools to bypass it. Section 1201 of the Digital Millennium Copyright Act, Article 6 of the European Union Copyright Directive, Bill C-11 in Canada, and even a new law in Mexico, the new copyright law that was just enacted earlier this month, they all make it very dangerous to build tools that bypass DRM. Now, these are all copyright laws, but tellingly, the ban on breaking DRM is not limited to copyright violations. Bypassing DRM to get your printer to accept third-party ink is not a copyright violation. You're not reproducing the printer's code. You're not reproducing the traces on its board. But even though you are not breaking copyright when you jailbreak your phone, you're still breaking copyright law. The law bans legal conduct if you have to break DRM to engage in it. That's not copyright. It's felony contempt of business model. And it's not just DRM. Think for a moment about this font, Goldman Sachs. Goldman Sachs was released by the global finance giant supervillain Goldman Sachs, and they give it away. It's a copyrighted work, and it comes with a copyright license, and that license contains a non-disparagement clause. That is to say that when you download it, you agree that you won't criticize Goldman Sachs with it. Goldman Sachs doesn't need copyright to protect its IP. It doesn't need it to stop you from copying it. You're allowed to copy its font. You're allowed to use its font. Goldman Sachs needs copyright so they can boss you around, so they can tell you what you may and may not say. The risk to free expression and self-determination have always been latent in copyright and patent and trademark. And so these laws have always been designed with escape valves to minimize these risks. Each one has its own escape valve that theoretically stop IP owners from using their rights to take away your rights. So, for example, copyright has fair use or fair dealing in most of the rest of the English-speaking world, which allows for many kinds of copying, adapting, displaying, and even selling other people's copyrighted expressions, provided that you're doing so in a way that promotes a free and robust discourse by transforming, commenting on, or analyzing the copyrighted work. Fair use does not depend on a copyright holder's permission. You can make fair uses even and especially if the copyright holder doesn't want you to. Patent has its own escape valve, publication. To receive a patent, you have to disclose how your invention works, and those disclosures are on display from as soon as your patent is given, where anyone can study them and use them as inspiration for their own inventions. Patents allow you to punish people who precisely duplicate your invention, but they also require you to disclose to others what steps they need to take to do the same thing your invention does without violating your patent. And they also provide a roadmap for making interoperable products that might erode future businesses that you might get into with your patent. Trademark has two important escape valves. First, as I said, trademark holders can only enforce their marks against deceptive uses and only on behalf of their customers. But second, trademark is subject to something called the nominative defense, which is to say it's not a trademark violation to use the trademark to describe the thing. You can put a sign in your store window that says, "We sell ink for HP printers," or "We will fix your Apple iPhone," or "Our cola tastes better than Coke," and the trademark holder doesn't get to say a word about it. Now, these escape valves have been a lot less robust than we might have hoped. It turns out that much of their efficacy depends on there being a competitive marketplace, so that when one company tries to narrow, say, copyright's fair use or patents disclosure rules or what have you, other companies that rely on those escape valves spring to the defense of the escape valve and defend it in court. As 4 decades of massive consolidation in every industry has occurred, a consensus has emerged among the shareholders and managers of the largest firms that escape valves are defects, they're bugs, not features, and otherwise laudable laws. And so these firms have set to work creating the legal precedents and tactics to jam the valves shut forever. So this is how we went from having software freedom cake to just having the icing. New copyright laws, like the ones that ban breaking DRM, new copyright precedents, like the one that Oracle is trying to set as it sues Google over API copyrights, and new tactics for combining copyrights, patents, trademarks, DRM, trade secrets, and other IP so that whatever trademark permits, copyright can prohibit, and whatever copyright permits, patent can block, and so on until all the certainty has been moved on to the manufacturer side of the deal and off of your side of the deal. Okay, so this is the second to last section here. Recall that the term of art that preceded IP was an author's monopoly. The tale of how the latter was replaced with the former, it has many variations, but if there's one thing everybody agrees on, it's that no one likes to be called a monopolist. If you think you don't have enough copyright, it's really hard to go to Congress and say, "Give me more monopoly." But it is easy to go and say, "My property rights are being violated, help me defend them." Now, there is a strict sense in which copyrights and especially patents are monopolies. When you write down a collection of words, this essay that I wrote right here, when you write those words down, you get a copyright in them from the instant they are fixed. That copyright gives you the exclusive right to reproduce, adapt, display, perform those words. Your rivals can compete with you by writing different words and hope that magazines will pay them for those words to reach their audience instead of you for your words. But only you can sell that essay that you just wrote. In that sense, it's obviously a monopoly. It's a product with only one seller. That's the definition of a monopoly. But there's another definition of monopoly, the one that competition regulators use. You don't have to own the whole market to have monopoly. You have monopoly as soon as you have what regulators call market power. And market power is the ability to set prices without having to worry about your competitors, the ability to operate as though other people's wishes don't matter and they have to listen to what you say and you don't have to listen to what they say. And I beg your pardon. So think about like how HP gets to sell you ink and charge you very high prices for it. HP doesn't have monopoly, but they do get to set the prices. They do get to use IP. They get to use DRM law to punish people who make interoperable cartridges. And also HP is in an industry that's so concentrated that everyone else has the same scam. So the people who bristled at having their copyrights called authors' monopolies, they have a point. It's a rare author who gets to have market power, who gets to set their own prices, walk into their publisher and say, here's how much money you're going to pay me. And if you don't like it, you can go pound sand. I mean, you can go and say that to your publisher. Your publisher will show you the door. There are a few superstar exceptions, but they're rounding errors. In the main, having a copyright does not give you market power. However, there are actual market power monopolies in the sense that regulators talk about them in the entertainment industry. For example, there's like one movie theater chain, AMC, about to go bankrupt. There's 3 record labels. There's 4 publishers, soon to be, or 5 publishers rather, soon to be 4, because Simon & Schuster is also about to tank. There's 1 national brick and mortar bookstore, and there's 1 digital bookstore, and they control also the entire market for audiobooks, like 90% of the audiobooks. And how did those monopolies emerge? Well, in some ways, they emerged the same way all the monopolies did. We have monopolies in energy, eyewear, finance, automotive, aerospace, accounting and auditing, civil engineering, and logistics. And they all came from one thing: lax antitrust enforcement. 40 years ago, we decided that companies should be allowed to grow by buying their nascent competitors before they could grow to be a threat, like Facebook did when it bought Instagram. We decided that companies could merge, like AT&T did when it merged with, T-Mobile did when it merged with Sprint. And we decided that companies could acquire vertical monopolies, as Google, Facebook, Universal, and AT&T all have. But entertainment monopolies, they're very special monopolies because they also consist of a bunch of aggregated authors' monopolies. Monopolies are durable in a way that market power is not. If you're like Universal Music and you control half of the music that anyone who wants to record music would have to license in order to sample, then anything that they do to get around the bottleneck, it's not clever entrepreneurship. It's a copyright violation. You can have them sued for trying to get around your creative monopoly, your market power monopoly. That is to say, if you're in banking or aerospace, you can get sued for being anti-competitive. But if you're in publishing or movies or music, you can sue other people for being pro-competitive. So the result is a monopoly that controls access to distribution channels and audiences, and that can invoke the power of the state to fine or even imprison people who challenge the monopoly. And tech is moving in on some of those entertainment monopolies, but only to establish its own monopolies. Think about Kindle Unlimited and Kindle Originals from Amazon. Every one of them comes with DRM that is locked to Amazon's platform. Removing that DRM is a felony. Even the author is not allowed to remove that DRM once it's been applied by Amazon. And so forever, even beyond the duration of the copyright, those works remain locked into Amazon's platform. The longer we go, the more of the audience is trapped inside of Amazon's walled garden, and the harder it is to reach that audience without surrendering your copyrights to them. If Congress gives you more copyrights, Amazon will just take them as part of the contract. It's like if your kid is getting beaten up for their lunch money, you won't get them fed by giving them more lunch money. The bullies will just take that lunch money too. And so every author who wants to reach the audience that Amazon has trapped has to surrender their copyrights. The more copyrights Amazon has aggregated in this way, the more thoroughly trapped the audience is, and the more authors there will be who surrender their copyrights to them. Authors' monopolies are not market power monopolies, but if you aggregate enough authors' monopolies in one place, you can turn them into a market power monopoly that is backed with the power of the courts and the prisons, and that accumulates more authors' monopolies every time someone enters the captive marketplace. So this is the big finish. Thank you for your patience. I'm about to get to the end of it. So you probably heard network founder Marc Andreessen's aphorism that software is eating the world. Andreessen is wrong. Software has already eaten the world, past tense. If there was ever any doubt, the pandemic has surely erased it. Lockdown, viewing the world through these screens. How can we doubt that software has eaten the world, that there's any distinction between human rights and digital rights? There's no more software freedom, there's just freedom. Software is expanding relentlessly into every device and system, from ventilators to tracking, from toothbrushes to sex toys, from refrigerator filters into money itself. And wherever we find software, we find IP. software deployed to control the conduct of competitors, critics, and customers in such a way that overlapping systems of laws can be invoked to punish anyone who bypasses the software. The combination of software and IP in every device is a sea change for the organization of our society. As firms have become increasingly concentrated, as monopolies have emerged in every sector, they have also figured out how to infuse their products with just enough software that they can invoke IP to control their competitors, their customers, and critics. These are market power monopolies backstopped by creative freedoms, which create IP rights that supercharge their market power. All of this, it's just the curtain raising. Software isn't just a way to put IP into otherwise inert objects. It's also a way to automate those objects, to make them into unblinking, ever-vigilant enforcers for the manufacturer monopolist's interests. They can detect and interdict any attempt at unauthorized interoperability and call the appropriate authorities to punish the offenders. This is a level of control beyond the wildest dreams of history's most sociopathic monopolists. Think about the coal boss, who controlled his workers by moving them into company housing in his company town, where they were paid with company script that they could only spend in the company store. That coal boss moves titanic amounts of risk off of his balance sheet and onto his workers' balance sheet. Not only are they incapable of leaving for a better job without paying the debts, but they're also paid in proprietary, non-interoperable money that only works at the company store, and the prices there can be adjusted at will.
Hey, Corey?
Yeah.
I didn't want to interrupt you. I apologize, but we're getting a lot of static on your microphone, and I wanted to let you know.
That's not good. Okay, let me just try rebooting my my mixer board.
That actually sounds great. That's perfect.
Oh yeah, weird. Okay, yeah, my mixer board has been we the third day of the lock-in, our local power substation exploded. There was a mile-high fireball, and in the resulting power surge, the ground lifter that I had for this blew up, but the mixer was okay. But it keeps getting worse and worse. So I think the magic smoke went out. Anyway, I'm nearly done here.
No. Yeah, I just wanted to let you know because it just started, and I figured we could catch it, and then
I hope I hope you managed to hear that. So the coal boss, he can raise prices to ensure that the debts are never paid, and since the workers are only paid in non-interoperable money, they can only shop at the place where the prices are going up. But even that coal boss, who was a veritable god to his workers, he wasn't all powerful. A coal worker could buy corn at the company store, find the moonshiner, and trade corn for U.S. greenbacks. He could get interoperable money from proprietary money through an intermediate corn transaction. The corn was an abstraction layer on U.S. dollars. But think of a worker being paid in company script today. The digitally enabled smart goods that they buy at their company store can be locked to their accounts the way that a Kindle book or an iPhone app is locked to your personal device. The unblinking eye of software enforcement systems are always watching, ready to discipline you for your lack of consideration for the poor shareholder's bottom line. Once we had cake, today we have icing. At this rate, the icing will be gone before long. This is why there are no digital rights. There's only human rights. It's why there's no software freedom. There's only human freedom. Thank you. And that's it.
That was amazing.
That was powerful.
Yeah, I love it. No, it reminded me a little bit of content, your book content, or
my essay collection.
Yeah, but it's so much more powerful and so much more impactful. Thank you for reading that. That was absolutely amazing.
Thank you. I appreciate that. Yeah, like I say, well, there's that old saying, I didn't have time to write you a short letter, so I wrote you a long one instead. That, as these ideas get sharpened up through this kind of discourse, and they get clearer and better, and then, periodically you have these phase changes where, like, you have a realization of a wholly new way of putting it that comes out of that process. So thank you. I think it'll get better still, but I'm glad you liked it. It's not something I'm as confident with as the usual material I deliver.
Well, if that's your like unconfident material, I don't think the rest of us have much hope.
Pshaw.
I wouldn't want to follow you, that's for sure.
Yeah.
I was actually running around looking for content. I found like Eastern Standard Tribe, I found United Kingdom, etc. And I was looking.
Well, I think I've got a copy here. Hang on. Oh yeah, there it is.
Yep.
Yeah.
I'll link to it in chat as well. For folks.
Thank you. Yeah.
But no,
Typography by John D. Barry, who runs Microsoft's or did run Microsoft's Type Lab. I don't know if he still is. It's kind of the god of true type. It's a pretty amazing guy.
it was very interesting. I also like the comparison between, and Heather and I were talking about it in direct message. I like the comparison between the sorts of cutoff that you have, or you would see in very extreme, in very extreme governments doing like basically information operations, cutting down on who can talk to whom, with the sorts of walled gardens and curation that we see in Facebook and things like that. I think that was incredibly impactful and incredibly powerful too. So
thank you. Yeah, I mean, interoperability. It's funny when that whole thing on interop. So I work on interop a lot with Electronic Frontier Foundation. We have this thing, we used to call it adversarial interoperability, which is so hard to say. So now we call it competitive compatibility, or ComCom. And some of this comes out of there. And we were in our competition meeting, and I said, I really think that like we under theorize the role that like free software plays in interop, and that really like, the whole point of free software was to allow you to have one foot in one, like to create a document using a proprietary system, but then not be married to the proprietary system forever. You could move over into the free software world. And one of my colleagues said, no, I don't think so. I think they wanted to build just an ecosystem of free software tools. They didn't really, compatibility was part of it. And like, I really thought about that, and I realized, well, first of all, Richard's first project was cloning Unix. So like, obviously interoperability was a big part of it to begin with. But I remembered I was at a dinner once that he was at, and someone at the dinner was talking about how much they like Flash as a tool of software freedom because it let people who didn't understand software make code. And he said, well, you have an obligation to make a runtime for that code so that they can have both kinds of freedom. Right. And I realized that like actually software freedom and interoperability, they really are intimately related. And this idea, the take it or leave it idea, is really broken. Like we never say take it or leave it, right? Like, otherwise you end up like after the French Revolution when they were like, oh, screw that bougie 12-month calendar. We're going with decimal calendars from now on. And no one in the world could figure out how to talk to them. I mean, I know that it's worked sometimes, like you've got the Russian Orthodox calendar and like the Julian calendar, or whatever. But for the most part, like if you can't interoperate, it's a really self-limiting move. And particularly in 2020, like imagine if you tried to go with a decimal calendar, what it would mean for your, like, whether or not your router's timestamps could be read,
Yeah. Basically tying yourself into something that is effectively an anchor at that point. You force people into it.
Think about all that, like the call for COBOL programmers at the start of the crisis when they were like, oh, we wrote all of our accounting code and all of our, unemployment benefits code and in this programming language that no one speaks. And, like we stuck this abstraction layer on top of it so it could talk to the web, but underneath it's running this old stuff. And like, on the one hand, that's super broken. On the other hand, everything is made up of layers upon layers upon layers. Like when I open up a terminal window on my computer, it says TTY at the top, because at some point, like it's an abstraction layer on an abstraction layer on an abstraction layer on an abstraction layer on an abstraction layer of a thing where you would like take an RS-232 or like a phone and acoustic coupler and plug it into a line printer that go and we didn't throw away the code. We like added code on top of the code. And I know you're security people, you hate that, right? But it's also like you understand why it's there, right? That even though there are like manifest problems with it, we don't throw it away, right? Like we keep it,
evolve.
like, yeah, we evolve. That's right.
Yeah. I don't know. I want to go back to corn as an abstraction layer. That was my favorite part. Like, that's corn as an abstraction.
Yeah.
Yes.
Yeah.
That's completely valid, right?
Sure.
The same idea, right?
Yeah, you could just got to round trip it through this other thing, like
Yep.
if you want to, you just, it's like Web 2.0 for company stores, right? You've got you've integrated the moonshine, you've taken the moonshine object and dropped it into your workers' company housing shack.
Oh, this got really dystopic really quick.
Yeah.
Although I do have a question.
Sure, go ahead, Heather.
We kind of mentioned like Microsoft, and like I remember I'm younger than pretty much everyone here. Sorry. I remember growing up and like the Microsoft monopoly being this huge deal and like reading about it, and now honestly it's kind of like we've gutted ourselves. Like we've got this like I got mine culture, and I don't care if anybody else has to deal with that or if we, release IP to the public trust anymore. How do you fix that? Is this like we overturn Citizens United? Like, what would you do?
Yeah, it's got to be an iterative process. Like clearly Citizens United has changed the way that we make laws. On the one hand, there's this like, there's one really important thing about antitrust, which is that almost all of antitrust enforcement is not about which laws we have. It's about how they're interpreted by the administrative branch. So, like the person sitting in the Oval Office just writes a memo and then you get different antitrust, right? Like, and obviously there are problems with whoever sits in the Oval Office and like influencing them is hard, but it's not like you have to get a law through Congress to make this happen, right? You just need to change how the administration views it. And the remedies are actually pretty simple. You can do things like ban companies from buying nascent competitors for the purpose of snuffing them out before they can grow to be a big competitor. And sometimes it's hard to know why a company is buying another company, but like Zuckerberg straight up said, we're buying Instagram because people are leaving Facebook. Right, like straight up said it. Like it wasn't like he whispered it to to his like Sheryl Sandberg in their secret lair. Like he put out a freaking press release that said it. Like we know, right? We know why they did it. So that's one thing. We can block companies from buying smaller companies. We can stop them from merging. Right, large firms shouldn't be allowed to merge. Like not merely because they might raise prices, but because it creates uncompetitive marketplaces. We want companies to compete with each other, right? Not to collude with one another. People look at that picture, the picture of Trump around a table with all the tech leaders after the inauguration in Trump Tower, and they're all sitting around like not a giant table, like maybe like billiard table size. And people were like, "Oh, how could those guys meet with Trump?" Blah 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 blah. But I looked at that and I was like, "How do all the people who run tech fit around one table?" Yeah. Like, you think about how important that is.
Think about it.
Yeah. And, like conspiracies are hard, but they're hard because of the collective action problem, right? The fewer people there are inside your conspiracy, the easier it is to coordinate, right? And when you've got 5 dominant firms in an industry, chances are that like everyone in the C-suite of all 5 firms worked at least 1 or 2 of the rest of them. And they're probably either godparents or married to people in the remaining ones, or like executors of their estates, right? Think about the top brass in any of the big firms, right? So you don't need like an active conspiracy. You don't need everyone to gather at the clubhouse to decide how they're going to screw the rest of us over. You just have convergence, right? With like 5 big players, you have convergence on what the rules should be. And so we should stop big firms from merging. And both of those are like really important because right now, because of the financial crisis, a lot of smaller firms are facing, extinction level events. And the big firms have got a lot of money because they have maintained the pretense for the last 25 years that they are headquartered in the middle of the Irish Sea and that their money is in a low Earth orbit and not subject to taxation. And as a consequence, they're about to like buy all of these small firms. Google wants to buy Fitbit. And if you have a Fitbit, chances are you have it because your employer said you had to wear it to get the best deal on your medical insurance. And maybe you were dumb enough to like input how many drinks you had into the app and like whether you were menstruating and all the other things that Fitbit would handily track for you. Maybe and if you don't have it for that reason, you probably have it because you were like, God damn, I'm not giving all that data to Google. Well, Google's about to get all that data. Right?
That was going to lead into my next question is like, how do you feel about big tech and big healthcare getting into bed with each other?
Yeah, like it's a match made in hell, right? But we need to be really vigilant right now. And what we need to do is say no, not okay, but make some promises, right? So like Google made all kinds of data privacy promises. Like they promised they would never merge all of the data they collected from like ads and search and YouTube and stuff. And they broke the goddamn promise. So the European Union has just said, you can merge with Fitbit, but you have to promise you won't merge the data. And Google's like, oh yeah, we'll make that promise. And you know what? Like, fool me once, shame on me. Shame on you. Fool me twice, we don't get fooled again, as George Bush once said. Like, come on, guys. Like Lucy in the football here, right? So we should just say no, right? Not like yes with conditions, just no. Like, what, like, I want you to shit sandwich. No. What if I toast it? No. What if I cut it diagonally? No. What if I cut the crust off of it? No. I don't want a shit sandwich. Like, no shit sandwiches. That should be our rule. Not shit sandwiches with conditions, not with chocolate sauce. Like, it's the Sam I Am rule, right? Not on a train, not on a plane, not on a tree. Like, no shit sandwiches. Just stop. Okay. And then the last thing we need to do is we have to stop them from creating vertical monopolies. We had this rule called the structural separation rule until the Reagan years. And it said that if you ran a platform, you couldn't use the platform, right? If you were a bank and you were loaning money to businesses, you couldn't start a business that competed with your customers, right? For obvious reasons. If you were a rail company and you ship freight, you couldn't start a freight company that competed with the people who put freight on your company, on your rails, for obvious reasons. Apple, Google, Facebook, they all operate platforms and compete with the people who use the platforms. Pick one, right? So we got to break them up. And that's going to be a slow process. It's going to be iterative. It's going to cost billions of dollars. When they were suing AT&T to break them up, or IBM to break them up, I beg your pardon, 12-year process that ultimately failed because Reagan was elected, basically, and he fired the guys who were working on it. But during that 12-year process, every single year that they were litigating against IBM spent more in legal bills than the entire DOJ spent on its entire antitrust division that was doing all of its enforcement. It's a long process. But even if you don't win, you do win, right? So we lost the fight to break up Microsoft. You mentioned Microsoft. We lost the fight to break up Microsoft, but Microsoft changed its behavior as a result of being like tied to the bumper of the DOJ by the ankles and dragged up and down a gravel road for 9 years, right? Bill Gates, if you've ever seen Bill Gates's deposition, it's on YouTube. He humiliates himself. You have never seen him in worse form. He is belligerent. He's stimming. It's an embarrassment. And he was humiliated by it. It was one of the first viral videos. And for years after the antitrust action, anytime anyone said, hey, let's do something evil, everyone else was like, didn't you see what they did to Bill? No, we're not going to do that. Right. So Google comes along and, Microsoft could have done to Google what they did to Netscape. They didn't do it. And when you talk to Microsoft insiders, they say, we didn't do it because we didn't want the DOJ to come down on us again. Bill Gates last year, he gave a talk, I think it was at a Recode event, where someone said, like, why did you screw up on mobile? Why didn't you buy Android? He said, oh, we were distracted with that DOJ thing. Android was on the market 7 years after the DOJ enforcement action ended, right? When he says we were distracted, he means we lost our nerve. We were behaving ourselves. As Albert Camus said, sometimes you have to execute an admiral to encourage the others, So like, it sets the tone, right? The enforcement sets the tone. So that's what we need to do. We need to do this stuff. It'll be iterative. It'll take a long time. But we got to start somewhere, right? Like every time, your technology debt reaches some like critical mass and the thing you feared finally happens and everything that you've been sort of nursing along falls over. Well, you show up for work, you curse the fates, and you start writing new code, right? You got to start, like, the journey of 1,000 miles begins with a single step, right? You got to start somewhere.
I guess one implication that really worries me with this conglomerate of those that control tech is not only do they have the platforms in which political discourse occur, but they also have the data on, who you are and what to show you. And I guess that's one of to me, the scariest ramifications right now of sort of that of that control.
I'm a little heterodox on this. So like, I do think that the data matters. I think it matters for a couple of reasons. I think the biggest reason it matters is that it's compromat, right? It's just a way for people to embarrass or blackmail you. The knowledge that it's being gathered makes it hard for you to be your authentic self. Like it's just bad in that way. I'm skeptical though that big tech has a mind control ray, right? Like I know big tech claims to have a mind control ray. Like if you want to buy an ad from Google, they'll be like, yeah, we can like do this thing and this other thing and machine learning and big data, and we'll put it all together, and whatever it is you're selling, people will buy. Well, like you want to sell fidget spinners? We got people who will buy fidget spinners from you. We'll show you how to do the message. And the theory goes that like Robert Mercer and Cambridge Analytica went like, oh, we can use that fidget spinner thing to make people racist and vote for Donald Trump. And I think that there's not much evidence that works. Like people point to that giant Facebook study where they did the voter influence study to see if they could get people to vote. And they like completely changed the way that those people saw the news and interacted with their friends. And they got an effect size of something like 0.25%, right? So like it's a real, like it survives like a lot of statistical regression. It's probably a real effect. And sure, yeah, like telling people stuff can change how they think for sure. But it's not a giant effect, right? It's not a real issue. So, or it's not like an existential crisis. So it does raise this question though, because people do believe some weird stuff, right? Like QAnon, I mean, flat Earth, right? Like there's never been a worse time to be a flat earther because there's never been a time when more people on Earth have seen the curvature of the Earth, right? Like, went in a plane, like your kid's school might be sticking a GoPro on a helium balloon and capturing the curvature of the Earth. So I think that like, if it's not mind control, and it's not that the flat earthers have gotten better at their arguments, and they sure haven't. When you read the arguments for anti-vax or flat earth, like none of these are new ideas, right? Even QAnon is just like a reheated version of old stuff, like the Protocols, the Elders of Zion and stuff. They're not better at arguing than they were in the 70s. So if they got bigger and it wasn't through mind control and it wasn't because they got better arguments, I think that what it has to be is that on the one hand, it's become easier to find people who might want to hear that argument. So it has been historically hard to put up a sign that says, like, come on down to Crazy Bob's used car lot. We're racist. If you're racist, you'll like to shop here, right? Because like people would get angry at you. But you can use targeted Facebook ads to say, hey, are you a racist? Shop at Crazy Bob's, right? So that's part of it. It's definitely easier to find people than it ever was. I mean, and that's not a necessarily a bad thing, right? If you want to ask yourself like how it is that people who were members of sexual minorities who couldn't disclose to the people around them what their true identity was could find other people and make common cause and advance the way that we think about gender, that's because it's easier to find people, right? Where did the Black Lives Matter movement come from? It didn't come from wheat pasting posters on telephone poles, right? I grew up in the anti-nuclear proliferation movement. I have wheat posted tens of thousands of posters for my sins. They are really low conversion rate, right? It came from targeting. It came from self-targeting, right? Looking for a hashtag. It came from targeting in other ways, search, all of those things that help you find people. So I think on the one hand, tech is much better at finding people, and that's because they spy on us, right? So they know a lot about us. Find me cheerleaders who have been searching for new uniforms and let me advertise my cheerleader uniforms to them. That is a thing big tech can do for you.
It's big money, yeah.
Yeah, and it doesn't have to work really well. I mean, you think about I always think about the poor refrigerator company, right? Like the median person buys one or few refrigerators. That's great. The median person buys one or fewer refrigerators in their whole life, right? So how do you advertise a fridge? Like mostly it's stuff like I put a billboard by the airport because refrigerators cost money and plane tickets cost money. So people who fly have money and they might buy a refrigerator, right? So that conversion rate is like 0.000000001%. And then you're like, okay, I'm going to use big tech and spy on people who've looked at refrigerator reviews. And now your conversion rate is like 0.00001%. Still like 4 orders of magnitude better. I pay for that if I'm a refrigerator guy, but it's not a mind control rate, right? Like you haven't done a magic trick, right? You've just found a correlate. Some of the correlates may be harder to find, and a little regression in the machine learning can help you find them. But most of the correlates are actually pretty obvious, right? They're just like, I have cheerleader uniforms. I need cheerleaders who are looking for a new uniform, right? Like they're really straightforward. That's the bulk of that business. But the other piece is like, why are people willing to believe conspiracies? Like what has made those people there to be found? What makes that cohort so big? Because I mean, I don't have any way to demonstrate this, but I really do believe that more of us are willing to believe conspiratorial explanations for what's going on in the world. And I do think that has changed. And I think the reason it's changed is because there are more conspiracies that explain what's going on, and not conspiracies like QAnon, but conspiracies in the sense of corruption, right? Like, how did the Sacklers manage to sell oxys and kickstart an opioid epidemic that made them richer than the Rockefellers and killed more people than the Vietnam War killed Americans in America, right? It was because the FDA looked the other way. They let them cite garbage evidence. You know, the if you look at all the papers about the safety of opioids, they all go back to one paper. It's like they call it the most consequential 5 sentences in the history of the New England Journal of Medicine. This guy named Jick, who was a doctor at Boston University, wrote a 5-sentence letter to the NEJM saying, you know, they say opioids are like, you have to be really careful with them with patients in recovery from surgery. But I've been a little looser with them, and I don't see the kind of addiction that you'd expect. Someone should really study this. And that is the thing that is cited in all the research that the Sacklers published to say, oh, no, everyone can take as much oxy as they want, right? So, like, the regulator's
there's a healthy
job
bit of
is...
cynicism, basically. There's somewhat, so there's this bit of cynicism that comes from, like, actual events that have occurred and become public, and now everyone's connected and they can see that.
Yeah, and you can't adjudicate these questions yourself, right? Like, even if you can figure out whether or not you should fill the script that your doctor gave you for oxys, can you figure out whether the firmware on the 737 you're going to fly on is any good, right? Like, was it right to trust Boeing to self-regulate? How about whether or not the curriculum that they're delivering to your kids in lockdown is any good? Are you a pedagogist, right? Like, how many of these disciplines do we master before we say, wait a second, we are not asking people to caveat emptor. We are convening neutral truth-seeking exercises of independent experts who adjudicate claims from rival experts to try and figure out what's true. And we trust those people not because we understand the science, but because we understand the process, right? You have to recuse yourself if you've got a conflict of interest. You can't go work for the companies. The companies themselves are diverse enough that they don't have monopoly rents that they can throw at bribing you, right? Like, that's the only way you can know what's true. Everything else is just like guesswork, right? It's just like, find an expert, cross your fingers.
And we did have one question here, which was, is it sort of the idea that, and I've thought about this too, actually, the idea that, there is this, I think anyways, minority of the population that now, based off of, and I don't think it's a nefarious, purposeful thing. I think it is very much, we have the data to target you, and it does it with this outsized voice, as it's put, with this ability to, like, that minority of the population, like, to be able to target people that might slightly agree with them. Does that play a part, or is it
totally.
just a situation of, there is, like, this hidden population of sizable, or a sizable population that's hidden that doesn't really, talk about their horrible beliefs in some cases.
Right. Well, so no, it's definitely the case that if you have a megaphone, you can reach more people, you can convince more people, you can drown out people who might otherwise convince people that you're wrong, right? Like, all of that stuff matters. And one of the ways that it matters is that when all of our conversation takes place within a couple of silos, if you can figure out how to game the silo, if you can get to the top of the search results, or get a topic trending, or figure out how to game Facebook algorithms, then you can you can own the information space. You can drown out competing voices. You can create what Data and Society calls a data void. Like, when I go to Google and I type in how long is the Brooklyn Bridge, and I get an answer that's off by 20 feet, it's not a feat of mind control. It's just that there's only one place where we go for answers. I don't know what the actual answer is, and I believe whatever it tells me, right? And so, like, yeah, maybe we should ask people to do the research every time they go to Google and look at the primary source. No one's going to really do that, practically speaking. But if we had a lot of different places, maybe you'd look at 2 places, right? Maybe you'd search around rather than, and maybe the process of gaming Google's algorithm to get your wrong answer for the Brooklyn Bridge, or for climate denial, or for austerity or any of the other things that people have gamed Google for, maybe you would have to replicate that feat so many times that it would be less effective.
That's a good point. And we have another question here, which is a really good question. What can a regular person do to sort of fight, to go against the grain of, seeing that one sphere?
Well, I'll tell you what you can't do. You cannot shop your way out of monopoly capitalism. Right? Like, that's the point. You cannot shop your way. Like this is actually one of the great crises of 40 years of neoliberalism is framing everything in terms of personal responsibility, right? Like, are you worried about the climate? Why aren't you recycling? Right? Like you can recycle all you want and your city will still drown, right? These are systemic problems, not individual problems. And systemic problems are hard to fight, but there is good news. So there's a copyright scholar called James Boyle, who teaches at the University of, he teaches at Duke University, runs the Center for the Public Domain. And Jamie has this idea he calls the knowledge ecology. And it comes from the ecology movement. He says that, in the run up to the coining and the currency of the term ecology, we had people who cared about a whole bunch of different issues. Like some people cared about whales, some people cared about owls, and some people cared about fresh water or the ozone layer. But they didn't really see themselves as being part of the same movement. They were like, those guys are doing good work too, but we're not on the same side. The term ecology took those issues and welded them together into a movement. And the movement changed the world and continues to change the world. I mean, it remains to be seen whether it will save the world, but certainly better than it would be if we all thought of those issues as atomized. And the thing about monopoly is that by definition, it's got a lot of different people who aren't very happy with it. Right. So you might care a lot about software monopolies, but you've probably got a relative who cares a lot about healthcare monopolies or finance monopolies, or maybe a younger relative who cares a lot about wrestling monopolies. 30 years ago, there were 20 pro wrestling leagues, and now there's one. It's owned by this billionaire Trump donor named Vince McMahon. He reclassified all the wrestlers as contractors and took away their healthcare. They're all begging on GoFundMe for money to pay their bills as they die in their 50s. Right. Or maybe you care about the eyewear monopoly, right? Your glasses and mine were all made by one company, a company called Luxottica, that is this private equity-backed Italian company that bought all of the major retailers, Sunglass Hut, LensCrafters, Sears Optical, Target Optical, and so on. And then they refused to carry any eyewear brand that wouldn't sell out to them. So now they own Oakley, Oliver Peoples, Versace, every eyewear brand you've ever heard of, except for a couple like internet ones. And they own the largest lab, Essilor, and they own the largest insurer, IMED. And so, the prices of glasses have gone up 1,000% over the last decade, right? So if you've got failing eyesight, you care about monopolies too. Now, you may not care about the wrestling monopoly, and you may not care about the big tech monopoly, but if you're pissed off about the eyewear monopoly, I'm on your side because we both care about monopolies. We have the same solution, right? That solution is vigorous antitrust enforcement. And so you and I can fight together. That's the thing that's going to save us. It's not going to be your individual actions. The individual action you can take is to join a coalition so that we can gang up our work and our agency and our citizenship and our significance and our influence together to make this a cause. And, I have to be careful because I work for a 501c3. I have to be careful about what I say about elections. But we are going into an election, and competition is an issue that candidates in both parties are actually talking about. And so you very well might have a decision to make, either in a primary race or in the general, about which candidate you support that could turn on things like competition. And it's become a bipartisan issue. So that is your chance, right? Right now, you have the opportunity to exercise power in ways that you rarely do. You're probably going to have people at your door ringing your doorbell saying, will you vote for me for town council? Ask them what they're going to do about the monopoly that your cable operator has over your internet service. I guarantee you that's an issue that the people in your city care about, right? On lockdown, when you've got terrible internet, it is not good. And, monopolistic ISPs have been a serious problem for people in lockdown. So think about Frontier. They were the worst ISP in the country, which is really saying something. They went bankrupt. And we got to see their bankruptcy filings. We got to see we got to see everything that was going on. So here's one of the things we learned about Frontier. So Frontier, like all big companies, they pay their executives primarily in stock. right? That's the major form of compensation at the top level. And so those executives want to make the stock prices go up. And the analysts who make the buy or sell recommendations in telecoms, they have a general prohibition on any capex that amortizes over more than 5 years. So if you do any infrastructure spending that takes more than 5 years to turn into profit, your share price goes down because the analyst says, don't buy Frontier stock. They're jerks, right? So Frontier had 1 million households that they could have profitably connected to 100 megabit fiber and earned a $1.9 billion return over 10 years on a $1 billion investment. $900 million, which they did not spend, they did not earn, right? They chose to leave it on the table. They jettisoned the chance of earning that $900 million, and they left those people on 20th century copper loops that are delivering DSL speed in a pandemic lockdown because they didn't want to affect their share price. So you know what? When someone rings your doorbell and says, hey, I'm running for city council, what can I do for you? What do you care about? Ask them about Charter or Comcast or AT&T and ask them why your city isn't building a fiber loop and giving everyone there 100 megabit fiber. I live here in Burbank, California. It's a little 100,000 person city just outside of LA. It's in LA County. It's where all the studios are. Because all the studios are here, we've got a really good fiber loop. The city put out a bond, built a thing called Burbank One. It's a 100 gigabit fiber loop. It runs under my foundation slab. I am stamping my foot on it now. I have Charter because the deal with Charter doesn't let Burbank connect my house. Even though I pay business tax because I run a business out of it, it's not zoned commercial. So Charter has the monopoly on providing me. It's $100 a month. Charter CEO was the 4th highest compensated CEO in the country last year. He didn't give his service techs who come into your house to fix your stuff PPE. Instead, he gave them vouchers for discounts on restaurants that had closed during the pandemic as a way of compensating them for hazard pay, right? Ooh. So, like, that's my bread and butter issue. Ouch. So this is your chance, right? Like, I can't tell you to vote Democrat or Republican because I work for a 501c3, but I can tell you to vote for pluralism, to vote for antitrust, to vote for trust busting, to vote for fair economic fairness. And that is not a partisan issue by and large. That there are people on both sides of the aisle who care about it.
Wow, that was a great answer.
Wow, that is a great answer to that question.
That was amazing.
Yeah. Really not much else to say to that, right? You know,
thank you.
Everyone has the choice, and do your research and go vote.
Go vote. Yeah, voting matters. I don't get to vote. I'm a Canadian. The way that I get to vote is by telling you to vote. Right? It's we're Canadians are like serial killers. We're everywhere and we look just like everybody else.
Well, how about that?
How about that? Hey.
Well, Corey, we appreciate it. We appreciate your time, your thoughts, and
thanks, guys.
Just the support as well, like coming on and helping us with this conference. It's been an amazing experience, and it's been great to have you on. Appreciate it.
You know what? Before I go, it occurs to me I should plug my new books.
Yes, yes, please.
So I don't even have them near me. Hang on one sec. Hang on. I've got one of them here. I'm not as mercenary as I should be, obviously. So the first thing.
Welcome to the team. Yes.
Yeah. I wrote a picture book. For little kids. It's called Posey the Monster Slayer. It's about a little girl who's like a maker. She's a toy hacker, and she repurposes the toys in her bedroom as monster killing weapons, field expedient monster killing weapons. But she won't go to bed, so her parents are slowly turning into zombies. And they're the only monster that she can't defeat. It's got a beholder in it. Check it out. She maces it with bubblegum scented perfume. So Posey the Monster Slayer, it's from First Second with Pardon Macmillan. They do all my books. Illustrated by Matt Rockefeller. The other thing is that there's a new edition of my novels, Little Brother and Homeland. Those are my kind of infosec-y, civil liberties books. And the new edition has got both of them in one set of covers, and it's got a new introduction by Edward Snowden. And one of the cool things about the book Homeland, the sequel, is if you watch the Snowden documentary, Citizen 4, the one that won the Academy Award, as he's like bugging out of his hotel in Hong Kong and grabbing stuff and sticking it in his bag, one of the things he grabs is Homeland. and sticks it in his bag. So it was really cool that Ed agreed to write this this intro for me. And the reason my publisher brought out this new edition of Little Brother and Homeland is there's a third Little Brother book coming out in October called Attack Surface. And Attack Surface is about a woman who works for a malware company, like a cyber arms dealer, like Palantir or NSO Group or Blackwater. And she spent her whole career like hunting jihadis as a military contractor at a forward operations base in Iraq, and then, you know, working for like ex-Soviet dictators in the former Soviet Union, putting down pro-democracy movements. And after a while, she can't live with herself anymore, and she decides she's going to go home to Oakland, where her best friend is running a successor to Black Lives Matter and is being hunted by the same cyber weapons that she developed. And it's full of like IMSI catchers and countermeasures, adversarial machine learning and adversarial examples to disrupt facial recognition algorithms, binary transparency, and you know, open ledgers to catch malware injections in the supply chain, and all kinds of like super deep infosec-y topics that are presented in a way that I hope makes them accessible to normies.
Well, I just purchased one of them, and I'm in the process of getting more of them. So that is awesome. We've got the links up there for the viewers, so they'll be able to go into, and we'll put it into our Slack chat.
Yeah,
as well.
Very exciting.
Thank you. You and Ed Snowden.
They're amazing.
All right. Well, thanks, guys.
Thank you, Corey.
Thank you.
Thanks again.
Bye.
Thanks for your thoughts, and we'll talk.
Thank you so much.
Oh, one more thing.
Of course.
Yes.
If you are a Mexican national or a Mexican resident, Mexico just passed a terrible copyright law that imports all the worst aspects of U.S. copyright law and then some, including prohibitions on security research where you have to bypass like a bootloader to get at it. It looks like it has an exemption. It doesn't have an exemption. The exemption only applies if it's like good faith for the sole purpose and non-commercial, and it's basically impossible to use the exemption. We've had the same one in the US for 22 years. No one's ever managed to use it. We have until the 31st to get the Mexican Human Rights Commission to look into this law, and they can just invalidate it at the stroke of a pen. There is a petition for this. If you go to EFF.org, you will see a post that I put up just before this talk that analyzes the speech dimensions of the new law. It's part of a series. I've got 6 posts going up this week analyzing the law. And at the bottom of every one of those posts is a link to the petition. Please, if you are in Mexico, if you know Mexican people, if you are a Mexican citizen, please, please, please get in touch. We have a chance to invalidate this law. Terrible law. That's the URL. All right. Thank you, everyone.
Thanks.
Bye.
Bye.
Thank you.
Thank you so much.
Dang, that was awesome.
Cool.
Yeah, amazing.
Well, guys.
I don't know how we close out after that.
Yeah, it's gone.
Well, let's recap what was discussed today. I mean, if you think about it, we talked about, you know, the digital rights were discussed on both the EFF side of things, and, you know, Corey touched upon this as well. Talked a little bit about just software, the history of software. You know, I guess, you know, the question is, we haven't really talked about is where is all this headed, but I don't know if you want to end on that note, or if you want to save that for a part 2.
I don't know if that's a simple question to answer. Where is this all headed, right? You didn't even talk about CSP. You didn't talk about risk or machine learning. Man, you know, like all you care about is, I see how it is, Ken. I see.
I think it's important to know where you came from to know where you're going, right? That's what we did tonight.
That's true. But I don't know. I like Corey's like, go vote, right?
Yeah.
Take a personal,
I think we should
take the initiative, personal initiative, and go vote.
Yeah.
Be involved. I think if anything is solidified in my head, it's, you know, focus on local problems for sure.
Yep. And it'll cascade from there. So.
And also, obviously, electoral security is fascinating to every one of us, right?
Yeah.
So there's a lot of interesting things there. There's a lot of commentary to be made there too. But it's super interesting to see that, and yeah, absolutely get out and vote, please. So,
Hey, Heather and Stefan, you two did an amazing job. Thank you so much. You did so much work. For anybody that thinks Seth and I had, done the legwork here, that really, honestly, Stefan and Heather did the majority of the heavy lifting, and we sincerely appreciate that. Thank you.
Yes.
No, thank you for putting up with my like fever dreams of running a conference.
I love your fever dreams.
I really feel like that's what it was.
Yes.
We're like building into this dream to make it happen.
I love how we finally figured out how long I can get people to shut up and listen to me. It's about 6 hours.
Everybody's done. You can see the numbers starting to drop.
About the limit.
Yeah, we're at the limit here. Stefan's been going.
Yeah.
Wait, Stefan's still on? Okay, we're done.
No, it was amazing.
So, yeah, it's amazing. Just keep an eye out. You can find us all online. Obviously, we've posted up all our links here. But thank you for participating and watching. We will cut up all the videos and post them again for reference in the future. And, watch for a Midwinter's Night conference, I guess, right?
I'm down.
Yeah, sure. Why not?
This was a blast.
We'll see if it's virtual or if it's in person or what, right? We'll depend. Just all depends this year. But
all right.
I see somebody put in our Twitter handles there, but nice. I love it.
Sweet. All right.
This is a lot of fun. Thank you all.
Yeah. Thanks, everybody. We'll catch everybody online.
All right. I'm going to end the broadcast.